Imagine you're part of the IT team of a medium-sized company that has recently migrated to cloud-based services. Your company has decided to use Azure Active Directory, frequently referred to as Azure AD, for identity and access management. However, the potential security risks involved are a cause for concern. You have several questions on how you'll be able to ensure the security of your company's resources. Can you be sure that Azure AD is configured securely and that there is no risk for data breaches? Do you think it's important to have a strategy to secure your network? In today's digital landscape, companies rely heavily on cloud platforms for storing and managing data. Therefore, it's crucial to have robust security measures, such as firewalls, in place to safeguard organizational resources against cyber threats. Understanding how to implement platform protection in Azure AD will help you protect sensitive and critical data and prevent security breaches. Hello, and welcome to Implement Platform Protection, the third course in the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. In this video, course introduction, you will gain an overview of what this course entails. I'm Ramanujam Srinivasan, and I've been a technologist for the last 25 years. I'm a certified cloud and security architect and help Fortune 500 companies formulate strategies and implement security solutions across identity, infrastructure, data, and applications. Wondering what's in it for you? In this course, you will learn about the core security concepts and how to implement platform protection in Azure AD. This course will enable you to review core security concepts that form part of the defense-in-depth approach. You will also explore how to enable and configure a distributed denial of service, frequently referred to as DDoS, protection implementation, and deploy an Azure Firewall. Did you know you can use virtual private networks, frequently referred to as VPNs, as part of your perimeter security strategy? You will learn how to do that and the steps to create user-defined routes and network virtual appliances to protect your perimeter. There's more about configuring network security groups, Azure application gateways, web application firewalls, and Azure Front Door. So let's discuss how the course is structured. The course content is divided into 4 weeks. In the first week, you will learn some of the perimeter level security tools Azure provides to help prevent attacks on your Azure solutions. You will also be introduced to the defense in depth and zero trust concepts to secure the Azure perimeter. You will gain insight into network security, firewalls, and tools to strengthen network protection in Azure. You will also learn about Azure Virtual Network Security, DDoS protection, and how to enable and configure it. Next, you will learn how to deploy Azure Firewall implementation and configure and deploy the Azure Firewall Manager. In week 1, you will also gain insight into securing your solutions using VPNs, network virtual appliances, frequently referred to as NVAs, and the Azure Network Virtual Appliances Firewall architecture. You will also learn to configure VPN-forced tunneling. As network security is an integral part of the defense-in-depth strategy, week 2 commences by introducing you to the deployment and configuration of network security groups. Next, you will learn how to implement an Azure application gateway to protect your perimeter and deploy a web application firewall. Finally, you will be introduced to the steps to configure and manage the Azure Front Door to define, manage, and monitor global routing of your web traffic. Going further, you will learn about using host security as part of your defense-in-depth strategy. This includes exploring how to configure and manage host security, container security, and Azure Kubernetes Service, frequently referred to as AKS networking. Week 3 delves deeper into how to deploy AKS storage. Lastly, it touches upon how to secure authentication to AKS with AD and manage access to it using Azure role-based access controls. The 4th week, which is the last week of this course, will be pretty interesting, as it allows you to practice hands-on with a course-level ungraded project. This week, you will brush upon your understanding of securing a custom container with Azure technologies. You will also recap all the concepts covered so far. This ungraded project will test your ability to apply most of the knowledge and skills you gained in this course. Lastly, you will attempt a course-level graded assessment, which will mimic the format of the AZ-500 exam. So, are you ready to start your journey? Let's begin mastering the skills to implement platform protection.
Cybersecurity threats have become increasingly sophisticated and rampant. With our lives becoming highly dependent on technology, it's become critical to safeguard your business's digital assets against unauthorized access, theft, or exploitation. One of the most effective ways of securing data is using the defense in depth strategy. So what exactly is defense in depth? How does this approach work to secure your online systems and data? Hello, and welcome to the video, Define Defense in Depth. In this video, you'll learn about the defense in depth approach and explore the core security concepts that are a part of it. As a security engineer, how can you implement security measures to protect your organization against various cyber threats? That's right. The answer is to always think of security in layers. Defense in depth is a strategy where you implement multiple layers of security measures to protect the organizational resources and digital assets against various types of threats. Let's explore this concept in detail. In an unfortunate event where a primary security control fails, the defense in depth approach includes additional controls incorporated in the design to mitigate risks to the organization. This design should consider the likelihood of the primary security control failing, the potential risk to the business if it does, and the effectiveness of the additional control. So, what's the solution to this looming risk of cyber threats and security issues? Microsoft designs and operates its cloud services with security at the core, and provides you with built-in controls and tools to meet your security needs. In addition, with machine learning, frequently referred to as ML, and significant investments by Microsoft in cyber defense, you can gain from unique intelligence and proactive security measures. How does this benefit your organization? Microsoft Azure offers unified security management and advanced threat protection for your resources in the cloud and on-premises. Did you know that all the services offered by Microsoft have multiple layers of protection to keep your data and apps safe? This includes virtual machines, frequently referred to as VMs, network rules, and physical security in their data centers. The sensors and systems that run Microsoft Azure are built to be secure while also allowing you to add customized security measures. An example of multiple layer security in case of a cyber threat is locking down the perimeter first and then working your way inward, locking down each layer. Let's look at an illustration of the defense in depth strategy. Still not convinced about the need for multiple layers of security? The bulk of a company's digital resources reside outside the corporate network, in the cloud, or on personal devices. Thus, it's clear that perimeter-only based security like firewalls, demilitarized zone, frequently referred to as DMZ, and virtual networks are no longer adequate. Adopting software-defining networking, frequently referred to as SDN, and software-defined data centers, frequently referred to as SDDC technologies, are driving network segmentation concepts to be more granular, that is, network microsegmentation. Let's dive deeper into this concept. Microsegmentation is a way to create secure zones and data centers and Azure deployments that allow you to isolate workloads and protect them individually. To do this, you can assign security policies and a virtual environment to virtual connections that can move with an application if the network is reconfigured. This helps to make the security policy persistent. Note that the best practice recommendation is to adopt the zero trust strategy based on user, device, and application identities. In contrast to network access controls based on elements such as source and destination IP addresses, protocols, and port numbers, zero trust enforces and validates access control at access time. What does that mean? Granting access at access time avoids the need to play the prediction game for an entire deployment, network, or subnet. In this case, only the destination resource must provide the necessary access controls. These access controls are Azure Network Security Groups, Application Security Groups, Azure Web Application Firewall and the Azure Firewall, and Local Admin Password Solution. Let's now look at these access controls in detail. Azure Network Security Groups can be used for basic Layer 3 and 4 access controls between Azure virtual networks, their subnets, and the Internet. Application Security Groups enable you to define fine-grained network security policies based on workloads and concentrated on applications instead of explicit IP addresses. Azure Web Application Firewall and the Azure Firewall can be used for more advanced network access controls that require application layer support. Local Admin Password Solution, frequently referred to as LAPS, is a third-party privileged access management tool used to set and manage strong local admin passwords of local administrator accounts on virtual machines. In addition, third parties offer micro-segmentation approaches that may enhance your network controls by applying zero-trust principles to networks that may have legacy assets. Let's summarize. In this video, you learned what is the defense in-depth approach, the importance of implementing multiple layers of security measures, how to use micro-segmentation to create secure zones in data centers and Azure deployments, and a best practice recommendation to adopt the zero-trust approach. Imagine that you're sitting in a coffee shop, browsing the internet on your laptop. Have you ever wondered how the page loads within seconds when you click a link to access a website? How does your laptop communicate with the website servers? Hello, and welcome to the video, Recap Network Client and Server Technology. In this video, you'll dive into the world of network client and server technology and uncover the secrets that make our online experiences possible. You'll also better understand the various client options and server models and options available. Let's begin with how the composition of a network is built. Servers are the workhorses of a network. Connections are achieved throughout a network through hubs, switches, and routers. This is true for your organization's network or more extensive networks like the web. So let's explore what network clients are. A network client is a lightweight computer or device that can't run programs on its own. This type of client is typically used to access and interact with a mainframe computer. As technology has advanced, a network client has transformed from a simple terminal and can now represent any hardware or software system that interacts with services made available on a server. This server is located elsewhere and accessed through a network. A client is part of the client-server model that's in use today. The three types of clients used in a client-server configuration are displayed on the screen. Next, let's understand each of these types of clients. Thick clients are the most common clients used and may be called workstations. It can process and store data locally without a server, and its interaction with a server is minimal and might only be to store data on a shared network drive. Thin clients are represented today by web applications that request and display information from servers regardless of their running device. Hybrid combines the best of both thick and thin clients. It can do limited local data processing but has no local storage capability. An example of a hybrid client is a device that renders content and stores the results on the server, like in automated rating systems. Now that you've understood network clients, the next question is, what are servers and server models? A server is a computer system or program that offers services or resources to other computers or programs, known as clients over a network. A server can refer to both the hardware and software components of the system, which are designed to enable sharing of data and resources among multiple clients. Now, let's understand what is meant by server hardware and software. A server's hardware is usually a high-end computer with dozens of CPUs or cores and vast amounts of memory. A server is associated with various switches, routers, load balancers, and firewalls. It usually runs server software, for example, Windows Server 2019 or Linux. Servers and server software expose various services and functions to network clients. A server supports multiple clients, and a client can connect to and use the services from multiple servers. For example, an application might use a media server to retrieve images and sound clips, but use a database server to pull data for display. Both services could be offered from the same server hardware, with each server service running as its own instance or virtual machine, frequently referred to as VM. There are three client-server models. The first one is request-response. In this model, the client sends a request to the server, and the server carries out an activity and sends back a response. The response is either the result of a request or an acknowledgement. Next is peer-to-peer, frequently referred to as P2P. In this model, every network device attached to the network is both a client and a server. Each client can request services, for example, files from any other device on the network and vice versa. P2P is an unstructured network suited for short-term usage. The third and last one is publish-subscribe. This model is a messaging pattern where clients subscribe to a service on the server. When a server receives a new message, it responds to each subscribed client. For example, really simple syndication, frequently referred to as RSS feed, is a publish-subscribe type of client server where the user subscribes to the feed and is automatically notified when new items appear. Now that you've understood what a server is and various client-server models, let's understand various server types. The table displayed here shows a broad range of servers, their usage, and the type of client that uses them. Next, let's go through the advantages and disadvantages of client-server networks. The advantages, for example, are all users are centrally managed, governing access and control to your servers and their services. If your server architecture is designed to scale, there are fewer performance issues when usage increases. All data can be stored and accessed centrally, reducing data duplication likelihood. Data is more easily safeguarded with centralized data storage to tape or other backup mediums. Some disadvantages of client-server networks are the failure of the server can block users from accessing resources. Because the resources are now centralized, any access disruption will affect all users. Setting up a client-server architecture can be expensive because it requires dedicated hardware and software. Running and maintaining a network requires IT professionals with dedicated technical knowledge. Multiple requests for the same operation affect the performance of the server, for example, in a denial of service attack. Finally, let's see what is available in Azure. Azure has several tools that can help you configure and manage clients and servers in your network. Two common Azure tools are Azure Resource Manager and Azure VMs. Let's understand them one by one. Azure Resource Manager. This is a management service that provides a means to organize and secure your organization's assets and resources. It uses declarative templates to manage your infrastructure and role-based access control, frequently referred to as RBAC, to improve the security and access your assets and resources. Azure VMs. This helps to implement a server without purchasing house server hardware. Virtualization provides the flexibility to have multiple dedicated servers within a cloud environment. Azure VMs will work with both the cloud and your on-premises network. They are scalable and will dynamically adapt to meet your organization's needs as you grow. In this video, you learned about what is a network client and the types of clients, servers and server models, various server types, advantages and disadvantages of client-server networks, and what's available in Azure.
Imagine you've just finished setting up your company's virtual network. It took you weeks to configure the security protocols, firewalls, and access controls to protect your organization's sensitive data. However, you receive a notification that your company's network has been breached. Isn't this your worst nightmare coming true? Unfortunately, this scenario is becoming quite common in today's virtual networking world. Cyber attacks are becoming more sophisticated and frequent. So the important question is, how can you protect your company's network from potential threats? Hello, and welcome to the video Explore Virtual Network Security. In this video, you will learn about virtual networks and their security, and then understand key Azure networking terminologies. As a security engineer, it is very important for you to understand various Azure networking components. Azure Virtual Networks are a key component of Azure Security Services. Let's explore this concept in detail. The Azure Network Infrastructure allows you to securely connect Azure resources to each other with virtual networks. A virtual network is a representation of your own network in the cloud. It is a logical isolation of the Azure Cloud Network dedicated to your subscription. Remember that you can connect virtual networks to your on-premises networks as well. But the question is, how does this work? Azure supports dedicated wide area network link connectivity between your on-premises network and an Azure virtual network with ExpressRoute. The wide area network is frequently referred to as WAN. The link between Azure and your site uses a dedicated connection that does not go over the public internet. If your Azure application is running in multiple data centers, you can use Azure Traffic Manager to intelligently route requests from users of the application. You can also route traffic to services not running in Azure if they are accessible from the internet. Next, let's understand why virtual networks are needed. Organizations can use virtual networks to connect resources. In Azure, virtual networks are network overlays that you can use to configure and control connectivity among Azure resources, such as Azure Virtual Machines, frequently referred to as VMs, and load balancers. Azure Virtual Network enables many types of Azure resources, such as Azure VMs, to securely communicate with each other, the internet, and on-premises networks. A virtual network is scoped to a single Azure region. Wondering what that is? An Azure region is a set of data centers deployed within a latency-defined perimeter and connected through a dedicated regional low-latency network. Now, let's explore subnets. Virtual networks are made up of subnets. A subnet is a range of internet protocols, frequently referred to as IP addresses, within your virtual network. You can implement multiple virtual networks within each Azure subscription and Azure region. However, it's important to note that a virtual network is isolated from other virtual networks. For each virtual network, you can specify a custom private IP address space using public and private addresses, Azure assigns resources in a virtual network to a private IP address from the address space you assign. Segment the virtual network into one or more subnets and allocate a portion of the virtual network's address space to each subnet. Use an Azure-provided name resolution or specify your own domain name system, frequently referred to as a DNS server, for use by resources in a virtual network. Now that you have gained insight into virtual networks, let's explore IP addresses. VMs, Azure load balancers, and application gateways in a single virtual network require unique IP addresses the same way clients in an on-premises subnet do. This enables these resources to communicate with each other. A virtual network uses two types of IP addresses, private and public. Let's understand each of these in detail. Private. A private IP address is dynamically or statically allocated to a VM from the defined scope of IP addresses in the virtual network. VMs use these addresses to communicate with other VMs in the same or connected virtual network through a gateway or Azure ExpressRoute connection. These private IP addresses or non-routable IP addresses conform to RFC 1918. Public. Public IP addresses which allow Azure resources to communicate with external clients are directly assigned to the virtual network adapter of the VM or the load balancer. A public IP address can also be added to Azure-only virtual networks. All IP blocks in the virtual network will be routable only within the customer's network. They won't be reachable from outside. Virtual network packets travel through the high-speed Azure backplane. A high-speed Azure backplane refers to the network infrastructure that connects the various components and services within the Microsoft Azure cloud computing platform. You can control the dynamic IP addresses assigned to VMs and cloud services within the Azure virtual network by specifying an IP addressing scheme. IP addressing schemes are used to uniquely identify and communicate with devices on a network. Planning an IP addressing scheme within an Azure virtual network is much like planning an IP addressing scheme on premises. The same ranges are often used and the same rules apply. However, conditions exist that are unique to Azure virtual networks. You can further divide your network using subnets for the logical and security-related isolation of Azure resources. Each subnet contains a range of IP addresses that fall within the virtual network address space. What is the benefit of using subnets? Subnetting hides internal network organization details from external routers. Subnetting also segments the host within the network, making it easier to apply network security at the interconnections between subnets. Finally, another key term you should be familiar with is network adapter. VMs communicate with other VMs and other resources on the network using virtual network adapters. These adapters configure VMs with private and optionally public IP addresses. A VM can have more than one network adapter for different network configurations. Let's recap. In this video, you learned about Azure networking components, virtual networks, the importance of IP addresses and their types, subnets, and the benefits of using network adapters.
Imagine you're a security engineer in a fast-growing technology startup. Your company relies on cloud-based services and remote employees to stay agile and competitive. But you're concerned about the security risks that come with this approach. To address these concerns, you decided to implement a perimeter network that can provide robust protection for your network while allowing your employees and cloud-based services to function effectively. You have also been advised to use the concepts of defense in depth and the zero trust model to secure your Azure perimeter. Hello, and welcome to the video, Perimeter Protection as Part of Your Defense Strategy. In this video, you'll be introduced to the concept of perimeter networks and then delve deeper into the concepts around perimeter protection as a defense strategy. Let's begin by understanding the definition of perimeter networks. Perimeter networks, or demilitarized zones, frequently referred to as DMZs, help provide secure connectivity between cloud networks, on-premises, or physical data center networks, and the internet. In secure perimeter networks, incoming packets flow through security appliances hosted in secure subnets before the packets can reach back-end servers. Now, what do security appliances mean? Security appliances include firewalls, network virtual appliances, frequently referred to as NVAs, and other intrusion detection and prevention systems. Internet-bound packets from workloads must also flow through security appliances in the perimeter network before they can leave the network. Usually, the central IT teams and security teams are responsible for defining operational requirements for perimeter networks. One of the key benefits of perimeter networks is that they can provide policy enforcement, inspection, and auditing. Perimeter networks can use the following Azure features and services. For example, virtual networks, user-defined routes, and network security groups, frequently referred to as NSGs. Azure Firewall, Azure Web Application Firewall on Azure Application Gateway, Azure Web Application Firewall on Azure Front Door, other NVAs, Azure Load Balancer, and public IP addresses. Next, let's understand the perimeter network topology. The diagram displayed on the screen shows an example hub and spoke network with two perimeter networks that enforce access to the internet and to an on-premises network. Both perimeter networks are in the DMZ hub. In the DMZ hub, the perimeter network to the internet can scale up to support many lines of business. This support uses multiple farms of web application firewalls, frequently referred to as WAFs, and Azure Firewall instances that help protect the spoke virtual networks. The DMZ hub allows connectivity via a virtual private network, frequently referred to as VPN or Azure ExpressRoute as needed. The next service you'll learn about is virtual networks, and you've already seen a video on it. To recap, perimeter networks are typically built within virtual networks. The virtual network uses multiple subnets to host different types of services that filter and inspect traffic to or from other networks or the internet. Next, in a hub and spoke network topology, you must ensure that traffic generated by virtual machines, frequently referred to as VMs, in the spokes passes through the correct virtual appliance in the hub. This traffic routing requires user-defined routes in the subnets of the spokes. How do these user-defined routes help you? These routes can guarantee that traffic passes through specified custom VMs, NVAs, and load balancers. You can also use user-defined routes to direct traffic through firewalls, intrusion detection systems, and other virtual appliances. Another Azure service that protects your company's digital assets against cyber attacks is an Azure Firewall. This firewall is a managed cloud-based firewall service that helps protect your resources in virtual networks. Azure Firewall has built-in high availability and unrestricted cloud scalability and can be used to centrally create, enforce, and log application and network connectivity policies across subscriptions and virtual networks. Besides this, you can also manage perimeter networks with access to the internet through Azure Firewall or Farm of Firewalls or WAFs. An Azure Firewall instance and an NVA firewall can use a common administration plane with a set of security rules. Azure Firewall has built-in scalability, and NVA firewalls can be manually scaled behind a load balancer. Next, Azure Load Balancer offers a high availability Layer 4 transmission control protocol or user datagram protocol, frequently referred to as TCP/UDP load balancing service. This service can distribute incoming traffic among service instances defined by a load balancing set. Azure Load Balancer can redistribute traffic from front-end public or private IP endpoints with or without address translation to a pool of back-end IP addresses like NVAs or VMs. Another service to note is Azure Front Door, which is a highly available and scalable web application acceleration platform and global HTTPS load balancer. You can use Azure Front Door to build, operate, and scale out your dynamic web application and static content. Next, Application Gateway is a dedicated virtual appliance that gives you a managed application delivery controller. It offers various Layer 7 load balancing capabilities for your application and helps you optimize web farm productivity by offloading CPU-intensive secure socket layer SSL termination. Finally, with some Azure features, you can associate service endpoints to a public IP address. This option provides access to your resource from the internet. The endpoint uses network address translation, NAT, to route traffic to the internal address and port on the Azure Virtual Network. This path is the main way for external traffic to pass into the virtual network. You can configure public IP addresses to control what traffic passes in and how and where it's translated into the virtual network. Let's summarize. In this video, you learned about what is a perimeter network network topology, virtual networks, user-defined routes, Azure Firewall, network virtual appliances, Azure Load Balancer, Azure Front Door, application gateways, and public IPs. An e-commerce site was hit with a distributed denial of service attack, frequently referred to as DDoS attack, bringing their website down. However, the company had implemented robust DDoS protection, which helped them identify the attack and block the malicious traffic in real time. Hello, and welcome to the video, Enable Distributed Denial of Service DDoS Protection. In this video, you'll learn about the importance of having a robust DDoS protection to safeguard against denial of service, frequently referred to as DOS, attacks, and how to enable a DDoS protection implementation. So let's first understand what a DOS attack is. DOS is an attack that has the goal of preventing access to services or systems. In case a DOS attack happens in your organization, check if the attack is originating from one or more locations. If the attack originates from one location, it is called a DOS. However, if the attack originates from multiple networks and systems, it's called a DDoS. Now that you know what DDoS is, let's understand what botnets are. Botnets are collections of internet-connected systems that individuals control and use without their owner's knowledge. Botnet owners use them to perform various actions of their choice. For example, botnets are used for spamming, data storage, DDoS, or various other actions that are up to the person in control of the botnet. Did you know that in the past, botnets were made up just of compromised computers? However, now botnets are also made up of the Internet of Things, frequently referred to as IoT devices. Malicious hackers can get these poorly secured security cameras, digital video recorders, thermostats, and other internet-connected devices under their control. So let's dive deeper into what DDoS is. DDoS is a collection of attack types aimed at disrupting the availability of a target. These attacks involve a coordinated effort that uses multiple internet-connected systems to launch many network requests against domain name system, frequently referred to as DNS, web services, email, and more. Almost any application that the malicious hacker can access might become the target of a DDoS. The goal of such hackers is to overwhelm the system resources on targeted servers, so they can no longer process legitimate traffic, effectively making the system inaccessible. A DDoS generally involves many systems sending traffic to targets as part of a botnet. In most cases, the owners of the systems in a botnet don't know that their devices are compromised and participating in an attack. Botnets are becoming a bigger problem than before because of the increasing number of connected devices. So, what can be done? Designing and building for DDoS resiliency requires planning and designing for a variety of failure modes. Let's look at the best practices that can be used to build DDoS-reliant services in Azure. The first best practice is to ensure that security is a priority throughout the entire lifecycle of an application. From design and implementation to deployment and operations, applications might have bugs that allow a relatively low volume of requests to use a lot of resources, resulting in a service outage. So, what's the solution? To help protect a service running in Azure, first understand your application architecture and focus on the 5 pillars of software quality. Let's take a look at what these 5 pillars are. The first one is scalability, which is the ability of a system to handle increased load. Next is availability, which refers to the proportion of time that a system is functional and working. Third is resiliency, which means the ability of a system to recover from failures and continue to function. Next is management, which entails operations processes that keep a system running in production. The fifth and last one is security, which refers to protecting applications and data from threats. Besides the 5 pillars, you should know typical traffic volumes, the connectivity model between the application and other applications, and the service endpoints that are exposed to the public internet. Helping ensure that an application is resilient enough to handle a DOS targeted at the application itself is most important. Security and privacy features are built into the Azure platform, beginning with the Microsoft Security Development Lifecycle, frequently referred to as SDL. The SDL addresses security at every development phase and ensures that Azure is continually updated to make it even more secure. The second best practice recommends designing your applications to scale horizontally to meet the demands of an amplified load, specifically in the event of a DDoS. If your application depends on a single instance of a service, it creates a single point of failure. Provisioning multiple instances makes your system more resilient and scalable. So, what's the solution here? For Azure App Service, select an app service plan that offers multiple instances. For Azure Cloud Services, configure each of your roles to use multiple instances. For Azure Virtual Machines, ensure that your VM architecture includes more than one VM, and that each VM is included in an availability set. It is recommended that you use virtual machine scale sets for auto-scaling capabilities. The next best practice is to layer security defenses in an application to reduce the chance of a successful attack. You should implement security-enhanced designs for your applications by using the built-in capabilities of the Azure platform. As a solution, you should be aware that the risk of an attack increases with the size or surface area of the application. You can reduce the surface area by using IP allow lists to close down the exposed IP address space and listening ports that aren't needed on the load balancers, for example, Azure Load Balancer and Azure Application Gateway. You can also use network security groups, frequently referred to as NSGs, to reduce the attack surface. In addition, you can use service tags and application security groups as a natural extension of an application structure to minimize the complexity of creating security rules and configuring network security. We've reached the end of this video. In this video, you learned about a DOS attack. What is a DDoS attack? What are botnets made up of? The 5 pillars of software quality and the best practices for building DDoS resilient services in Azure. Imagine you work as a network security engineer with a financial technology company operating an online payment system. The company's been battling distributed denial of service attacks, frequently referred to as DDoS attacks, causing significant disruptions to its payment processing services. As a part of your job responsibilities, you must set up DDoS protection to safeguard the company's website or online service against the attacks which are overloading its servers and bringing down the site. Hello, and welcome to the video, Configure a Distributed Denial of Service Protection Implementation. In this video, you'll learn about Azure DDoS Protection Service tiers, how Azure Denial of Service Protection works, and the types of denial of service attacks that Azure Protection mitigates. Let's begin with what Azure DDoS Protection Service tiers are. The combination of Azure DDoS Protection and application design best practices helps you provide defense against DDoS attacks. The protection levels in Azure DDoS are basic and standard service tiers. Both service tiers provide protection for IPv4 and IPv6 Azure public IP addresses. Let's first understand the basic service tier. It is enabled automatically as part of the Azure platform. It provides you with defenses like always-on traffic monitoring and real-time mitigation of common network-level attacks, which are also utilized by Microsoft's online services. With basic protection, you can distribute and mitigate attack traffic across the entire scale of Azure's global network. On the other hand, the standard service tier provides you with additional mitigation capabilities over the basic one. The mitigation capabilities are tuned specifically to Azure Virtual Network resources. You can easily enable the DDoS protection standard as it requires no application changes. Protection policies are tuned through dedicated traffic monitoring and machine learning algorithms. These policies are applied to public IP addresses associated with resources deployed in virtual networks, such as Azure Load Balancer, Azure Application Gateway, and Azure Service Fabric instances, but this protection does not apply to app service environments. Let's look at the defense options in the standard service tier against DDoS attacks. You can use real-time telemetry through Azure Monitor views during an attack and for history. You can also use rich attack mitigation analytics via diagnostic settings. You can add application layer protection through the Azure Application Gateway Web Application Firewall. You can also do this by installing a third-party firewall from Azure Marketplace in a virtual network with a public IP. This way, DDoS Protection Standard can provide full Layer 3 to Layer 7 mitigation capability. Now we'll look at how Azure Denial of Service Protection works. DDoS Protection Standard monitors actual traffic utilization and constantly compares it against the thresholds defined in the DDoS policy. When the traffic threshold is exceeded, DDoS mitigation is automatically initiated. When traffic returns to a level below the threshold, the mitigation is removed. Let's look at a diagram to understand this. The diagram depicts customers using the Azure portal or a virtual network to get DDoS protection standard, which uses public IP addresses for policy generation. The policy causes information about network utilization, detected anomalies, and initiated mitigations for each public IP address to be generated. Do you know what happens in DDoS protection during mitigation? It redirects traffic sent to the protected resource and performs several checks, including helping ensure that packets conform to internet specifications and aren't malformed, interacting with the client to determine if the traffic might be a spoofed packet, for example, dropping a packet for the source to retransmit it, using rate limit packets if it can't perform any other enforcement method. Now let's look at how Azure Monitor works. DDoS protection blocks attack traffic and forwards the remaining traffic to its intended destination. Within a few minutes of attack detection, you'll be notified with Azure Monitor metrics. By configuring logging on DDoS protection standard telemetry, you can write the logs to available options for future analysis. Azure Monitor retains metric data for DDoS protection standard for 30 days. Next, we'll talk about the types of denial of service attacks that Azure Protection mitigates. DDoS protection standard can mitigate volumetric attacks, protocol attacks, and resource or application layer attacks. Let's look at volumetric attacks first. Its goal is to flood the network layer with a substantial amount of seemingly legitimate traffic. It includes user datagram protocol, frequently referred to as UDP floods, amplification floods, and other spoofed packet floods. So how do we mitigate these attacks? DDoS Protection Standard automatically mitigates these potential multi-gigabyte attacks by absorbing and scrubbing them with Azure's global network scale. Next are the protocol attacks. These attacks render a target inaccessible by exploiting a weakness in the Layer 3 and Layer 4 protocol stack. It includes SYN flood attacks, reflection attacks, and other protocol attacks. So is it possible to mitigate these attacks? The answer is yes. DDoS Protection Standard mitigates these attacks by differentiating between malicious and legitimate traffic. It does this by interacting with the client and blocking malicious traffic. And the third type of denial of service attack is the resource or application layer attack. These attacks target web application packets to disrupt the transmission of data between hosts. The attacks include HTTP protocol violations, SQL injection, cross-site scripting, and other Layer 7 attacks. You can mitigate these attacks by using a web application firewall, frequently referred to as WAF, such as the Azure Application Gateway Web Application Firewall, as well as DDoS Protection Standard to provide defense against these attacks. You can also use third-party web application firewall offerings available in the Azure Marketplace. Let's summarize. In this video, you've learned about Azure DDoS Protection Service tiers, how Azure Denial of Service Protection works, and types of denial of service attacks that Azure Protection mitigates.
Suppose you are a company's IT administrator who just received an email from the security team about a potential security breach. Your company's network infrastructure has different types of components and various types of traffic flow through the system, such as web traffic, email traffic, and database traffic. You know that your company's network security needs an overhaul, but the issue is that you don't know where to start. Fortunately, you can use some of the key features of Azure Firewall to provide network security services and control over network traffic. Hello, and welcome to the video Explore Azure Firewall Features. In this video, you'll learn about Azure Firewall and its features. You will also learn about the types of Azure Firewall rules and how they work. We will begin with understanding what Azure Firewall is. Azure Firewall is a managed cloud-based network security service that protects your Azure virtual network resources. It's a fully stateful firewall as a service with built-in high availability and unrestricted cloud scalability. By default, Azure Firewall blocks traffic. In this diagram, we can see that Azure Firewall provides L3 to L7 filtering, and threat intelligence feeds directly from Microsoft cybersecurity. Threat intelligence-based filtering can alert and deny traffic from or to known malicious IP addresses and domains that are updated in real time to protect against new and emerging attacks. In the diagram, Azure Firewall is in the middle. Bidirectional arrows show communication with two-spoke VNets and an on-premises office building. Depending on how you have configured your firewall features, the traffic flows between the internet and the firewall, but other traffic is denied. As an IT administrator, it is very important for you to understand the features of Azure Firewall. Let's explore some of the features one by one. First, the Azure Firewall has built-in high availability. Because high availability is built in, you do not require additional load balancers. Do you know what the best part of this feature is? To use this feature, you are not required to configure anything. Isn't it amazing? The next feature is unrestricted cloud scalability. This feature helps you to scale up as much as you need to accommodate changing network traffic flows, so you don't need to budget for your peak traffic. The third feature is that Azure Firewall has application fully qualified domain name, frequently called FQDN filtering rules. With this feature, you can limit outbound HTTPS traffic to a specified list of FQDNs, including wildcards. This feature does not require a secure sockets layer, commonly known as SSL termination. The next feature is the network traffic filtering rules. Using this feature, you can centrally create, allow, or deny network filtering rules by source and destination IP addresses, port, and protocol. Azure Firewall is fully stateful, distinguishing legitimate packets for different types of connections. Network traffic filtering rules are enforced and logged across multiple subscriptions and virtual networks. The fifth feature is qualified domain tags. By using fully qualified domain names or FQDN tags, you can easily allow well-known Azure service network traffic through your firewall. For example, say you want to allow Windows Update network traffic through your firewall. you create an application rule and include the Windows Update FQDN tag. Now, network traffic from Windows Update can flow through your firewall. The next Azure Firewall feature is support for outbound source network address translation, frequently called OSNAT. Using this feature, you can translate all outbound virtual network traffic IP addresses to the Azure Firewall public IP. You can identify and allow traffic originating from your virtual network to remote internet destinations. Then we have inbound destination network address translation, frequently referred to as DNAT support. With this feature, you can translate and filter the inbound network traffic on your firewall's public IP address to the private IP addresses on your virtual networks. The eighth feature is Azure Monitor Logging. Using this feature, you can integrate all events with Azure Monitor. This allows you to archive logs to a storage account, stream events to your Event Hub, or send them to the Azure Monitor logs. The next feature that we will look at is forced tunneling. You can configure Azure Firewall to route all internet-bound traffic to a designated next hop instead of going directly to the internet. For example, you may have an on-premises edge firewall or another network virtual appliance, frequently referred to as NVA, to process network traffic before it's passed to the internet. The Azure Firewall also has some premium features. Let's look at them. The first feature is Transport Layer Security, frequently referred to as TLS, inspection. This feature helps you to decrypt outbound traffic, process the data, and then encrypt the data. After encryption, the data is sent to the destination. The next feature is the Intrusion Detection and Prevention System, commonly known as IDPS. A network IDPS allows you to monitor network activities for malicious activity, log information about this activity, report it, and attempt to block it optionally. Now let's look at the URL filtering feature. This feature allows you to extend Azure Firewall's FQDN filtering capability to consider an entire URL along with any additional path. For example, www.contoso.com/a/c instead of www.contoso.com. The next feature is the Azure Firewall's web categories. With this feature, as an IT administrator, you can allow or deny user access to website categories such as gambling websites and social media websites. Next, we are going to learn about Azure Firewall rules. Grouping the Azure Firewall features into logical groups reveals that Azure Firewall has three rules: network address translation, frequently called NAT, rules, network rules, and application rules. So how do these rules work? The application order precedence for the rules is that network rules are applied first and then the application rules. Rules are terminating, which means if a match is found in network rules, then application rules are not processed. If there's no network rule match and the packet protocol is HTTP or HTTPS, the application rules evaluate the packet. If no match continues to be found, then the packet is evaluated against the infrastructure rule collection. If there's still no match, then that packet is denied by default. Now let's learn to configure NAT rules. You can configure inbound connectivity by configuring Destination Network Address Translation DNAT. You can use the Azure portal to filter inbound traffic with Azure Firewall DNAT. To do that, DNAT rules are applied first. If a match is found, an implicit corresponding network rule to allow the translator traffic is added. You can override this behavior by explicitly adding a network rule collection with deny rules that match the translator traffic. Do you think application rules are applied after no match is found? That's right. The answer is no. The application rules are not applied for these connections. An important part of your overall network security plan is to control outbound and inbound network access. Network traffic is subjected to the configured firewall rules when you route your network traffic to the firewall as a default gateway. Let's recap. In this video, you learned about Azure Firewall and its features, types of Azure Firewall rules, and how Azure Firewall rules work.
Imagine you own a small startup company that has just moved its operations to the cloud. Your company hosted various resources on Azure, from web applications to databases to virtual machines or VMs. However, you soon realized that you needed to take security seriously to protect your data and prevent any unwanted access. One of your team members had heard about Azure Firewall, a cloud-based firewall service that could help you manage and filter your network traffic. You decided to give it a try, but had no idea where to start. Hello, and welcome to the video, Deploy an Azure Firewall Implementation. In this video, you will learn how to control outbound network traffic from an Azure subnet and set up a test network environment for deploying the Azure Firewall. You will also learn to configure application, network, and network address translation, or NAT rules. Finally, you'll look at the process of testing the firewall. Let's first understand how to control outbound network traffic. Controlling outbound network access is an important part of your overall network security plan. For example, you may want to limit access to websites, or you may want to limit the outbound IP addresses and ports that can be accessed. Wondering how to do that? One way you can control outbound network access from an Azure subnet is with Azure Firewall. With Azure Firewall, you can configure application rules that define fully qualified domain names, frequently referred to as FQDNs, can be accessed from a subnet. And network rules define source address, protocol and destination port, and destination address. Network traffic is subjected to the configured firewall rules when you route your network traffic to the firewall as the subnet default gateway. Let's look at a diagram to understand how the Azure Firewall works. In the diagram, an Azure Firewall is present in the middle. The firewall provides full Layer 3 to Layer 7 connectivity policies. The bidirectional arrows show the firewall's communication with two-spoke VNets in an on-premises office building. The firewall allows the network traffic, adhering to the policies, to flow between the internet and the firewall. The traffic that does not adhere to the policies is denied flow. One of the Azure Firewall features is that you can monitor the firewall using firewall logs. You can also use activity logs to audit operations on Azure Firewall resources. You can access some of these logs through the portal. Logs can be sent to Azure Monitor Logs, storage, and event hubs and analyzed in Azure Monitor Logs or by tools such as Excel and Power BI. On the other hand, metrics are lightweight and can support near real-time scenarios, making them useful for alerting and fast issue detection. The Azure Firewall features require configuration, but before that, you need to deploy Azure Firewall. To deploy the Azure Firewall, you first need to set up a test network environment, then deploy a firewall and firewall policy. After that, you'll create a default route and then configure an application rule to allow access to a website, www.google.com, for example. Then you're going to configure a network rule to allow access to external DNS servers and a NAT rule to allow a remote desktop to the test server. Finally, you'll test the firewall. Let's understand this process by looking at each of these steps in detail. To set up the network on your Azure portal, you'll first create a resource group to contain the resources needed to deploy the firewall. Then you'll enter or select these settings and values to create the resource group. Now you'll create a VNet, subnets, and a test server. For easy deployment, you must create a simplified single VNet with two subnets. The first is Azure Firewall subnet. The firewall is in this subnet. The second is the workload SN. The workload server is in this subnet. This subnet's network traffic goes through the firewall. To create the VNet, on the Azure portal menu, search for virtual networks and select virtual networks in the result pane. During the creation process, you'll enter or select these values to create the VNet. To finish setting up your network, you'll create the workload virtual machine and place it in the workload SN subnet. On the Azure portal menu, select Create a Resource. During the creation process, you need to enter or select these values for the virtual machine. The next step is to deploy the firewall into the created VNet. On the Azure portal, you need to select Create a Resource. Then on the Create a Firewall page, you will use the following table to configure the firewall. The firewall deployment takes a few minutes. Now you want to ensure that the network traffic goes through the firewall. For the workload SN subnet, you must configure the outbound default route to go through the firewall. To create this default route, you'll select All Services on the Azure portal. Then under Networking, select Route Tables. Then you'll create the route by entering or selecting the following values. After creating the route table and deployment completion, you'll select Go to Resource to add the route by following these steps. After adding the default route, it's time for one of the most important settings of Azure Firewall implementation. That is to configure the firewall rules. First, we'll see how to configure an application rule. The application rule will allow outbound access to www.google.com. You can follow these steps to configure this application rule for other websites as well. Azure Firewall includes a built-in rule collection for infrastructure for FQDNs that are allowed by default. These FQDNs are specific to the platform and can't be used for other purposes. Similarly, you can also configure a network and DNAT rule by following these steps. This network rule allows outbound access to two IP addresses at port 53, a domain name system or DNS. And this DNAT rule allows you to connect a remote desktop to the SRV work virtual machine through the firewall. After firewall rules are configured, you will change the primary and secondary DNS address for the SRV work network interface. This is not a general requirement, but is only done for testing purposes. These primary and secondary IP addresses are the two DNS servers allowed while configuring the network rules. To change these DNS addresses, you'll select resource groups on the Azure portal and follow these steps. Finally, you're going to test the deployed firewall. To do so, you'll first connect a remote desktop to firewall public IP address and sign into the SRV Work virtual machine. Now open your Edge browser and browse to www.google.com. You should see the Google homepage. Now when you try browsing any other websites, you should be blocked by the firewall. Let's recap. You have learned about controlling outbound network traffic from an Azure subnet, setting up a test network environment for deploying the Azure Firewall, configuring application network and NAT rules, and the process of testing the firewall. Imagine you own a logistics operations company. Your company helps your clients move their goods from one place to another. It also ensures that the goods reach their destination safely and on time. A lot of traffic and data flow through your logistics systems. As your company grows, you want to create a security perimeter with strong security measures and technologies to safeguard sensitive information and prevent cyber attacks. These perimeters can control traffic flow to and from hosted apps and other resources. However, it might become difficult to manage these security technologies. How can you simplify the management of your cloud-based security? Use Azure Firewall Manager to centralize your firewall security policies and route management for your cloud-based security perimeters. Hello, and welcome to the video, Overview of Azure Firewall Manager. In this video, you'll learn what Azure Firewall Manager is and what centralized firewall management is. You'll also learn about the features of Azure Firewall Manager and the types of architecture needed to implement Firewall Manager. To understand the need for Azure Firewall Manager, let's consider an example scenario. Suppose your company has resources distributed across multiple Azure virtual networks and multiple Azure regions. You might decide to configure Azure Firewall, a managed cloud-based security device. A firewall can help protect resources in virtual networks. As your needs evolve, you'll want to implement additional Azure Firewall instances. Each should have similar rules governing traffic flow. Management becomes more difficult when you have a more complex virtual network, virtual wide area network, commonly known as VAN, and firewall settings. So you must be wondering how you can control and manage these components together. This is where the Firewall Manager comes to your rescue. It enables you to centrally manage these components and more easily control your cloud-based security perimeters. So what is centralized firewall management? It means you can manage multiple firewalls simultaneously. It can be challenging for you to maintain multiple firewalls individually. As your security needs change, you might need to reconfigure all your firewalls to ensure their settings are in sync. Similarly, if your security needs to expand, you might need to update all of your firewalls. Using Firewall Manager simplifies firewall management. After going through the basic learning, let's now define the Firewall Manager. Azure Firewall Manager enables you to centralize the management of multiple instances of Azure Firewall. Azure Firewall is a cloud-based network security service that's fully managed by a firewall global admin by centralizing the management of firewall policies. By implementing Azure Firewall, you can help protect your Azure resources and route management for your cloud-based security perimeters. Your security team must configure and maintain network and application-level rules for traffic filtering. If your organization has multiple Azure Firewall instances, you'll benefit from centralizing these configurations. Firewall Manager enables you to centralize firewall management, span multiple Azure subscriptions, span different Azure regions, implement hub and spoke architectures to provide for traffic governance and protection. When managing firewalls, you're also required to apply the firewall policy. Firewall policy is the fundamental building block of Firewall Manager. A firewall policy can consist of network address translation, also called NAT settings, network rule collections, application rule collections, threat intelligence settings. You apply firewall policies to firewalls. After you create policies, you can associate them with one or more virtual networks or virtual hubs. You can create and manage Azure Firewall policies by using the Azure portal, Representational State Transfer Application Program Interface, also known as REST API, templates, Azure PowerShell, and Azure Command Line Interface, frequently referred to as Azure CLI. Now let's look at how you can centrally manage your firewalls. For this, first you need to configure and deploy the Firewall Manager with the following features. The first is centralized deployment and configuration. This feature allows you to configure multiple Azure Firewall instances. These multiple instances can potentially span Azure subscriptions and regions. The next feature is centralized route management. This feature helps you bypass the requirement of manually creating user-defined routes on spoke virtual networks. Centralized route management is only available on secured virtual hub and architecture. Next, we'll look at hierarchical policies. These enable you to centrally manage Azure Firewall policies across multiple secured virtual hubs. Your IT security team can then create global firewall policies and apply them across your organization. The fourth feature that Firewall Manager allows you to do is third-party integration. This supports the integration of third-party security as a service provider. Then you have cross-region availability. This feature allows you to create Azure Firewall policies in one region and apply them in other regions. Now let's look at the sixth feature, Distributed Denial of Service, frequently referred to as DDoS Protection Plan. This plan offers enhanced DDoS mitigation capabilities via adapting tunneling, attack notification, and telemetry to protect against DDoS attacks. You can easily associate your virtual networks with a DDoS protection plan with Azure Firewall Manager. The last feature we'll look at is managing Web Application Firewall, also called WAF, policies. With this feature, you can centrally create and associate WAF policies for your application delivery platforms, including Azure Front Door and Azure Application Gateway. Now let's look at the two architectures that you can use to implement a Firewall Manager: Hub Virtual Network and Secured Virtual Hub. So what is a Hub Virtual Network? It's a standard Azure virtual network that you create and manage. When you associate firewall policies with this type of hub, you're creating a Hub Virtual Network. This architecture's underlying resource is a virtual network. On the other hand, a Secured Virtual Hub is a Microsoft-managed resource that enables you to easily create hub and spoke architectures. When you associate firewall policies, you're using a Secured Virtual Hub. The underlying resource is a virtual WAN hub. Let's look at a diagram depicting these architecture types. A firewall global admin has overarching policy control over an organization's security policies. These policies are applicable to all Azure regions. Say Region 1 has a Secured Virtual Hub with associated firewall policies. It is bidirectionally connected to a third-party security provider, the headquarter or HQ, and the end user. Another Region N has a Hub Virtual Network with associated firewall policies. A local admin has some control over policies associated with the Hub Virtual Network. It is bidirectionally connected to the data center. Let's recap. In this video, you learned about Azure Firewall Manager, centralized firewall management, features of Azure Firewall Manager, and architecture types to implement Firewall Manager.
Suppose you are working as an IT administrator at a global financial institution. You have been given the responsibility to migrate its on-premises infrastructure to the Azure cloud. As part of the migration strategy, you're planning to deploy critical financial systems and sensitive customer data on Azure. Azure helps you address the perceived risk of resources sharing by providing a trustworthy foundation for assuring logically isolated cloud services using a common set of principles. One of these principles is network isolation. Hello, and welcome to the video Network Isolation and Security. In this video, you will learn about the key aspects related to network isolation. You will also learn about the Azure VNets, key protections to secure traffic between tenants. So how can you ensure network isolation and security during their migration to Azure? For this, let's look at the key aspects of network isolation. The logical isolation of tenant infrastructure in a public multi-tenant cloud is fundamental to maintaining security. The overarching principle for a virtualized solution is to allow only connections and communications that are necessary for that virtualized solution to operate, blocking all other ports and connections by default. So which aspect can help you achieve this? The first aspect is the separation of tenant network traffic. Azure Virtual Network, also known as VNet, helps ensure that your private network traffic is logically isolated from traffic belonging to other customers. Services can communicate using public IPs or private IPs. Communication between your virtual machines, also known as VMs, remains private within a VNet. You can connect your VNets via VNet peering or VPN gateways, depending on your connectivity options, including bandwidth, latency, and encryption requirements. The second aspect you can use is the network security groups or NSGs. They help you achieve network isolation and protect your Azure resources from the internet while accessing Azure services that have public endpoints. Next, you can use virtual network service tags to define network access controls on network security groups or Azure Firewall. A service tag represents a group of IP address prefixes from a given Azure service. Microsoft manages the address prefixes encompassed by the service tag and automatically updates the service tag as addresses change, thereby reducing the complexity of frequent updates to network security rules. You can also use private link to access the Azure Platform as a Service, also known as PaaS, over a private endpoint in your VNet. This ensures that traffic between your VNet and the service travels across a Microsoft global backbone network. This further eliminates the need to expose the service to the public internet. Finally, Azure provides you with options to encrypt data in transit. Data encryption in transit isolates your network traffic from other traffic and helps protect data from interception. This includes transport layer security, also known as TLS, end-to-end encryption of network traffic with TLS termination using key vault certificates, VPN encryption using IPsec, and Azure ExpressRoute encryption using MACsec with customer managed keys, also known as CMK support. Azure VNets implements several mechanisms to ensure secure traffic between tenants. These mechanisms align with existing industry standards and security practices and help you prevent well-known attack vectors. Let's look at these attack vectors one by one. Firstly, Azure VNets help you prevent IP address spoofing. Whenever a VNet transmits encapsulated traffic, the service re-verifies the information on the receiving end of the transmission. This verification is done with an internal VNet feature called SpoofGuard, which verifies that the source and destination are valid and allowed to communicate, thereby preventing mismatches in expected encapsulation patterns that might otherwise permit spoofing. Secondly, Azure VNet provides network segmentation across customers with overlapping network spaces. Azure VNet's implementation relies on established tunneling standards such as the generic routing encapsulation, also known as GRE, which in turn allows the use of customer-specific unique identifiers called VNet IDs throughout the cloud. The VNet identifiers are used as scoping identifiers. This approach ensures that you're always operating within your unique address space, overlapping address spaces between tenants, and the Azure network fabric. Anything that hasn't been encapsulated with a valid VNet ID is blocked within the Azure network fabric. Finally, Azure VNets help prevent traffic from crossing between VNets. It is done through the same mechanism that handle address overlap and prevent spoofing. Traffic crossing between VNets is rendered infeasible by using unique VNet IDs established per tenant in combination with verification of all traffic at the source and destination. Users cannot access the underlying transmission mechanisms that rely on these IDs to perform the encapsulation. Therefore, any attempt to encapsulate and simulate these mechanisms would lead to dropped traffic. In addition to these key protections, all unexpected traffic originating from the internet is dropped by default. Any packet entering the Azure network first encounters an edge router. Edge routers intentionally allow all inbound traffic into the Azure network except spoofed traffic. This basic traffic filtering protects the Azure network from known bad malicious traffic. Azure also implements DDoS protection at the network layer, collecting logs to throttle or block traffic based on real-time and historical data analysis, and mitigates attacks on demand. Let's recap. In this video, you learned about the key aspects related to network isolation and Azure VNet's key protections to secure traffic between tenants.
Your office has an intranet configured for IT resources like servers, desktop computers, networking equipment like routers and switches, etc. Now, if you bring your personal laptop to the office, it'll be outside the network perimeter and may pose security risks. Hello, and welcome to the video, VPNs as part of perimeter security. In this video, you'll learn about creating a virtual network and a VPN gateway. As the network perimeter is the edge of what an organization has control over, using strong network controls and deploying perimeter networks for security zones is imperative. So let's begin with understanding how to use strong network controls. You can connect Azure virtual machines, frequently referred to as VMs, and appliances to other network devices by placing them on Azure virtual networks. What does that mean? You can connect virtual network interface cards to a virtual network to allow transmission control protocol or internet protocol-based communications frequently referred to as TCP or IP between network-enabled devices. VMs connected to an Azure virtual network can connect to devices on the same virtual network, different virtual networks, the internet, or your own on-premises networks. As you plan your network and the security of your networks, it is recommended that you centralize management of core network functions like ExpressRoute, virtual network, subnet provisioning, and IP addressing, governance of network security elements such as network virtual appliance functions like ExpressRoute, virtual network, subnet provisioning, and IP addressing. If you use a common set of management tools to monitor your network and the security of your network, you get clear visibility into both. A straightforward, unified security strategy reduces errors because it increases human understanding and the reliability of automation. Next, you need to understand how to deploy perimeter networks for security zones. As we discussed earlier, a perimeter network is a physical or logical network segment that provides an extra layer of security between your assets and the internet. Did you know that specialized network access control devices on the edge of a perimeter network allow only desired traffic into your virtual network? Perimeter networks are useful because you can focus your network access control management, monitoring, logging, and reporting on the devices at the edge of your Azure virtual network. A perimeter network is where you typically enable distributed denial of service protection, frequently referred to as DDoS protection. You also enable intrusion detection or intrusion prevention systems, frequently referred to as IDS or IPS, firewall rules and policies, web filtering, network anti-malware, and more. The network security devices sit between the internet and your Azure virtual network and have an interface on both networks. Next, let's learn how to create a virtual network. To do this, you need to sign into the Azure portal. You can then select the required virtual network from the marketplace results to open the virtual network page. After creating your virtual network, configure its settings as you require and then verify the subscription and select a resource group. Now name your virtual network and select the IP addresses. Finally, validate the virtual network settings and you have your virtual network. The next important step is to create the virtual network gateway, frequently referred to as the VPN gateway, for your virtual network. But what do we mean by a VPN gateway? A VPN gateway is a type of virtual network gateway that sends encrypted traffic between your virtual network and your on-premises location across a public connection. You can also use a VPN gateway to send traffic between virtual networks across the Azure backbone. As discussed earlier, a VPN gateway is a type of virtual network gateway. A virtual network gateway is composed of 2 or more Azure-managed VMs that are automatically configured and deployed to a specific subnet you create called the gateway subnet. The gateway VMs contain routing tables and run specific gateway services. One of the settings that you specify when creating a virtual network gateway is the gateway type. The gateway type determines how the virtual network gateway will be used and the actions that the gateway takes. A virtual network can have 2 virtual network gateways, one VPN gateway and one ExpressRoute gateway. When you create a VPN gateway, gateway VMs are deployed to the gateway subnet and configured with the settings that you specified. This process can take 45 minutes or more to complete depending on the gateway SKU that you selected. After you create a VPN gateway, you can configure connections. A VPN gateway connection relies on multiple resources that are configured with specific settings. Most of the resources can be configured separately, although some resources must be configured in a certain order. Let's recap. In this video, you learned about what network perimeter is, the importance of using strong network controls, and how to deploy perimeter networks for security zones. In addition, you learned how to create a virtual network and a VPN gateway.
With ever-evolving technologies, we have become more reliant on digital technologies. Conventional hardware-based networking systems are expensive and inflexible, and thus making it tough to keep pace with the requirements of the dynamic business world. What if I told you there is a solution to transform your network infrastructure? Hello, and welcome to the video, What is an NVA? In this video, you will explore a network virtual appliance, frequently referred to as NVA, how it functions, and why it has become the go-to solution for organizations worldwide. To begin with, let's understand what an NVA is. An NVA is a virtual appliance comprising various layers, such as a firewall, a wide area network, frequently referred to as WAN optimizer, application delivery controllers, routers, load balancers, intrusion detection or intrusion prevention systems, frequently referred to as IDS or IPS, and proxies. You can deploy NVAs chosen from providers in the Azure Marketplace. But the question is, why do you need NVAs and how do they benefit you? You can use an NVA to filter traffic inbound to a virtual network, block malicious requests, and block requests from unexpected resources. Consider a scenario of a retail organization where you need to work with the security and network teams. You want to implement a secure environment that scrutinizes all incoming traffic and blocks unauthorized traffic from passing on to the internal network. You also want to secure both virtual machine networking and Azure services networking as part of your company's network security strategy. What would be your primary goal in such a scenario? It would be to prevent unwanted or unsecured network traffic from reaching critical systems. As part of the network security strategy, you must control traffic flow within your virtual network. To do that, let's learn the role and benefit of using an NVA to control traffic flow through an Azure network. NVAs are virtual machines that control the flow of network traffic by controlling routing. You'll typically use them to manage traffic flowing from a perimeter network environment to other networks or subnets. You can deploy firewall appliances into a virtual network in different configurations. In addition, you can place a firewall appliance in a perimeter network subnet in the virtual network. If you want more security control, you can implement a micro-segmentation approach. With the micro-segmentation approach, you can create dedicated subnets for the firewall and then deploy web applications and other services in other subnets. All the traffic is routed through the firewall and inspected by the NVAs. You'll enable forwarding on the virtual appliance network interfaces to pass traffic accepted by the appropriate subnet. What else does microsegmentation do? It lets the firewall inspect all packets at OSI layer 4 and for application-aware appliances, layer 7. When you deploy an NVA to Azure, it acts as a router that forwards requests between subnets on the virtual network. Some NVAs require multiple network interfaces. One network interface is dedicated to the management network for the appliance. Additional network interfaces manage and control the traffic processing. After deploying the NVA, you can configure the appliance to route the traffic through the proper interface. Now that you have insight into what NVAs are and their benefits, let's understand what user-defined routes are. For most environments, the default system routes already defined by Azure are enough to get the environments up and running. In certain cases, you should create a routing table and add custom routes. Some examples include access to the internet via an on-premises network using forced tunneling and using virtual appliances to control traffic flow. Did you know that you can create multiple route tables in Azure? Each route table can be associated with one or more subnets. You should also remember that a subnet can only be associated with one route table. Next, let's look at NVAs in a highly available architecture. If traffic is routed through an NVA, the NVA becomes a critical piece of your infrastructure. Any NVA failures will directly affect the ability of your services to communicate. It's important to include a highly available architecture in your NVA deployment. There are several methods of achieving high availability when using NVAs. You will learn more about using NVAs in highly available scenarios in the course ahead. With this, you have reached the end of the video. To summarize, you learned about what an NVA is, the benefits of using NVAs, and what user-defined routes are. You also learned about NVAs in a highly available architecture.
Imagine you're working for an MNC that has offices located in different parts of the world. Though the company has a robust network infrastructure, the challenge is connecting all the offices securely while enforcing a centralized security policy. This is where virtual private network forced tunneling, frequently referred to as VPN-forced tunneling, comes into the picture. VPN ensures that your sensitive information stays encrypted and protected. However, if you need to implement a specific security policy for all the traffic originating from the remote offices, then configuring VPN-forced tunneling becomes imperative. Hello, and welcome to the video, Configure VPN-forced tunneling. In this video, you'll understand the need to use VPN-forced tunneling, its benefits, and how to configure VPN-forced tunneling. But before proceeding further, let's explore why some cases require forced tunneling. A VPN consists of remote peers sending private data securely to one another over an unsecured network, such as the internet. This is called internet tunneling. The other type of VPN, called site-to-site, frequently referred to as S2S VPNs, uses tunnels to encapsulate data packets within normal IP packets for forwarding over IP-based networks using encryption to ensure privacy and authentication to safeguard the integrity of data. So what does forced tunneling do? Forced tunneling lets you redirect or force all internet-bound traffic back to your on-premises location via an S2S VPN tunnel for inspection and auditing. This is a critical security requirement for most enterprise IT policies. Without forced tunneling, internet-bound traffic from your virtual machines, frequently referred to as VMs in Azure, always traverses from the Azure network infrastructure directly to the internet, without the option to allow you to inspect or audit the traffic. And that's dangerous, as unauthorized internet access potentially leads to information disclosure or other types of security breaches. As you learned earlier, Azure currently works with two deployment models, the Resource Manager deployment model and the Classic deployment model. The two models aren't completely compatible with each other. Let's take a look at how you can configure VPN tunneling for virtual networks that are created via the Resource Manager deployment model. The figure displayed on the screen depicts how forced tunneling works. The front-end subnet doesn't use forced tunneling. The workloads in the front-end subnet can continue to accept and respond to customer requests that come directly from the internet. The mid-tier and back-end subnets use forced tunneling. Any outbound connections from these two subnets to the internet are forced back to an on-premises site via one of the S2S VPN tunnels. This allows you to restrict and inspect internet access from your VMs or cloud services in Azure while continuing to enable your multi-tier service architecture. If no internet-facing workloads exist in your VMs, you can also apply forced tunneling to the entire virtual network. Now, let's understand how you can configure VPN-forced tunneling. You configure forced tunneling in Azure via virtual network user-defined routes, frequently referred to as UDRs. Redirecting traffic to an on-premises site is expressed as a default route to the Azure VPN gateway. This example uses UDRs to create a routing table to first add a default route and then associate the routing table with your virtual network subnets to enable forced tunneling on those subnets. You have now reached the end of the video. To recap, you learned why some cases need forced tunneling, its benefits, and how to configure VPN forced tunneling in Azure.
Consider a scenario where your organization has a production network that hosts sensitive customer data. They also have an intranet for employees to collaborate and development network to test new applications. In addition, they also need to ensure secure connections with all external stakeholders and offices in other locations. How do you do that? There are two options to connect virtual networks in Azure. However, you are confused if you should go for virtual network peering or virtual private network gateways, frequently referred to as VPN gateways. Though both solutions would offer unique advantages, you must opt for the one that suits your business requirements and network architecture the best. Hello, and welcome to the video Choose Between Virtual Network Peering and VPN Gateways. In this video, you will learn about two ways to connect virtual networks in Azure: virtual network peering and VPN gateways. Let's begin with understanding what a virtual network is. As the name suggests, a virtual network is a virtual isolated portion of the Azure public network. By default, traffic cannot be routed between two virtual networks. However, it's possible to connect virtual networks either within a single region or across two regions so that traffic can be routed between them. Next, let's explore virtual network connection types. The first one is virtual network peering. Virtual network peering connects two Azure virtual networks. Once paired, the virtual networks appear as one for connectivity purposes. Traffic between virtual machines in the paired virtual networks is routed through the Microsoft backbone infrastructure through private IP addresses only. There is no public internet involved. You can also peer virtual network across Azure regions, which is termed global peering. The second option, a VPN gateway, is a specific type of virtual network gateway that is used to send traffic between an Azure virtual network and an on-premises location over the public internet. You can also use a VPN gateway to send traffic between Azure virtual networks. Each virtual network can have at most one VPN gateway. You should enable Azure Distributed Denial of Service Protection Standard, frequently referred to as DDoS Protection Standard, on any perimeter virtual network. Did you know that virtual network peering provides a low latency, high bandwidth connection? There is no gateway in the path, so there are no extra hops ensuring low latency connections. It is useful in scenarios such as cross-region data replication and database failover. Because traffic is private and remains on the Microsoft backbone, also consider virtual network peering if you have strict data policies and want to avoid sending any traffic over the internet. In addition, VPN gateways provide a limited bandwidth connection and are useful in scenarios where you need encryption but can tolerate bandwidth restrictions. In these scenarios, customers are also not as latency sensitive. Now let's move ahead and discuss gateway transit. Virtual network peering and VPN gateways can also coexist via gateway transit. Gateway Transit enables you to use a peered virtual networks gateway for connecting to on-premises instead of creating a new gateway for connectivity. As you increase your workloads in Azure, you need to scale your networks across regions and virtual networks to keep up with the growth. Another benefit is that Gateway Transit allows you to share an ExpressRoute or VPN gateway with all peered virtual networks and lets you manage the connectivity in one place. Sharing enables cost savings and reduction in management overheads. With Gateway Transit enabled on virtual network peering, you can create a transit virtual network that contains your VPN gateway, network virtual appliance, and other shared services. As your organization grows with new applications or business units, and as you spin up new virtual networks, you can connect to your transit virtual networks using peering. This prevents adding complexity to your network and reduces the management overhead of managing multiple gateways and other appliances. It is also important to note that both virtual network peering and VPN gateways support certain connection types. These are virtual networks in different regions, virtual networks in different Azure Active Directory tenants, virtual networks in different Azure subscriptions, and virtual networks that use a mix of Azure deployment models such as Resource Manager and Classic. This brings us to the end of this video. Let's summarize. In this video, you learned about virtual networks and their connection types, such as virtual network peering and VPN gateways. You also learned about gateway transits and how to configure connections.
Consider a scenario where an organization has recently migrated its infrastructure to the cloud. You set up virtual networks to segregate various tiers of your applications and allocate resources efficiently. However, you now face a challenge on how to control the flow of network traffic between these virtual networks and external resources. You have 3 virtual networks, and you want to establish precise control over how traffic flows between these networks and external destinations. Additionally, you need to inspect and filter any outbound traffic from your virtual networks. This is where creating user-defined routes, frequently referred to as UDRs, and using network virtual appliances, frequently referred to as NVAs, becomes imperative. Hello, and welcome to the video, Create User-Defined Routes to Network Virtual Appliances. In this video, you'll explore what UDRs are, how to create UDRs, and deploy NVAs. Let's begin by exploring what UDRs are. A UDR is a custom route in Azure that overrides Azure's default system routes or adds routes to a subnet's route table. In Azure, you create a route table and then associate that route table with 0 or more virtual network subnets. Each subnet can have 0 or 1 route table associated with it. If you create a route table and associate it with a subnet, Azure either combines its routes with the default routes that Azure adds to a subnet or overrides those default routes. In the diagram displayed on the screen, UDRs are used to direct traffic from the gateway subnet and the web tier to the NVA. Next, let's understand how you can deploy an NVA. You can deploy an NVA to a perimeter network in many architectures. In the diagram displayed on the screen, the NVA helps provide a secure network boundary by checking all inbound and outbound network traffic. It also makes sure that only the traffic that meets the network security rules passes through. However, the fact that all network traffic passes through the NVA means that the NVA is a single point of failure in the network. If the NVA fails, no other path will exist for network traffic, and all the back-end subnets will become unavailable. So what can you do to make an NVA highly available? To do that, you should deploy more than one NVA into an availability set. The figure displayed on the screen shows a high availability architecture that implements an ingress perimeter network behind an internet-facing load balancer. This architecture is designed to provide connectivity to Azure workloads for Layer 7 traffic, such as HTTP or HTTPS traffic. Now let's understand the benefit of this high availability architecture. The key benefit of this architecture is that all NVAs are active, and if one fails, the load balancer directs network traffic to the other NVA. Both NVAs route traffic to the internal load balancer, so if one NVA is active, traffic will continue to flow. The NVAs are required to terminate SSL traffic intended for the web tier VMs. These NVAs can't be extended to handle on-premises traffic, because on-premises traffic requires another dedicated set of NVAs with their own network. Another important benefit to note is that UDRs and network security groups, frequently referred to as NSGs, help provide Layer 3 and Layer 4 security of the OSI model. In addition, NVAs help provide Layer 7 application layer security. You've reached the end of this video. Let's recap. In this video, you learned about what UDRs are, how to create UDRs, and how to deploy NVAs. Congratulations on completing this module. This module focused on some of the perimeter-level security tools provided by Azure to help prevent attacks on your Azure solutions. Let's recap what you learned. You started by being introduced to the defense concepts. This included defense in depth, a strategy where you implement multiple layers of security measures to protect the organizational resources and digital assets against various types of threats. We also did a recap of network client and server technology, where you learned what a network client is, the types of clients, servers, and server models. You also explored various server types, their advantages and disadvantages, and what's available in Azure. You also learned about network security and firewalls, and tools to strengthen network protection in Azure. The module delved into virtual network security and network monitoring to secure the Azure perimeter. Next, you noted how to secure your solutions using distributed denial of service protection, frequently referred to as DDoS protection and firewalls. You explored the importance of perimeter protection as part of your defense strategy and how to enable DDoS protection. To refresh your memory, DDoS is a collection of attack types aimed at disrupting the availability of a target. You also explored the steps to configure a distributed denial of service protection implementation and learned some best practices to build DDoS-resilient services in Azure. Next, you got acquainted with the Azure Firewall features and how to deploy an Azure Firewall implementation. Azure Firewall is a managed cloud-based network security service that protects your Azure virtual network resources. It's a fully stateful firewall as a service with built-in high availability and unrestricted cloud scalability. Your understanding of Azure Firewall did not end with theoretical concepts. You also had the exciting opportunity to check out the features and test the steps to deploy an Azure Firewall implementation through hands-on exercises. Next, you gained an overview of Azure Firewall Manager and delved deeper into how Azure Firewall Manager works and how to configure and deploy it. Do you recollect what Azure Firewall Manager does? It enables you to centralize the management of multiple instances of Azure Firewall. By implementing Azure Firewall, you can help protect your Azure resources. Then you gained insight into securing your solutions using VPNs, starting with network isolation and security. You learned how VPNs can be used as part of perimeter security and what a network perimeter is. To refresh this concept, the network perimeter is the edge of what an organization has control over. Using strong network controls and deploying perimeter networks for security zones is imperative. In addition, you also learned how to create a virtual network and a VPN gateway. Moving ahead, you were also introduced to the hub and spoke topology. A hub and spoke topology is a type of network configuration in which a central node or hub serves as the conduit to transmit messages and data where needed. All peripheral nodes or spokes are connected to the central hub, and any communication between the spokes has to pass through the hub. This configuration simplifies network management and control, as the hub becomes a centralized point for managing data, security, and network administration. You also learned about routing Azure virtual networks and what an NVA is. A network virtual appliance, or NVA, comprises various layers, such as a firewall, a wide area network, frequently referred to as WAN optimizer, application delivery controllers, routers, load balancers, intrusion detection, or intrusion prevention systems, frequently referred to as IDS or IPS, and proxies. The module also discussed how to configure VPN-forced tunneling. Forced tunneling lets you redirect or force all internet-bound traffic back to your own on-premises location via a site-to-site VPN tunnel for inspection and auditing. This is a critical security requirement for most enterprise IT policies. In addition, you explored how you can use virtual network peering to connect Azure virtual networks directly. You learned about reciprocal connections and cross-subscription virtual network peering and how only directly peered virtual networks can communicate with each other. You then went on to explore how to choose between virtual network peering and VPN gateways. That's not all. You also gained insight into creating user-defined routes. It's frequently referred to as UDRs and NVAs. In Azure, you create a route table and then associate that route table with 0 or more virtual network subnets. You then went beyond theoretical concepts and practiced your learnings through hands-on exercises. You did a hands-on exercise on virtual network peering, frequently referred to as VNet peering and NVA routes, to brush up on your understanding. Next, you learned about Azure Functions networking options and gained an overview of Azure Network Virtual Appliances firewall architecture. Wow, that was a lot of learning. You are now ready to move to the next step, the graded assessment for the module. Good luck.
A security engineer, James, is assigned the task of creating a network security group, also called NSG, in Azure to secure traffic to a new virtual network. By using NSGs, James's IT team ensures that Azure resources are protected from unauthorized access and cyber threat. Network traffic can be filtered to and from Azure resources in an Azure virtual network with a network security group. Hello, and welcome to the video, Network Security as Part of Your Defense Strategy. In this video, you will learn about the role of NSGs in providing advanced security for virtual machines, frequently referred to as VMs, and what NSG rules are. Let's start by recapitulating the creation of VMs using the Resource Manager deployment model and the classic deployment model and the basic security features embedded in them. First, let's understand how VMs created through the Resource Manager deployment model are protected from the Internet. In this case, VMs can have direct connectivity to the Internet by using a public IP address directly assigned to the VMs. Only the host firewall configured inside the VMs helps protect these VMs from the Internet. Next, let's explore the VMs created using the classic deployment model. In this case, VMs communicate with Internet resources through the cloud service that is assigned the public IP address. The public IP address is also known as a virtual IP address, frequently referred to as VIP. VMs that reside inside the cloud service share that VIP and establish communication with Internet resources by using endpoints. If you remove the VM endpoints that map the public port and public IP addresses of the cloud service to the private port and private IP address of the VM becomes unreachable from the Internet via the public IP address. For implementing advanced security in the VMs created through either of the models, Resource Manager or Classic, NSGs are used. NSGs control inbound and outbound traffic passing through a network adapter in the Resource Manager deployment model and passing through VMs in the classic deployment model. For both models, they control the traffic passing through a subnet. Let us explore how the traffic is approved or denied through NSGs. This is done through NSG rules. Each NSG rule is based on a source IP address, a source port, a destination IP address, and a destination port. Based on whether the traffic matches this combination, the rule either allows or denies the traffic. Let us now identify the properties of NSG rules. The first property is the name, a unique identifier for the rule. The second property, direction, specifies whether the traffic is inbound or outbound. The priority property is applicable when multiple rules match the traffic. In such cases, rules with a higher priority apply. The access property specifies whether the traffic is allowed or denied. Next, the source IP address prefix identifies where the traffic originated from. It can be based on a single IP address, a range of IP addresses in classless interdomain routing, also called CIDR, notation, or the asterisk to match all possible IP addresses. The source port range property specifies source ports by using a single port number from 1 through 65,535, a range of ports, or the asterisk to denote all possible ports. The destination IP address prefix property identifies the traffic destination based on a single IP address, a range of IP addresses in CIDR notation, or the asterisk to match all possible IP addresses. The destination port range property specifies destination ports using a single port number from 1 through 65,535, a range of ports, or the asterisk to denote all possible ports. Lastly, the protocol property specifies a protocol that matches the rule. It can be UDP, TCP, or an asterisk. Predefined default rules exist for inbound and outbound traffic. These rules allow all inbound and outbound traffic within a virtual network, outbound traffic towards the Internet, and inbound traffic to an Azure load balancer. A default rule with the lowest priority also exists in both the inbound and outbound sets of rules that deny all network communication. The default rules have the lowest property, so you cannot delete them, but you can override them. When you create a custom rule, you can specify predefined categories of IP addresses by using default tags in the source and destination IP address. These default tags are Internet, Virtual Network, and Azure Load Balancer. The Internet tag represents Internet IP addresses. The Virtual Network tag identifies all IP addresses defined by the IP range for the virtual network. It also includes IP address ranges from on-premises networks defined as the local network to virtual network. The Azure Load Balancer specifies the default Azure Load Balancer destination. Let us now learn about designing NSGs to isolate virtual networks and security zones. You can apply NSGs to subnets to create protected screened subnets. Or you can apply NSGs to DMZs, which can restrict traffic flow to all the machines residing within that subnet. With the classic deployment model, you can assign NSGs to individual computers to control traffic that is both destined for and leaving the VM. With the Resource Manager deployment model, you can assign NSGs to a network adapter so that NSG rules control only the traffic that flows through that network adapter. If the VM has multiple network adapters, NSG rules won't automatically be applied to traffic that is designated for other network adapters. With this, you have reached the end of the video. In this video, you learned about implementing advanced security in VMs through NSGs. You learned how the traffic is approved or denied through NSG rules. You also learned about the properties of NSG rules. Finally, you learned about planning and designing NSGs to isolate virtual networks in security zones. James, a security engineer, is creating a network security group, also called NSG, in Azure to secure traffic to a new virtual network. James's organization recognizes the role of NSGs in implementing advanced security in virtual machines, frequently referred to as VMs. James understands how the traffic is approved or denied through NSG rules. Next, James needs to work on deploying NSG implementation. Hello, and welcome to the video, Deploy and Configure Network Security Groups. In this video, you will learn about the limitations of implementing NSGs. You will explore an example to understand the application of NSG rules based on the direction of traffic and the priority of applied security rules. Let's begin by identifying the limitations to consider when implementing NSGs. By default, you can create 100 NSGs per region per subscription. You can raise this limit to 400 by contacting Azure support. You can apply only one NSG to a VM, subnet, or network adapter. By default, you can have up to 200 rules in a single NSG. You can raise this limit to 500 by contacting Azure support. You can apply an NSG to multiple resources. You should also consider that an individual subnet can have 0 or 1 associated NSG. Also, an individual network interface can have 0 or 1 associated NSG. So, by associating an NSG with a subnet and another NSG with a VM's network interface, you can impose dual traffic restrictions on the VM. In this case, the application of NSG rules depends on the direction of traffic and the priority of applied security rules. Let us consider a simple example with one VM. The virtual machine is placed inside the Contoso subnet. Contoso subnet is associated with subnet NSG, and the VM network interface is additionally associated with VM NSG. So, how is the traffic evaluated in this case? For inbound traffic, the subnet NSG is evaluated first. VM NSG then evaluates any traffic allowed through subnet NSG. The reverse is applicable for outbound traffic. The VM NSG is evaluated first. Subnet NSG then evaluates any traffic allowed through VM NSG. In this case, it is possible to implement a granular security rule application. For instance, you want to authorize inbound internet access only to specific application VMs, such as front-end VMs located within a subnet, while blocking access to other VMs, such as back-end and database VMs. So, you can have a more lenient rule on the subnet NSG, allowing internet traffic, and restrict access to specific VMs by denying access on VM NSG. The same can be applied for outbound traffic. To help secure and protect your Azure resources, ensure that the NSG planning is standard operating procedure, also called SOP, for your deployments. It is possible to assign either 1 or 0 NSG to each virtual network subnet and network interface in a virtual machine. As an example, refer to the shown image that depicts different scenarios for how NSGs might be deployed to allow network traffic to and from the internet over TCP port 80. Let us now understand how Azure processes inbound and outbound rules for NSGs. For inbound traffic, Azure first processes the rules in the NSG associated to the subnet, if one exists. Then, it processes the rules in the NSG associated to the network interface, if one is present. For VM1, the security rules in NSG1 are processed, as it is associated to subnet 1 and VM1 is in subnet 1. Without a rule that allows port 80 inbound, deny all inbound default security rule denies the traffic and NSG2 doesn't evaluate it, as NSG2 is associated to the network interface. However, if NSG1 has a security rule that allows port 80, NSG2 processes the traffic. To allow port 80 to the VM, both NSG1 and NSG2 must have a rule that allows port 80 from the internet. For VM2, the rules in NSG1 are processed because VM2 is also in subnet 1. Without an NSG associated to its network interface, VM2 either receives traffic allowed by NSG1 or is denied traffic that NSG1 denies. Traffic is either allowed or denied to all resources in the same subnet when an NSG is associated with a subnet. For VM3, no NSG is associated to subnet 2, so traffic is allowed into the subnet and processed by NSG2. This is because NSG2 is associated to the network interface attached to VM3. From VM4, all network traffic is allowed because an NSG is not associated to the network interface attached to the VM or to the subnet 3. Moving further, let us understand how Azure processes outbound rules for NSGs. For outbound traffic, Azure first processes the rules in an NSG associated to a network interface, if one exists. Then, it processes the rules in an NSG associated to the subnet, if there is one. For VM1, the security rules in NSG2 are processed. Without a rule that denies port 80 outbound, the Allow Internet Outbound default security rule allows traffic in both NSG1 and NSG2. If NSG2 has a security rule that denies port 80, the traffic is denied and never evaluated by NSG1. To deny port 80 from the VM, either or both of the NSGs must have a rule that denies port 80 to the internet. For VM2, the rules in NSG1 are processed. All traffic is sent through the network interface to the subnet, as the network interface attached to VM2 does not have an NSG associated to it. For VM3, if NSG2 has a security rule that denies port 80, the traffic is denied. If NSG2 has a security rule that allows port 80, then port 80 is allowed outbound to the internet, since an NSG is not associated to subnet 2. From VM4, all network traffic is allowed because an NSG is not associated to the network interface attached to the virtual machine or to subnet 3. You should know that security rules in an NSG associated to a subnet can affect connectivity between VMs within it. For example, if NSG1 has a rule denying all inbound and outbound traffic, VM1 and VM2 won't be able to communicate. Another rule would have to be explicitly added to allow this. Finally, let us understand the recommended general guidelines. You should associate an NSG to a subnet or a network interface, but not both. As rules in an NSG associated to a subnet can conflict with rules in an NSG associated to a network interface, you can have unexpected communication problems that require troubleshooting. With this, you have reached the end of the video. Let's summarize. In this video, you learned: what are the limitations of implementing NSGs? What are the major considerations when implementing NSGs? How Azure processes inbound and outbound rules for NSGs. James, a security engineer, is working to create and deploy a network security group, also called NSG, in Azure. James understands that one can filter network traffic to and from Azure resources in an Azure virtual network with an NSG. An NSG contains security rules that allow or deny inbound network traffic to or outbound network traffic from several types of Azure resources. You can specify the source and destination, port, and protocol for each rule. You can enable NSG flow logs to analyze network traffic to and from resources that have an associated NSG. Next, James is exploring application security groups, also called ASGs, which are built on NSGs. Hello, and welcome to the video, Create Application Security Groups. In this video, you will learn about the role of ASGs and the constraints for implementing ASGs. ASGs enable you to configure network security as a natural extension of an application structure. Then you can group VMs and define network security policies based on those groups. ASGs also enable you to apply your security policy at scale without manually maintaining explicit IP addresses. This eliminates the complexity of dealing with explicit IP addresses and multiple rule sets, allowing you to concentrate on your business logic. The platform manages the IP addresses and rule sets. Let us refer to the given image as an example to understand the role of ASGs. In this example, NIC1 and NIC2 are members of the ASG Web ASG. NIC3 is a member of the ASG Logic ASG. NIC4 is a member of the ASG DB ASG. Although in this example, each network interface belongs to a single ASG, a network interface can be a member of multiple ASGs, up to the Azure limits. Here in this example, none of the network interfaces have an associated NSG. NSG1 is associated to both subnets and contains the following rules. Allow HTTP inbound internet. Deny database all. Allow database business logic. The rules that specify an ASG as the source or destination are only applied to the network interfaces that are members of the ASG. If the network interface is not a member of the ASG, the rule is not applied, even though the NSG is associated to the subnet. Next, let us understand the constraints of ASGs. Firstly, it is important to consider that there are limits to the number of ASGs you can have in a subscription. In a security rule, you can specify one ASG as the source and destination. You cannot specify multiple ASGs in the source or destination. Another important constraint is that all network interfaces assigned to an ASG must exist in the same virtual network in which the first network interface is assigned to the ASG is in. For example, if the first network interface assigned to an ASG named ASG Web is in the virtual network named VNet1, then all subsequent network interfaces assigned to ASG Web must exist in VNet1. You cannot add network interfaces from different virtual networks to the same ASG. If you specify an ASG as the source and destination in a security rule, the network interfaces in both ASGs must exist in the same virtual network. For example, if ASG Logic contain network interfaces from VNet1 and ASG DB contain network interfaces from VNet2, you could not assign ASG Logic as the source and ASG DB as the destination in a rule. All network interfaces for source and destination ASGs must exist in the same virtual network. You would have now understood that the ASGs, along with NSGs, bring multiple benefits in the network security area. We can summarize these benefits as following: a single management experience, increased limits on multiple dimensions, a great level of simplification, a seamless integration with your architecture. With this, you have reached the end of the video. Let's summarize. In this video, you learned role of ASGs in network security, constraints when implementing ASGs, and benefits of ASGs in the network security. James, a security engineer, works in an enterprise organization. James's organization is concerned about data exposure on the public internet when accessing Azure services. James identifies that service endpoints help to solve this problem. A virtual network service endpoint provides the identity of your virtual network to the Azure service. With service endpoints enabled in your virtual network, you can secure Azure service resources to your virtual network by adding a virtual network rule to the resources. Hello, and welcome to the video, Enable Service Endpoints. In this video, you will learn about the basics of service endpoints and why service endpoints are required to secure Azure service resources. Let us understand how service endpoints secure Azure service resources. Azure service traffic from a virtual network uses public IP addresses as source IP addresses. Service endpoints change service traffic to use private addresses in the virtual network as source IP addresses when the Azure service is accessed from the virtual network. With this change, you can use the service without reserved public IP addresses used in the IP firewall. Service endpoints are commonly used for virtual machines, also called VMs, accessing storage. The storage account restricts access to the VM's private IP address. After understanding the basics of service endpoints, what benefits do you think the service endpoints bring to network security? Let us explore why service endpoints should be used. Firstly, service endpoints bring improved security to your Azure service resources. Let's understand how this is done. The private address space of a virtual network may overlap, which means it cannot be used to uniquely identify traffic originating from your virtual network. Service endpoints extend the virtual network's identity to Azure service resources. Enabling service endpoints in a virtual network allows for improved security by adding a virtual network rule to Azure resources and fully removing public internet access to these resources. As a result, only traffic from the virtual network is allowed, enhancing the security of the resources. The second benefit is that service endpoints bring the optimal routing for Azure service traffic from your virtual network. Any routes in your virtual network that direct internet traffic to your premises or virtual appliances, which is referred to as forced tunneling, will also direct Azure service traffic through the same route as the internet traffic. The next benefit is that endpoints always take service traffic directly from your virtual network to the service on the Microsoft Azure Backbone Network. By keeping the traffic on the Azure Backbone Network, you can maintain the ability to monitor and audit outbound internet traffic from your virtual networks through forced tunneling without any impact on service traffic. Finally, service endpoints are simple to set up with less management overhead. You can now secure Azure resources through IP Firewall without the need for reserved public IP addresses in your virtual networks. The setup of service endpoints does not require any network address translation, also called NAT, or gateway devices, and can be configured by simply clicking on a subnet. There is no additional overhead to maintaining the endpoints. You have now reached the end of the video. Let's summarize. In this video, you learned about the role of service endpoints in network security and benefits of service endpoints in network security. James, a security engineer working in an enterprise organization, is considering enabling service endpoints in the virtual network of his organization. James's IT team acknowledges the benefits of service endpoints to secure Azure service resources to their virtual network. The virtual network service endpoints provide secure and direct connectivity to Azure services over an optimized route over the Azure Backbone Network. Service endpoints enable private internet protocol, also called IP, addresses in the virtual network to reach the endpoint of an Azure service without needing a public IP address in the virtual network. It is also worth noting that Microsoft recommends using Azure Private Link for secure and private access to services hosted on the Azure platform. Hello, and welcome to the video, Configure Service Endpoint Services. In this video, you will learn how service endpoints work and what are typical scenarios in which service endpoints are useful. Let us begin by understanding how service endpoints work. Service endpoints enable you to connect certain platform services to your virtual networks. Your Azure virtual machines, also called VMs, can interact with Azure SQL and Azure storage accounts as if they were part of the same virtual network. Instead of accessing these services through the public endpoints, they can be accessed as if they were internal resources. You can enable the service endpoint of your choice under the virtual network and specify the subnet. Once completed, you can visit the platform service, such as the Azure SQL Server. Under firewalls and virtual networks, add the virtual network and subnet that you configured. To activate service endpoints on the desired subnet, you can leverage an existing Azure VM's network interface card, also called NIC. By utilizing the Effective Routes diagnostic tool, you can inspect the routing setup and determine any issues. Moving further, let's analyze a few considerations regarding the configuration of service endpoints. You can configure service endpoints on a subnet in a virtual network. endpoints work with any type of compute instance running within that subnet. You can configure multiple service endpoints for all supported Azure services, such as Azure Storage or Azure SQL Database on a subnet. For Azure SQL Database, virtual networks must be in the same region as the Azure service resource. With Azure Storage, you can authorize virtual networks in other regions in the preview. For all other services, it is possible to connect Azure service resources with virtual networks in any region for improved security. What are some scenarios in which the service endpoints would provide benefits? Let us explore a few of these scenarios. The first scenario is peered, connected, or multiple virtual networks. To secure Azure services across several subnets in one or more virtual networks, you can activate service endpoints on each subnet individually, and then secure Azure service resources on all of the subnets. The second scenario relates to filtering outbound traffic from a virtual network to Azure services. By deploying a network virtual appliance within a virtual network, you can inspect or filter the traffic sent to an Azure service. You can then apply service endpoints to the subnet where the network virtual appliance is deployed and secure Azure service resources only to this subnet. This setup can be useful if you need to use network virtual appliance filtering to restrict Azure service access from your virtual network only to specific Azure resources. The next scenario is about securing Azure resources to services deployed directly into virtual networks. By deploying different Azure services directly into specific subnets within a virtual network, you can secure their resources to manage service subnets. This can be achieved by setting up a service endpoint on the managed service subnet. Another scenario in which service endpoints can provide benefits relates to disk traffic from an Azure VM. Changes in service endpoint routing for Azure Storage do not impact the VM disk traffic of managed and unmanaged disks. This traffic encompasses disk input, output, also called I/O, mounting, and unmounting. You can limit REST access to page blobs to select networks through service endpoints and Azure Storage Network rules. You have now reached the end of the video. Let's summarize what you learned in this video. In this video, you learned working of service endpoints, considerations regarding the configuration of service endpoints, and scenarios in which service endpoints would provide benefits. James, a security engineer in an enterprise organization, has been working with his IT team to secure the virtual network of his organization. James's organization accesses a number of Azure Platform as a Service, also called PaaS services, such as Azure Storage and SQL Database. These services have internet-facing endpoints. James's IT team wanted a secure way to access a PaaS service from Azure directly, without going down and around the internet. So, they decided to explore deploying Private Link in Azure. Azure Private Link will enable them to access Azure PaaS services and Azure-hosted customer-owned and partner services over a private endpoint in their virtual network. Hello, and welcome to the video, Deploy Private Links. In this video, you will learn what Azure Private Link is and what key benefits are provided by Private Link. You will also learn how to deploy Private Link in Azure. The traffic between your virtual network and the service travels the Microsoft backbone network. It is not necessary to expose your service to the public internet. You can create your own Private Link service in your virtual network and deliver it to your customers. Azure Private Link offers a consistent way of setting up and usage, which is applicable for Azure PaaS, customer-owned and shared partner services. You have now understood the basic purpose of deploying Azure Private Link in your network. So, what benefits can Private Link offer? Let us explore these benefits. The most important benefit is that Azure Private Link enables you to access services on the Azure platform privately. You can connect your virtual network using private endpoints to all services that can be used as application components in Azure. With Private Link, service providers can host their services within their virtual network, while consumers can access these services from their local virtual network. The Private Link platform facilitates consumer and service connectivity via the Azure Backbone Network. The second benefit relates to on-premises and peered networks. You can access services running in Azure from on-premises over ExpressRoute private peering, VPN tunnels, and peered virtual networks using private endpoints. Private Link eliminates the requirement for configuring ExpressRoute Microsoft peering or using the internet to access a service. It offers a secure approach for migrating workloads to Azure. The other benefit is the protection against data leakage. A private endpoint is mapped to an instance of PaaS resource instead of the entire service. Consumers can only connect to a specific resource. This effectively blocks access to any other resources within the service and helps prevent the risk of data leakage. The next benefit is the global reach. Private Link enables you to connect privately to services running in other regions. For example, the consumer's virtual network could be in region A, and it can connect to services behind Private Link in region B. Last but not least, Private Link enables the same experience and functionality to render your service privately to consumers in Azure. To enable Private Link for your service, you can use a standard Azure load balancer to place it behind. The consumer can then connect directly to your service using a private endpoint in their virtual network. You can control the connection requests by implementing an approval call flow. Azure Private Link can also be utilized for services and consumers belonging to distinct Azure Active Directory tenants. Moving forward, let us understand a few aspects of deploying Private Link. Azure Private Link works on an approval call flow model, wherein the Private Link service consumer can request a connection to the service provider to consume the service. The service provider can decide whether to allow the consumer to connect or not. Azure Private Link enables the service providers to manage the private endpoint connections on their resources. For approval, the service consumer can choose from the two connection approval methods, which are automatic or manual. Let's first understand the automatic approval method. The service consumer can choose the automatic approval method if they have role-based access control, also called RBAC, permissions on the service provider resource. In this case, when the request reaches the service provider resource, no action is required from the service provider, and the connection is automatically approved. The manual approval method can be chosen if the service consumer doesn't have RBAC permissions on the service provider resource. In this case, the connection request appears on the service resources as pending. The service provider must manually approve the request before establishing connections. In manual cases, the service consumer can also specify a message requesting more context to the service provider. The service provider has the following three options to choose from for all private endpoint connections: approved, reject, remove. You have now reached the end of the video. In this video, you learned the basics of Azure Private Link, key benefits provided by Private Link, and connection approval methods for accessing service resources. A retail organization has a new shipping portal for vendors to ship customer items and track status. The organization is publishing this portal and making it available over the internet. This portal exposes business and customer data. The shipping portal requires encryption to protect customers' sensitive information and financial account data. The data needs to be encrypted between users and the back-end application. Encrypting data in transit helps to secure applications. You can buy certificates from a certificate authority to encrypt messages passing in and out of servers. This encryption prevents unauthorized users from intercepting and examining information in the messages. To help secure this data, you can use Azure Application Gateway. It encrypts data that's traversing the network from users to application servers. Hello, and welcome to the video Application Gateway and Encryption. In this video, you will learn what Azure Application Gateway is and how it helps to secure applications. You will also learn about the components and working of Application Gateway. Let's start by understanding the basics of Azure Application Gateway. Azure Application Gateway is an application delivery controller. It provides features like load balancing hypertext transfer protocol, also called HTTP, traffic, and web application firewall. It also provides support for secure sockets layer, also called SSL, encryption of your data. Next, let's analyze how Application Gateway helps to secure web applications. Basically, Application Gateway supports encrypting traffic between users and an application gateway, and between application servers and an application gateway. The Application Gateway offloads the CPU-intensive SSL termination workload from your servers and eliminates the need to install certificates and configure SSL on your servers. Application Gateway enables end-to-end encryption by decrypting traffic with a private key on the gateway and then re-encrypting it with the public key of the backend service. Exposing your website or web application through the Application Gateway reduces the attack surface by not directly connecting servers to the web. You are exposing only port 80 or port 443 on the Application Gateway. Moving further, let's understand the components of Application Gateway. Application Gateway has several components. The main parts for encryption are the front-end port, the listener, and the back-end pool. The image shows how incoming traffic from a client to Application Gateway over SSL is decrypted and then re-encrypted when sent to a server in the back-end pool. Traffic enters the gateway through a front-end port. You can open many ports, and Application Gateway can receive messages on any port. A front-end IP address is associated with an Application Gateway and can be public, private, or both. An Application Gateway supports one public or one private IP address. The virtual network and public IP address must be in the same location. After creation, the front-end IP address is associated with a listener. A listener is a logical entity that checks for incoming connection requests. A listener is the first thing your traffic meets when entering the gateway through a port. A listener is set up to listen for a specific hostname, IP address, and port. The listener can use an SSL certificate to decrypt the gateway's traffic. The listener then uses a rule that you define to direct the incoming requests to a backend pool. The backend pool contains your application servers. These servers might be virtual machines, a virtual machine scale set, or applications running on Azure App Service. In the backend pool, incoming requests can be load balanced across the servers. The pool has an HTTP setting with a certificate for authenticating backend servers. The gateway uses this certificate to re-encrypt traffic before forwarding it to one of your servers in the backend pool. You have now reached the end of the video. In this video, you learned about basics of Azure Application Gateway, encryption through Azure Application Gateway, and components of Azure Application Gateway. A retail organization's new online shipping portal for vendors requires encryption to protect sensitive business and customer data during transmission. To help secure the data, the IT team of the organization is considering implementing Azure Application Gateway, which encrypts data traversing the network from users to application servers. For this purpose, the IT team is exploring the features of Application Gateway. Hello, and welcome to the video, Implement an Azure Application Gateway. In this video, you will learn how Application Gateway can make routing decisions and what are the features of Application Gateway. Azure Application Gateway is a web traffic load balancer enabling you to manage web application traffic. Let's understand how traffic is routed through Azure Application Gateway. Load balancers typically work at the transport layer, which is layer 4 in the Open Systems Interconnection, also called OSI model. Layer 4 of the OSI model manages transport protocols like Transmission Control Protocol, also called TCP, and User Datagram Protocol, also called UDP. Traditional load balancers route traffic based on the source IP address and port to a destination IP address and port. Application Gateway can make routing decisions based on additional attributes of an HTTP request, such as URI path or host headers. Let us consider the example depicted in the image. In this case, you can route traffic based on the incoming URL. If /images are in the upcoming URL, you can route traffic to a specific set of servers, known as a pool, configured for images. If/video is in the URL, that traffic is routed to another pool that's optimized for videos. This type of routing is known as application layer load balancing. For implementing Application Gateway, it is important to explore its features. So, let us now understand the features of Application Gateway. The first feature is the Secure Sockets Layer, also called SSL, Termination at the Gateway. SSL is also known as Transport Application Gateway, or TLS. After SSL or TLS termination, the traffic typically flows unencrypted to the backend servers. This feature allows web servers to be unburdened from costly encryption and decryption overhead. The second feature is autoscaling. Application Gateway Standard version 2 supports autoscaling and can help scale up or down based on changing traffic load patterns. With autoscaling, there is no need to select a deployment size or a number of instances during provisioning. The third feature is zone redundancy. Application Gateway Standard version 2 can span multiple availability zones, offering better fault resiliency and removing the need to provision separate application gateways in each zone. The fourth feature is Static Virtual Internet Protocol, also called VIP. The Application Gateway Standard version 2 SKU supports static VIP type exclusively. This ensures that the VIP associated with the application gateway doesn't change even over the lifetime of the application gateway. Another feature is the Web Application Firewall, also called WAF. This service provides centralized protection of your web applications from common exploits and vulnerabilities. WAF is based on rules from the Open Web Application Security Project, frequently referred to as OWASP. It is specifically based on Core Rule Sets 3.1, 3.0, and 2.2.9. This next feature is the Ingress Controller for Azure Kubernetes Service, also called AKS. Application Gateway Ingress Controller, also called AGIC, allows you to use Application Gateway as the ingress for an AKS cluster. Another feature of Application Gateway is URL-based routing. This feature allows you to route traffic to back-end server pools based on the URL paths of the request. One of the scenarios is to route requests for different content types to different pools. The next feature to understand is multiple site hosting. Multiple site hosting enables you to configure more than one website on the same application gateway instance. This feature enables you to create a more efficient deployment topology by adding up to 100 websites to a single application gateway, which can optimize performance. The next feature is about redirection. To ensure that all communication between a web application and its users takes place over an encrypted path, many web applications use automatic HTTP to HTTPS redirection as a standard practice. The cookie-based session affinity feature is used for keeping a user session on the same server. Another feature is WebSocket and HTTP2 traffic. Application Gateway provides native support for the WebSocket and HTTP2 protocols. There's no user configurable setting to enable or disable WebSocket support selectively. The other feature of Application Gateway is connection draining, which helps you achieve smooth removal of back-end pool members during planned service updates. Next, you should know that Application Gateway allows you to create custom error pages instead of displaying default error pages. You can use your own branding and layout using a custom error page. The next feature of Application Gateway is to rewrite HTTP headers. HTTP headers allow the client and server to pass additional information with the request response. Finally, you should know about the sizing feature. Application Gateway Standard version 2 can be configured for autoscaling or fixed-size deployments. This SKU doesn't offer different instance sizes. New Application Gateway version 1 SKU deployments can take up to 20 minutes to provision. Changes to instance size or count aren't disruptive, and the gateway remains active during this time. Most deployments that use the version 2 SKU take around 6 minutes to provision. You have now reached the end of the video. In this video, you learned about how can Application Gateway make routing decisions, and what are the features of Application Gateway. Julia, a security engineer in a retail organization, is responsible for managing web applications of her organization. Julia is concerned about the increasing number of cyber attacks and security breaches that are occurring daily. Julia understands that the web applications of her organization are critical to their business and contain sensitive data. So Julia wants to take effective measures to secure their web applications against potential threats. One solution to protect web applications is to implement a web application firewall, also called WAF. WAF is a security solution that protects web applications from malicious activities. Hello, and welcome to the video, Deploy a Web Application Firewall. In this video, you will learn how WAF secures web applications. You will learn about the primary features of WAF. You will also learn about the implementation of WAF policies. You know that it is challenging to prevent attacks, such as SQL injection and cross-site scripting in application code. It can require rigorous maintenance patching and monitoring at multiple layers of the application topology. Azure WAF provides a solution to these challenges. Azure WAF is a centralized, cloud-native security platform to protect web applications. Using a centralized WAF can simplify security management and provide better assurance of protection against threats and intrusions. A WAF solution can react to a security threat faster by centrally patching a known vulnerability instead of securing each individual web application. The centralized cloud-based WAF platform acts as an application delivery controller, also called ADC. The platform allows teams to create custom and managed rule sets to implement security hardening at the edge. A WAF is typically deployed on a web server to inspect incoming requests and block those which do not match its rules. You can deploy the WAF service as part of the Azure cloud or on-premises in your own data center. To know more about the WAF service, let us understand its primary features regarding monitoring, customization, and WAF policy and rules. Firstly, let's examine the monitoring capabilities of WAF. Azure WAF integrates seamlessly with Azure Security Information Event Management, also called SIEM, Tools for Improved Visibility. The WAF generates different logs that can be sent to Azure monitoring logs for tracking firewall alerts and trends. Additionally, it can seamlessly integrate with Microsoft Defender for cloud to display the status of all Azure resources in a unified interface. Next, let us explore the customization feature. With WAF, cloud security teams can generate personalized rules and rule groups to accommodate specific application needs. These rules can be utilized to assign a WAF security policy for each site safeguarded by the firewall, enabling site-specific configurations. Azure WAF policy supports different rules, exclusions, and customizations necessary for activating the firewall on an application gateway. After configuring a WAF policy, you can associate it with single or multiple application gateways to manage security. Azure WAF policies are primarily configured based on the Open Worldwide Application Security Project, also called OWASP, Core Rule Groups. These policies can be categorized as managed rules, custom rules, or bot mitigation rules. Managed rules are a collection of pre-configured Azure rule sets. Custom rules are developed for specific use cases. WAF supports bot mitigation rules to block requests from known malicious IP addresses. The WAF policies are associated with an application gateway for a global policy, or to a listener for a per-site policy, or to a path-based rule for a per-URI policy. There's no limit on the number of policies you can create. When you create a policy, it must be associated with an application gateway to take effect. It can be associated with any combination of application gateways, listeners, and path-based rules. When you associate a WAF policy globally, every site behind your application gateway WAF is protected with the same managed rules, custom rules, exclusions, and any other configured settings. If you want a single policy to apply to all sites, you can associate the policy with the application gateway. Moving further, let us understand the per-site WAF policies. You can protect multiple sites with different security needs behind a single WAF by using per-site policies. For example, if there are 5 sites behind your WAF, you can have 5 separate WAF policies, one for each listener, to customize the exclusions, custom rules, managed rule sets, and all other WAF settings for each site. You can associate a WAF policy with a path-based rule for even more customization down to the Universal Resource Identifier, also called URI level. If particular pages within a site require distinct policies, you can modify the WAF policy to exclusively affect a specific URI. This might apply to a payment or sign-in page, or any other URIs that need an even more specific WAF policy than the other sites behind your WAF. You have now learned about the 3 levels of WAF policies: global, per site, and per URI. Let us go through an example to comprehend the implementation of these policies. Say you have 3 sites: contoso.com, fabricam.com, and adatum.com, all behind the same application gateway. You need WAF applied to all 3 sites, but you need extra security for adatum.com as customers visit, browse, and buy products through this site. Now, let's identify how policies can be implemented based on the requirements in this example. For the WAF, use a global policy with basic settings, exclusions, or custom rules to prevent false positives from blocking traffic. As fabricam.com and contoso.com are static pages with no SQL backend, there's no need for global SQL injection rules. So, you can disable those rules in the global policy. Do you think the specified global policy is suitable for all 3 sites? Let's discuss further about this. While the global policy is fine for contoso.com and fabricam.com, adatum.com requires more caution as it manages sign-in info and payments. To address this, you can apply a per-site policy to the adatum listener and leave the SQL rules running. Also, assume that there is a cookie blocking some traffic, so exclude that cookie to prevent false positive. Further in this example, consider that adatum.com/payments URI is where you need to be careful. So apply another policy on that URI and leave all rules enabled, and also remove all exclusions. So, let's recapitulate what policies you have identified to apply in this example. In this example, you have a global policy that applies to 2 sites. You have a per-site policy that applies to 1 site, and then a per-URI policy that applies to 1 specific path-based rule. Finally, you should know that all new WAF settings, including custom rules, managed rule set configurations, and exclusions, exist in a WAF policy. If you have an existing WAF, these settings may still exist in your WAF configuration. Let's summarize the learning covered in this video. In this video, you learned how WAF secures web applications, what are the primary features of WAF, and how WAF policies can be associated at different levels. An e-commerce organization operates globally with distinct sites and back-end setups per region. As the organization grows, some of its customers experience slow page load times or even downtime due to high traffic volume or server failures. The organization wants to ensure that its customers are always routed to the closest available server to minimize latency and improve user experience. Chris, the security engineer working in this organization, identifies that Azure Front Door as a global load balancer and traffic manager can resolve these issues. Hello, and welcome to the video, Configure and Manage Azure Front Door. In this video, you will learn how Azure Front Door routes and manages web traffic and what features are included with Front Door. Azure Front Door enables you to optimize global web traffic routing for peak performance and instant global failover to ensure high availability. This enables you to transform your global, multi-region consumer and enterprise applications into robust, high-performance personalized modern applications, APIs, and content that reaches a global audience with Azure. Let's now understand how Front Door works. Front Door works at Layer 7, or HTTP/HTTPS layer, and uses split TCP-based Anacast protocol. Front Door ensures that your end users promptly connect to the nearest front door point of presence, also called POP. Based on your routing method selection, Front Door routes client requests to the fastest and most available application backend. Front Door offers various traffic routing methods and backend health monitoring options to fit application needs and automatic failover models. Like Traffic Manager, Front Door is resilient to failures, including the failure of an entire Azure region. Here is an example depicting the implementation of Azure Front Door. Azure Front Door pools 2 instances of a web application running in different Azure regions. you create a front door configuration based on equal weight and same priority backends. This configuration directs traffic to the nearest site that runs the application. Azure Front Door continually monitors the web application and automatically switches to the next available site if the nearest site is down. To know about configuring Azure Front Door, it is important to explore the features included with Front Door. The first feature is that it accelerates application performance. Front Door utilizes a split TCP-based Unicast protocol to ensure that your end users are quickly connected to the nearest front door POP. Next, Front Door delivers high availability for your critical applications with smart health probes that monitor backends for latency and availability and provide instant automatic failover if a backend goes down. The next feature included with Front Door is Uniform Resource Locator, also called URL-based routing. URL path-based routing allows you to route traffic to backend pools based on the URL paths of the request. This feature can be utilized to route requests for various types of content to separate backend pools. Multiple site hosting enables you to configure more than one website on the same Front Door configuration. The cookie-based session affinity feature is useful when you want to keep a user session in the same application backend. The next feature to consider is TLS termination. Front Door supports TLS termination at the edge. Users can establish a TLS connection with Front Door instead of the application backend over long-haul connections. Moving further, let's discuss the feature of custom domains and certificate management. When you use Front Door to deliver content, a custom domain must display your own domain name in the Front Door URL. Another feature included with Front Door is the application layer security. Azure Front Door lets you create custom web application firewall, also called WAF, rules to control access and secure your HTTP, HTTPS workload against exploitation using client IP addresses, country codes, and HTTP parameters. As secure communication gains importance in the industry, web applications are expected to redirect HTTP traffic to HTTPS automatically. Front Door also supports URL rewrite. It allows configuring an optional custom forwarding path to use when constructing the request to forward to the backend. Last but not least, let us consider the protocol support for Front Door. Azure Front Door natively supports end-to-end IPv6 connectivity and HTTP2 protocol. You have learned that routing to the Azure Front Door environments leverages Unicast for both domain name system, also called DNS, and HTTP traffic. So, user traffic will go to the closest environment in terms of network topology, with the fewest hops. This architecture typically offers better round-trip time for end users, maximizing the benefits of split TCP. Front Door organizes its environments into primary and fallback rings. The outer ring has environments closer to users, providing lower latencies. The inner ring has environments that can handle failover for the outer ring if an issue arises. The outer ring is the preferred target for all traffic, but the inner ring is necessary to handle traffic overflow from the outer ring. Each front-end host or domain served by Front Door has a primary, Virtual Internet Protocol, also called VIP, and a fallback VIP. The primary VIP is announced by environments in both rings, whereas the fallback VIP is only announced by environments in the inner ring. Let's summarize what you learned in the video. In this video, you learned how Azure Front Door routes and manages web traffic and what features are included with Front Door. A financial services consulting firm has critical business operations and sensitive data that need to be transferred between its on-premises data center and its cloud infrastructure in Azure. The firm's IT team is concerned about the security, reliability, and performance of its connection, especially when dealing with high volumes of data traffic. The IT team is considering using Azure ExpressRoute to establish a private and dedicated network connection between its on-premises infrastructure and Azure. This will ensure secure, fast, and consistent communication between your resources in both locations. Hello, and welcome to the video Review ExpressRoute. In this video, you will learn the configuration aspects related to ExpressRoute. You will learn about the ExpressRoute encryption and related encryption technologies. Finally, you will learn about ExpressRoute Direct and its features. ExpressRoute establishes a direct, private link from your wide area network, also called WAN, to Microsoft services, including Azure, rather than using the public internet. On the other hand, site-to-site virtual private network, also called VPN, traffic travels over the public internet while being encrypted. You can configure a site-to-site VPN as a secure failover path for ExpressRoute. Else, you can use site-to-site VPNs to connect to sites that are not part of your network, but that are connected through ExpressRoute. This configuration requires two virtual network gateways for the same virtual network, one using the gateway type VPN and the other using the gateway type ExpressRoute. Moving forward, let's understand the ExpressRoute encryption. Azure Virtual WAN connects your on-premises network to Azure using a secure VPN connection, Internet Protocol Security, also called IPsec, Internet Key Exchange, also called IKE. This connection is established through private peering on an Azure ExpressRoute circuit. Let's refer to the given image to understand an example of VPN connectivity over ExpressRoute private peering. The image shows a network within the on-premises network connected to the Azure Hub VPN gateway over ExpressRoute private peering. The connectivity establishment is straightforward. First, establish ExpressRoute connectivity with the ExpressRoute circuit and private peering. Next, establish the VPN connectivity. Routing between on-premises networks and Azure is critical in this configuration, as it needs to function over both the ExpressRoute and VPN connections. ExpressRoute supports a couple of encryption technologies to ensure the confidentiality and integrity of the data traversing between your network and Microsoft's network. The first of these technologies is point-to-point encryption by Media Access Control Security, also called MACsec. The other one is end-to-end encryption by Internet Protocol, also called IPsec and MACsec. MACsec is an IEEE standard that encrypts data at the Media Access Control, also called MAC, or Network Layer 2. When connecting to Microsoft via ExpressRoute Direct, you can use MACsec to encrypt the physical links between your network devices and Microsoft's devices. MACsec is disabled on ExpressRoute Direct ports by default. To ensure MACsec, you must provide your own encryption key and store it in Azure Key Vault. You decide when to rotate the key. IPsec is an IETF standard that encrypts data at the Internet Protocol, also called IP level or Network Layer 3. You can use IPsec to encrypt an end-to-end connection between your on-premises network and your virtual network, also called VNet on Azure. So, how do you achieve end-to-end encryption by IPsec and MACsec? MACsec makes sure that your physical links to Microsoft are secure. On the other hand, IPsec ensures that your virtual networks on Azure are connected securely from end to end. You can enable them independently. Next, let us learn about ExpressRoute Direct. ExpressRoute Direct lets you connect directly to Microsoft's global network at peering locations strategically distributed across the world. ExpressRoute Direct provides dual 100 gigabytes or 10 gigabytes connectivity, which supports active-active connectivity at scale. To know more about ExpressRoute Direct, let us learn about some of its features. Keep in mind that the video will cover some, but not all, of the key features provided by ExpressRoute Direct. The first feature to focus on is massive data ingestion into services like storage and Cosmos DB. ExpressRoute Direct can now support 40 gigabytes and 100 gigabyte circuits SKUs in addition to 100 gigabyte circuits. The physical port pairs only have 100 or 10 gigabytes options, but multiple virtual circuits can be used. The next feature of ExpressRoute Direct is about physical isolation for industries that are regulated and require dedicated and isolated connectivity, such as banking, government, and retail. Another feature to consider is about granular control of circuit distribution based on business unit. It is important to know that ExpressRoute Direct supports both Q-in-Q and .1Q VLAN tagging. With Q-in-Q VLAN tagging, You can have separate routing domains for each ExpressRoute circuit. Azure dynamically allocates an S tag at circuit creation and cannot be changed. Each peering on the circuit, private and Microsoft, will utilize a unique C tag as the VLAN. The C tag doesn't have to be unique across circuits on the ExpressRoute direct ports. .1Q VLAN tagging allows for a single tagged VLAN on a per ExpressRoute direct port pair basis. A C tag used on a peering must be unique across all circuits and peerings on the ExpressRoute direct port pair. ExpressRoute Direct provides the same enterprise-grade service level agreement, also called SLA, with active-active redundant connections into the Microsoft Global Network. ExpressRoute infrastructure is also redundant, and the connection to the network is diverse and can be scaled as per customer needs. Let's recap the learning covered in the video. In this video, you learned about the configuration aspects related to ExpressRoute, ExpressRoute encryption and related encryption technologies, and ExpressRoute Direct and its features. Well done! You've completed learning the concepts related to network security. You were introduced to network security as part of your defense strategy. Let's recap what you learned. Initially, you learned about the role of network security groups, also called NSGs, in providing advanced security for virtual machines, frequently referred to as VMs. NSGs filter the network traffic to and from Azure resources to protect them from unauthorized access and cyber threats. You learned about deploying and configuring NSGs. You also learned the limitations of implementing NSGs. Next, you learned about creating application security groups, also called ASGs. ASGs enable you to configure network security as a natural extension of an application structure. With ASGs, you can apply your security policy at scale without manually maintaining explicit IP addresses. You learned about the role and benefits of ASGs. You also learned about the constraints of ASGs. Moving further, you learned about service endpoints. Service endpoints enable private IP addresses in the virtual network to reach the endpoint of an Azure service without needing a public IP address on the virtual network. You learned about the role and benefits of service endpoints in network security. You also learned about configuring service endpoints. Next, you explored the Azure Private Link feature. Azure Private Link enables you to access Azure PaaS services and Azure-hosted customer-owned and partner services over a private endpoint in a virtual network. Your understanding of NSGs was supported by the exciting opportunity to deploy and configure NSGs through hands-on exercises. You also attempted the exercise on service endpoints and securing storage. The next major concept that you learned was Azure Application Gateway, which encrypts data that is traversing the network from users to application servers. You learned about implementing and configuring Azure Application Gateway to protect your perimeter. Based on the learning covered, you identified that Azure Application Gateway provides features like load balancing hypertext transfer protocol, also called HTTP traffic, web application firewall, and support for SSL encryption of your data. To understand Application Gateway in detail, you explored the components of Application Gateway, which include the front-end port, the listener, and the back-end pool. You learned about configuring the back-end pool and listener. Your understanding of Application Gateway did not end with theoretical concepts. You also had the opportunity to attempt the hands-on exercise on application service groups. You know that preventing attacks, such as SQL injection and cross-site scripting, is challenging in application mode. So how does one deal with these challenges? You identified that the Azure Web Application Firewall, also called WAF, provides a solution to these challenges. Azure WAF is a centralized, cloud-native security platform to protect web applications. You learned how WAF secures web applications and what are the primary features of WAF. Next, think about how you can optimize global traffic routing for peak performance and instant global failover to ensure high availability. You identified that this can be done using Azure Front Door. You learned how Azure Front Door routes and manages web traffic and what features are included with Front Door. Finally, you learned about using Azure ExpressRoute. ExpressRoute establishes a direct, private link from your wide area network, also called WAN, to Microsoft services, including Azure, rather than using the public internet. This will ensure secure, fast, and consistent communication between your resources in both locations. Whoa, that was a fantastic learning experience. You're now ready to move to the next step of attempting the graded assessment for this module. Good luck with the module quiz.
Imagine that you work for the IT department of a retail company that's recently started using virtual machines because of numerous advantages. These include reduced overhead costs, scalability, and centralized management. However, there's always a possibility that a piece of malware can detect that it's running in a virtual environment and try to break out. Hence, you've been asked to devise the optimum way to ensure the security of these machines and the associated private networks. Hello, and welcome to the video, Host Security as part of your defense strategy. In this video, you'll learn all about securing Azure Virtual Machines, also called VMs, private network security, and the various aspects of security management and threat defense. You'll also see how Azure uses layers for protection in its infrastructure. Azure provides a networking infrastructure powered by Microsoft to provide a secure connection for virtual VMs between shared environments and to be the secure link between the data center and the cloud. It supports thousands of customers. As customers using active VMs continues to increase, ensuring the security and confidentiality of network traffic information is paramount. Let's start by exploring how Azure secures its virtual machines. For Azure to guarantee customers' data in shared environments, it uses a combination of logical isolation, access control, firewalls, authentication, and encryption mechanisms. Microsoft Azure also implements a comprehensive information security policy, while following industry-standard control frameworks like SOC 1, SOC 2, and ISO 27001 across its data center operations. Azure ensures its physical and virtual infrastructure by employing third-party auditors to certify adherence. Conventionally, a company's IT department has to control network systems and monitor the physical access to hardware. In this regard, the company employs the services of an employee or contractor to procure, configure, and manage the physical network, routers, and firewalls. What do you think happens in the cloud service model of Azure? The network safety and operations duties are shared between the cloud provider and the customer. Here, customers don't have physical access to the cloud data center, but they have the freedom to implement the logical equivalent within the cloud platform through applications and virtual private networks. This physical and coherent partition empowers clients to depend on the vital security capacities conveyed by Azure as they assemble their foundation. Next, let's move on to see Azure Private Network Security. I'm sure you'll agree that a customer's security is paramount when it comes to cloud services. Azure maintains a customer's security through a distributed virtual firewall. Additionally, a customer can deploy multiple logically isolated private networks as another step for network security. This network is generally thought of as two separate divisions. The first division is deployed network. Deployed systems at the network level can be separated from each other, while VMs within a deployment can communicate with each other through private IP addresses. The second division is virtual network. Multiple deployments at the network level can be aligned on the same virtual networks. Each virtual network is isolated from the other virtual networks and communicates with a private IP address. The management of these networks can be similar to conventional on-premise infrastructures. Suppose an application sends or receives sensitive information over an internal private network, for example through a VPN. The data can be encrypted via IPsec, SSL, or TLS, or other application-level encryption innovations. Clients with higher privacy or security concerns ought to guarantee that every private correspondence between VMs inside a locale is encrypted. This image shows you an isolated multi-tier application hosted within Azure. Next, let's learn about Azure security management and threat defense practices. Securing remote control of VMs, architects, and administrators can make a VM utilizing the Azure Management Portal or Windows PowerShell. At the point when an administrator uses the Azure Management Portal to create a VM, Remote Desktop Protocol, also called an RDP, and Remote Windows PowerShell ports are opened as a matter of course. The Azure Management Portal at that point doles out RDP and Remote Windows PowerShell random port numbers to decrease the odds of a successful automated network-based attack. Protecting against denial of service to ensure Azure availability, Microsoft provides a distributed denial of service, also called DDoS resistance framework. That is a piece of Azure's continuous checking process, and is consistently enhanced through infiltration testing. Securing connections from VMs to Microsoft Azure SQL database. Microsoft Azure SQL database also features an integrated firewall to channel incoming traffic. At first, all communication with the SQL database is blocked. To secure connections with the database, the admin must build firewall rules in the Azure SQL database, permitting the public IP address of the VM in Azure to communicate with the information source. Finally, let's look at the several layers of security barriers that form a part of Azure's defense strategy. Layer A, the network access layer, isolates Azure's private system from the network. Layer B, this is Azure's DDoS, DOS, or IDS layer, which utilizes more diverse strategies than physical data center organizations to accomplish similar security goals. Layer C, host firewalls ensure every one of the hosts and the VLANs give extra security to critical resources. Layer D, conformance with security and protection prerequisites incorporates two-factor confirmation for administrators. Let's summarize. In this video, you learned how Azure secures its virtual machines, Azure Private Network Security, Azure Security Management and Threat Defense Practices, the several layers of security barriers that form a part of Azure's defense strategy. Rapidly increasing digitization is changing the way business is done today. More and more devices can benefit from decreased latency and increased bandwidth. As a result, business transformation has never been easier. But just like anything else, it's a double-edged sword that cuts both ways. There's also now an ever-increasing scope for cyber attacks. There's opportunity and risk with this new wave of endpoints. Proper endpoint protection has become the need of the hour. Hello, and welcome to the video, Enable Endpoint Protection. In this video, you'll learn how to use Microsoft Defender for endpoint security, its capabilities, and the several Microsoft solutions it can integrate. Before we go ahead, let's ask, what is endpoint protection? It's the ability to protect the assets that are the last touch point of the network it's connected to. Microsoft Defender for Endpoint is an enterprise endpoint security platform designed to help enterprise networks prevent, detect, investigate, and respond to advanced threats. How does it work? Microsoft Defender for Endpoint uses a specific combination of technologies. Built into Windows 10 and Microsoft's robust cloud service, endpoint behavioral sensors are embedded in Windows 10. These sensors collect and process behavioral signals from the operating system and send this sensor data to your private, isolated cloud instance of Microsoft Defender for Endpoint. Then there's cloud security analytics. Leveraging big data, device learning, and unique Microsoft optics across the Windows ecosystem, enterprise cloud products such as Office 365 and online assets, behavioral signals are translated into insights, detections, and recommended responses to advanced threats. Finally, there's threat intelligence, generated by Microsoft hunters and security teams and augmented by threat intelligence provided by partners. Threat intelligence enables Defender for Endpoint to identify attacker tools, techniques, and procedures and generate alerts when observed and collected sensor data. Now let's look at some of the key capabilities of Microsoft Defender for Endpoint. Built-in core vulnerability management capabilities use a modern risk-based approach to the discovery, assessment, prioritization, and remediation of endpoint vulnerabilities and misconfigurations. The attack surface reduction set of capabilities provides the first line of defense in the stack. The capabilities resist attacks and exploitation by ensuring configuration settings are properly set and exploit mitigation techniques are applied. This set of capabilities also includes network protection and web protection, which regulates access to malicious IP addresses, domains, and URLs. To further reinforce the security perimeter of your network, Defender for Endpoint uses next-generation protection designed to catch all types of emerging threats. Endpoint detection and response capabilities are implemented to detect, investigate, and respond to advanced threats that may have surpassed the first two security pillars. Advanced Hunting provides a query-based threat hunting tool that lets you proactively find breaches and create custom detections. In conjunction with being able to respond to advanced attacks quickly, Defender for Endpoint offers automatic investigation and remediation capabilities that help reduce the volume of alerts in minutes at scale. Defender for Endpoint includes Microsoft Secure Score for devices to help you dynamically assess the security state of your enterprise network, identify unprotected systems, and take recommended actions to improve your organization's overall security. It has Microsoft Threat Experts. This is Defender for Endpoint's new managed threat hunting service, which provides proactive hunting, prioritization, and additional context and insights that further empower security operations centers, also called SOCs, to identify and respond to threats quickly and accurately. Next, we'll learn about how Defender of Endpoint can be integrated. Let's look at centralized configuration and administration, as well as Application Program Interface, also called API. Did you know you can integrate Defender for Endpoint into your existing workflows, increasing and smoothing operational efficiency? That's not all. Defender for Endpoint directly integrates with various Microsoft solutions, including Microsoft Defender for Cloud, Microsoft Sentinel, Intune, Microsoft Defender for Cloud Apps, Microsoft Defender for Identity, Microsoft Defender for Office, and Skype for Business. Finally, Microsoft 365 Defender, Defender for Endpoint, and various Microsoft security solutions form a unified pre- and post-breach enterprise defense suite that natively integrates across endpoint, identity, email, and applications to detect, prevent, investigate, and automatically respond to sophisticated attacks. What more could you ask for? Let's summarize. In this video, you learned how Microsoft Defender for Endpoint works, its key features and capabilities, the various Microsoft solutions it can be integrated with. Imagine that you're going on an extended family holiday. As lovely as that sounds, one of your primary concerns in all probability is how safe will your empty home be because of recent thefts in the neighborhood. You begin to explore the different home security options and get one installed at the soonest. An optimal home security system would secure all parts of your house with authorized, compatible, and quality electronic devices. This would include sensors, alarms, cameras, and what have you. It would function accurately the first and every time an attack is attempted. Similarly, for the most secure conditions for your company, you must ensure security from the time of purchase of a new device to its first usage and beyond. Zero trust means you don't purchase from generic retailers, but only supply hardware from an authorized OEM supporting autopilot. Hello, and welcome to the video, Define a Privileged Access Device Strategy. In this video, you'll learn how you can deploy Root of Trust to ensure the most secure conditions for your company, the different levels of device security and how they're used, and some common security measures. Just like a good engine needs a good car to function at its best, Root of Trust is deployed using Windows Autopilot technology with hardware that meets modern technical requirements. Autopilot lets you leverage Microsoft OEM-optimized Windows 10 devices to secure a workstation. These devices come in a known good state from the manufacturer. Instead of re-imaging a potentially insecure device, Autopilot can transform a Windows 10 device into a business-ready state. It applies settings and policies, installs apps, and even changes the edition of Windows 10. You can refer to the images shown here. Let's look at hardware Root of Trust. To have a secure workstation, you need to make sure the following security technologies are included on the device. Trusted Platform Module, also called TPM 2.0. BitLocker Drive Encryption. Unified Extensible Firmware Interface, also called UEFI Secure Boot. Drivers and firmware distributed through Windows Update. Virtualization and Hypervisor Protected Code Integrity, or HVCI, enabled. Drivers and apps HVCI ready. Windows Hello. Direct Memory Access Input-Output, also called DMA/IO protection. System Guard and Modern Standby. Just like your home security varies depending on who you are protecting your home from, there are different levels of device security as shown in the table here. So an enterprise device is used by home users, small business users, general purpose developers, and small enterprises. It can run any application and browse any website. It is kept secure using anti-malware, virus protection, and policy-based security posture. On the other hand, a specialized device is used by specialized or secure enterprise users. It can run approved applications but cannot install apps. Email and web browsing are allowed. However, it will not have any admin controls. A privileged device, as the name suggests, is used for very extremely sensitive roles for IT operations. It will have no local admins, no productivity tools, and lockdown browsing. It is a privileged access workstation, also called PAW. Let's dive deeper into device security and learn more about device security controls. This chart shows the level of device security controls based on how the device will be used. A secure workstation requires it to be part of an end-to-end approach, including device security, account security, and security policies applied to the device at all times. Here are some common security measures you should consider implementing based on your user's needs. Using a device with security measures directly aligned to the security needs of its users is the more secure solution. Let's recap. In this video, you learned how you can use Root of Trust to ensure the most secure conditions for your company, the hardware of Root of Trust, the different levels of device security, and common security measures that you can implement based on the user's needs. As work from anywhere becomes the norm, organizations today want to ensure security. At the same time, they need to allow users access to their applications and networks from diverse locations and devices. As always, the challenge is to balance mitigating threats and making work easy to do and accessible for the user. Privileged access workstations, frequently called PAWs, provide a dedicated system for sensitive tasks protected from internet attacks and threat vectors. Separating these sensitive tasks and accounts from the daily use workstations and devices offers powerful protection from phishing attacks, applications, and operating systems, also called OS, vulnerabilities, various impersonation attacks, and credential theft attacks such as keystroke logging, pass the hash, and pass the ticket. Hello and welcome to the video. Deploy privileged access workstations. In this video, you'll learn what a PAW is, its architecture, and the security risks that PAWs need to be protected against. You'll also get acquainted with a jump box and how it works. So first, let's see what a PAW is. A PAW is a hardened, lockdown workstation that provides high security assurances for sensitive accounts and tasks. PAWs are recommended for the administration of identity systems, cloud services, private cloud fabric, and sensitive business functions. PAWs should always run the most up-to-date and secure OS to provide the greatest security. Microsoft strongly recommends Windows 10 Enterprise, which includes several additional security features not available in other editions, in particular Credential Guard and Device Guard. The PAW security controls are focused on mitigating high-impact and high-probability risks of compromise. Let's see what these risks and attacks are. There are internet attacks. Isolating the PAW from the open internet is a crucial element in ensuring the PAW is not compromised. Then there's usability risk. Administrators will be motivated to create workarounds to make their jobs easier if a PAW is too challenging to use for daily tasks. You also have environment risks. These are addressed by minimizing the use of management tools and accounts with access to the PAWs to secure and monitor these specialized workstations. You have supply chain tampering. This includes validating the integrity of all installation media, known as the clean source principle, and using a trusted and reputable supplier for hardware and software. Finally, there's the possibility of physical attacks. Because PAWs can be physically mobile and used outside of physically secure facilities, they must be protected against attacks that leverage unauthorized physical access to the computer. Next, you'll see the architecture overview of PAWs. This diagram depicts a separate channel for administration, a highly sensitive task created by maintaining separate, dedicated administrative accounts and workstations. This architectural approach builds on the protections found in the Windows 10 Credential Guard and Device Guard features and goes beyond those protections for sensitive accounts and tasks. This methodology is appropriate for accounts with access to high-value assets. What are these assets? Let's take a look. The first of these administrative privileges. PAWs provide increased security for high-impact IT administrative roles and tasks. This architecture can be applied to the administration of many types of systems, including Active Directory domains and forests, Microsoft Azure Active Directory tenants, Microsoft 365 tenants, process control networks called PCNs, supervisory control and data acquisition, that is, SCADA systems, automated teller machines popularly known as ATMs, and point of sale, that is, POS devices. The second refers to high sensitivity information workers. The PAW approach can also protect highly sensitive information worker tasks and personnel, such as pre-announcement merger and acquisition activity, pre-release financial reports, organizational social media presence, executive communications, unpatented trade secrets, sensitive research, or other proprietary or sensitive data. This guidance does not discuss the configuration of these information worker scenarios in depth or include this scenario in the technical instructions. Next, you'll learn about a jump box. Administrative jump box architectures set up a small number of administrative console servers and restrict personnel to using them for administrative tasks. This is typically based on remote desktop services, a third-party presentation virtualization solution, a virtual desktop infrastructure, or VDI technology. This approach is frequently proposed to mitigate risk to administration. It provides some security assurances, but the jump box approach is vulnerable to certain attacks because it violates the clean source principle. The clean source principle requires all security dependencies to be as trustworthy as the secured object. This figure depicts a simple control relationship. Any subject in control of an object is a security dependency of that object. If an adversary can control a security dependency of a target object or subject, they can control that object. The administrative session on the jump server relies on the integrity of the local computer accessing it. If this computer is a user workstation subject to phishing attacks and other internet-based attack vectors, then the administrative session is also subject to those risks. The default configuration in this PAW guidance installs administrative tools on the PAW, but a jump server architecture can also be added if required. This figure shows how reversing the control relationship and accessing user apps from an admin workstation gives the attacker no path to the targeted object. The user jump box is still exposed to risk, so appropriate protective controls, detective controls, and response processes should still be applied for that internet-facing computer. Now it's time to recap. In this video, you learned what a PAW is, the risks it needs to be protected from, how those risks are mitigated, the architecture of a typical PAW, and what a jump box is and how it works. You might have heard of a master recording in music. It's the original soundtrack recording that contains the different components of the audio as separate recordings. This master copy is needed to make any changes to the original track, also known as remasters. In the same way, a virtual machine template is a master copy of a virtual machine, also known as a VM. That usually includes the guest operating system or OS, a set of applications, and a specific VM configuration. Virtual machine templates are used when you need to deploy multiple VMs and ensure they are consistent and standardized. Hello, and welcome to the video, Create Virtual Machine Templates. In this video, you'll learn about Azure Resource Manager and its key features and explore template design. But before diving into configuring VM policies and templates, you need to understand the features and functionality of Azure Resource Manager. A Resource Manager is the deployment and management service for your Azure subscription. It provides a consistent management layer that allows you to create, update, and delete resources in your Azure subscription. That's not all. You can use its access control, auditing, and tagging features to help secure and organize your resources after deployment. The Resource Manager API handles your request when you take actions through the Azure portal, Azure PowerShell, the Azure CLI, or the command line interface. The Representational State Transfer Application Programming Interface, referred to as REST APIs, or Client Software Development Kits, or SDKs. And here's the best part, because the same API handles all requests, you get consistent results and capabilities in all the different tools. When using a resource manager, you need to know some key terms. Let's see what they are. A resource provider is a service that supplies Azure resources. For example, a common resource provider is Microsoft.Compute, which supplies the VM resource. Microsoft.Storage is another common resource provider. The Resource Manager template is a JavaScript object notation, or JSON file, that defines one or more resources to deploy to a resource group or subscription. You can use the template to consistently and repeatedly deploy the resources. Finally, the declarative syntax lets you state, here's what I intend to create, without having to write the sequence of programming commands to create it. The Resource Manager template is an example of a declarative syntax. In the file, you define the properties for the infrastructure to deploy to Azure. You can use the Resource Manager template to define your VMs. After they're defined, you can easily deploy and redeploy them. It's recommended that you periodically redeploy your VMs to force the deployment of a freshly updated and security-enhanced VM OS. Now let's explore template design. How you define templates and resource groups is entirely up to you and how you want to manage your solution. For example, you can deploy your 3-tier application through a single template to a single resource group, as seen in this image. But you don't have to define your entire infrastructure in a single template. Often, it makes sense to divide your deployment requirements into a set of targeted, purpose-specific templates. You can easily reuse these templates for different solutions. To deploy a particular solution, you create a master template that links all the required templates. If you envision your tiers having separate life cycles, you can deploy your 3 tiers to separate resource groups. Notice how the resources can still be linked to resources in other resource groups, as illustrated here. It's important to note that when you deploy a template, the Resource Manager converts it into REST API operations. Let's recap. In this video, you learned what are the key features and functionalities of the Azure Resource Manager, the key terms associated with the Azure Resource Manager, and how templates are created and defined. With rapid digitization and work from anywhere becoming the norm, remote access has become necessary for corporations, business owners, employees, and technicians to access their work computers and files remotely and securely. Hello, and welcome to the video, Enable and Secure Remote Access Management. In this video, you'll learn how to connect and sign into the virtual machines you created on Azure, also known as VMs. You will also learn about Azure Bastion as a service, its architecture, and its critical features. Did you know that once successfully connected, you can work with the VM as if you were locally logged onto its host server? But first, let's see how you can connect to a Windows VM. The most common way to connect to a Windows-based VM running in Azure is by using Remote Desktop Protocol, also called an RDP. Most versions of Windows natively contain support for the RDP. If you're connecting to a Windows VM from a Mac, you'll need to install an RDP client for Mac. If you use PowerShell and have the Azure PowerShell module installed, you may connect using the AZ Remote Desktop File commandlet. Next, you'll see how to connect to a Linux-based VM. You need a secure shell protocol called SSH client to connect the Linux-based VM. The most used free tool is the PuTTY SSH terminal. The following shows the PuTTY configuration dialog. Now let's look at the Azure Bastion service in detail. Azure Bastion is a service you deploy that enables you to connect to a VM using your browser and the Azure portal or via the native SSH, that is Secure Shell or RDP client already installed on your local computer. Azure Bastion is a platform as a service, or PaaS, that you provision inside your virtual network. It provides secure and seamless RDP or SSH connectivity to your virtual machines directly over TLS from the Azure portal or via the native client. When you connect via Azure Bastion, your virtual machines don't need a public IP address, agent, or special client software. Bastion provides secure RDP and SSH connectivity to all the VMs in the virtual network in which it is provisioned. Azure Bastion protects your virtual machines from exposing RDP or SSH ports to the outside world while providing secure RDP or SSH access. If you look at the architecture of Azure Bastion, you'll see that it is deployed to a virtual network and supports virtual network peering. Specifically, Azure Bastion manages RDP or SSH connectivity to VMs created in the local or peered virtual networks. RDP and SSH are some of the fundamental means through which you can connect to your workloads running in Azure. Exposing RDP or SSH ports over the internet isn't desired and is seen as a significant threat surface. This is often due to protocol vulnerabilities. To contain this threat surface, you can deploy Bastion hosts, also known as jump servers, on the public side of your perimeter network. Bastion host servers are designed and configured to withstand attacks. Bastion servers also provide RDP and SSH connectivity to the workloads sitting behind the Bastion and further inside the network. This figure shows the architecture of an Azure Bastion deployment, as you can see in this diagram. The Bastion host is deployed in the virtual network. The user connects to the Azure portal using any HTML5 browser. The user selects the virtual machine to connect to. The RDP or SSH session opens in the browser with a single click. No public IP is required on the Azure VM. It has several benefits. Let's explore them. You can access the RDP and SSH session directly in the Azure portal using a single-click, seamless experience. Azure Bastion uses an HTML5-based web client automatically streamed to your local device. Your RDP or SSH session is over Transport Layer Security, or TLS, on port 443. This enables the traffic to traverse firewalls more securely. Bastion supports TLS 1.2 and above. Older TLS versions are not supported. Azure Bastion opens the RDP or SSH connection to your Azure VM using the private IP address. You don't need a public IP address. You don't need to apply any network security groups or NSGs to the Azure Bastion subnet. Because it connects to your VMs over private IP, you can configure your NSGs only to allow RDP or SSH from Azure Bastion. This removes the hassle of managing NSGs each time you need to connect to your virtual machine securely. Azure Bastion is a fully managed PaaS from Azure that is hardened internally to provide secure RDP or SSH connectivity. Your VMs are protected against port scanning by rogue and malicious users because you don't need to expose the VMs to the internet. Azure Bastion sits at the perimeter of your virtual network, so you don't need to worry about hardening each of the VMs in your virtual network. The Azure platform protects against zero-day exploits by keeping the Azure Bastion hardened and always up to date for you. Let's recap. In this video, you learned how to connect to and sign into a Windows VM, how to connect to and sign into a Linux-based VM, Azure Bastion as a service and its architecture, as well as key benefits. The Public Information Officer in your department maintains a non-public facing website for use by the local media. She uses her mobile device to update content on the media website so that local media outlets can stay informed about current events. To prevent unauthorized or incorrect information from being presented to the media, this site must be as secure as possible. As the administrator, one approach you can take to improve security is to keep the website-hosted virtual machine current with the latest updates. But the question is, how can you do that? Hello, and welcome to the video, Configure Update Management. In this video, you'll be introduced to Azure's Update Management solution. What are its uses and advantages and how to configure it? So what is Update Management? Azure Update Management is a service included as part of your Azure subscription. This service helps you assess your update status across your environment and manage your Windows Server and Linux Server updates from a single location, for both your on-premises and Azure environments. You can assess the status of available updates on computers and manage the process of installing required updates for servers. The best part is that the Azure Update Management solution is available at no additional cost, as you pay only for the log data that Azure Log Analytics stores. What's more, you can easily enable it for Azure and on-premises virtual machines, frequently referred to as VMs. Wondering how you can try it? Just navigate to your VM tab in Azure and then enable Update Management for one or more of your VMs. You can also enable Update Management for VMs directly from your Azure Automation account. Making updates easily is one of the key factors in maintaining good security hygiene. There are several advantages of the Update Management solution. 1. There are no agents or additional configurations within the virtual machine. 2. You can run updates without logging into the VM. You also don't have to create passwords to install the update. 3. The Update Management solution lists missing updates and provides information about failed deployments in an easy-to-read format. 4. Update Management can be used to natively onboard machines in multiple subscriptions in the same tenant. To manage machines in a different tenant, you must onboard them as non-Azure machines. Computers that Update Management manages use the following configurations to perform assessment and update deployments. It includes Microsoft Monitoring Agent, frequently referred to as MMA for Windows or Linux. Desired State Configuration, frequently referred to as DSC in Windows PowerShell for Linux. Hybrid Runbook Worker in Azure Automation, and Microsoft Update or Windows Server Update Services, frequently referred to as WSUS for Windows computers. Azure Automation uses runbooks to install updates. You can't view these runbooks and they don't require any configuration. When an update deployment is created, it creates a schedule that starts a master update runbook at the specified time for the included computers. The master runbook starts a child runbook on each agent to install the required updates. The displayed diagram is a conceptual depiction of the behavior and data flow together with how the solution assesses and applies security updates to all connected Windows Server and Linux computers in a workspace. You can use the Update Management solution to manage updates and patches for your Windows and Linux virtual machines. From your Azure Automation account, you can onboard virtual machines, assess the status of available updates, schedule installation of required updates, and finally, review deployment results to verify that updates were applied successfully to all virtual machines for which Update Management is enabled. The Log Analytics agent for Windows and Linux needs to be installed on the VMs that are running on your corporate network or other cloud environments in order to enable them with Update Management. Note that after you enable Update Management for your machines, you can view machine information by selecting Computers. You can view information about machine name, compliance status, environment, OS type, critical and security updates installed, other updates installed, and update agent readiness for your computers. Computers that have recently been enabled for Update Management might not have been assessed yet. The compliance state status for those computers will be not assessed. Now let's understand update inclusion. Azure Update Management provides the ability to deploy patches based on classifications. However, there are scenarios where you may want to explicitly list the exact set of patches. Common scenarios include allowing specific patches after canary environment testing and zero-day patch rollouts. With update inclusion lists, you can choose exactly which patches you want to deploy instead of relying on patch classifications. Talking about supported operating systems, Update Management Solutions supports Windows and Linux, specifically Windows Server 2019, for example, Data Center or Standard including Server Core. Windows Server 2016, such as Data Center or Standard excluding Server Core, and Windows Server 2012, R2 Data Center or Standard, Windows Server 2012, and Windows Server 2008 R2 including RTM and SP1 Standard. It also supports CentOS 6, CentOS 7, and CentOS 8, Oracle Linux 6.x, 7.x, and 8x. It supports Red Hat Enterprise 6, 7, and 8. SUSE Linux Enterprise Server 11 and 12, 15 and 15.1, and lastly, Ubuntu 14.04 LTS, 16.04 LTS, and 18.04, and 20.04 LTS. Now let's understand what hybrid worker groups are. Windows computers that are directly connected to your Log Analytics workspace are automatically configured as a hybrid runbook worker. to support the runbooks that are included in this solution. Each Windows computer that's managed by the solution shows up as a system hybrid worker group for the automation account. The solutions use the naming conventions hostname FQDN_GUID. Finally, let's look at the Operations Manager management packs. If your System Center Operations Manager management group is connected to a log analytics workspace, there are certain management packs installed in Operations Manager. These management packs are also installed on directly connected Windows computers after you add the solution. You don't need to configure or manage the management packs such as Microsoft System Center Advisor Update Assessment Intelligence Pack, Microsoft.intelligencepack.updateassessment.configuration, and Update Deployment MP. Let's review. In this video, you learned about Azure Update Management Service, the advantages of the update management solution and where it can be used. You also explored update inclusions, the supported operating systems, hybrid worker groups, and the Operations Manager management packs. Imagine you're the IT head of security for a financial institution. Your organization handles sensitive customer data and critical financial transactions, and the requirement to safeguard this information is vital. As you strive to maintain a robust security posture, you realize that one of the most critical aspects is protecting the data stored on your organization's numerous devices. You have all traditional security measures like firewalls and intrusion detection systems in place. However, these systems are not enough to protect against unauthorized access and threat to the valuable data that may reside on your hard drives. This is where disk encryption helps. Hello, and welcome to the video, Deploy Disk Encryption. In this video, you'll delve into the process of deploying disk encryption, exploring its uses, advantages, and the steps involved in implementing this robust security measure. Azure Disk Encryption for Windows VMs helps protect and safeguard your data to meet your organizational security and compliance commitments. It uses the BitLocker feature of Windows to provide volume encryption for the OS and data disks of Azure virtual machines, frequently referred to as VMs, and is integrated with Azure Key Vault to help you control and manage the disk encryption keys and secrets. If you use Microsoft Defender for Cloud, you'll be alerted if you have VMs that aren't encrypted. The alerts are categorized as high severity, and the recommendation is to encrypt these VMs. Azure Disk Encryption is zone resilient, the same way as virtual machines. Let's now talk about supported VMs. Windows VMs are available in a range of sizes. Azure Disk Encryption is supported on Generation 1 and Generation 2 VMs and is also available for VMs with premium storage. However, Azure Disk Encryption is not available on basic A-series VMs or on virtual machines with less than 2 GB of memory. The supported operating systems are Windows Client, Windows 8 and later, Windows Server 2008 R2 and later, and Windows 10 Enterprise Multi-Session. Moving ahead, let's talk about the network requirements. To enable Azure Disk Encryption, the VMs must meet the following network endpoint configuration requirements. To get a token to connect to your Key Vault, the Windows VM must be able to connect to an Azure Active Directory endpoint. To write the encryption keys to your Key Vault, the Windows VM must be able to connect to the Key Vault endpoint. The Windows VM must be able to connect to an Azure storage endpoint that hosts the Azure Extension repository and an Azure storage account that hosts the VHD files. If your security policy limits access from Azure VMs to the internet, you can resolve the preceding URI and configure a specific rule to allow outbound connectivity to the IPs. Now let's understand the group policy requirements. Azure Disk Encryption uses the BitLocker external key protector for Windows VMs. For domain-joined VMs, don't push any group policies that enforce Trusted Platform Module Protectors, frequently referred to as TPM protectors. BitLocker policy on domain-joined VMs with custom group policy must include the following setting. Configure user storage of BitLocker recovery information, and then allow 256-bit recovery key. Azure Disk Encryption will fail when custom group policy settings for BitLocker are incompatible. On machines that didn't have the correct policy setting, apply the new policy, force the new policy displayed on your screen to update, and then a restart may be required. Azure Disk Encryption will fail if the domain-level group policy blocks the AES-CBC algorithm, which is used by BitLocker. Azure Disk Encryption requires an Azure Key Vault to control and manage disk encryption keys and secrets. Your Key Vault and VMs must reside in the same Azure region and subscription. Once the OS disk encryption process is complete on Linux virtual machines, the VM can be configured to run with less memory. Azure Disk Encryption requires the dmcrypt and VFAT modules to be present on the system. A virtual file allocation table, frequently referred to as VFAT, is an extension to the file allocation table, frequently referred to as FAT from Windows 95 and onward, for creating, storing, and managing files with long names. Removing or disabling VFAT from the default image will prevent the system from reading the key volume and obtaining the key needed to unlock the disks on subsequent reboots. System hardening steps that remove the VFAT module from the system are not compatible with Azure Disk Encryption. Let's review. In this video, you learned about Azure Disk Encryption for Windows VMs, the supported VMs and operating systems, and the networking requirements. In addition, you also learned about the group policy requirements and encryption key storage requirements. Imagine you're the IT manager for an organization that relies heavily on its computer systems for daily operations. With the increasing risk of cybersecurity threats, you need to ensure the safety of your organization's sensitive data and the potential impact of a security breach. In your quest to strengthen your company's defenses, you need to deploy and configure Windows Defender, a powerful security solution provided by Microsoft. Hello, and welcome to the video, Deploy and Configure Windows Defender. In this video, you'll explore the process of deploying and configuring Windows Defender, discussing its features and the steps involved in setting it up to safeguard your organization's digital assets. Did you know that Windows 10, Windows Server 2019, and Windows Server 2016 include important security features? They are Windows Defender Credential Guard, Windows Defender Device Guard, and Windows Defender Application Control. Let's begin by understanding what Windows Defender Credential Guard is. Introduced in Windows 10 Enterprise and Windows Server 2016, Windows Defender Credential Guard uses virtualization-based security enhancement to isolate secrets so that only privileged system software can access them. Unauthorized access to these secrets might lead to credential theft attacks, such as pass-the-hash or pass-the-ticket attacks. Windows Defender Credential Guard helps prevent these attacks by helping protect integrated Windows authentication, frequently referred to as NTLM. Password hashes, Kerberos authentication, ticket-granting tickets, and credentials that applications store as domain credentials. By enabling Windows Defender Credential Guard, you get the following features and solutions. The first one is a hardware security enhancement. NTLM, Kerberos, and Credential Manager take advantage of platform security features, including secure boot and virtualization, to help protect credentials. The second feature is a virtualization-based security enhancement. NTLM-derived credentials, Kerberos-derived credentials, and other secrets run in a protected environment that is isolated from the running operating system. Next is better protection against advanced persistent threats. Because of virtualization-based security enhancement, the credential theft attack techniques and tools that many targeted attacks use are blocked. Malware running in the OS with administrative privileges can't extract secrets that virtualization-based security helps protect. Although Windows Defender Credential Guard provides powerful mitigation, persistent threat attacks will likely shift to new attack techniques, so you should also incorporate Windows Defender Device Guard and other security strategies and architectures. Now let's learn about Windows Defender Device Guard and Windows Defender Application Control. The configuration state of Windows Defender Device Guard was originally designed with a specific security idea in mind. Although no direct dependencies existed between the two main OS features of the Windows Defender Device Guard configuration, that is, between configurable code integrity and hypervisor protected code integrity, frequently referred to as HVCI, the discussion intentionally focused on the Windows Defender Device Guard lockdown state that can be achieved when they're deployed together. However, the use of the term Device Guard to describe this configuration state has unintentionally left many IT pros with the impression that the two features are inexorably linked and can't be separately deployed. Additionally, because HVCI relies on security based on Windows virtualization, it comes with additional hardware, firmware, and kernel driver compatibility requirements that some older systems can't meet. As a result, many IT pros assumed that because some systems couldn't use HVCI, they couldn't use configurable code integrity either. But configurable code integrity has no specific hardware or software requirements other than running Windows 10, which means that many IT pros were wrongly denied the benefits of this powerful application control capability. Since the initial release of Windows 10, the world has witnessed numerous hacking and malware attacks where application control alone might have prevented the attack altogether. Configurable code integrity is now documented as an independent technology within the Microsoft security stack and given a name of its own, Windows Defender Application Control. Application control is a crucial line of defense for helping protect enterprises given today's threat landscape, and it has an inherent advantage over traditional antivirus solutions. Specifically, application control moves away from the traditional application trust model, in which all applications are assumed trustworthy by default, to one where applications must earn trust to run. Many organizations understand this and frequently cite application control as one of the most effective means for addressing the threat of malware based on executable files such as .exe and .dll files. Windows Defender application control helps mitigate these types of threats by restricting the application that users can run and the code that runs in the system core or kernel. Policies in Windows Defender application control also block unsigned scripts and message-signaled interrupts, frequently referred to as MSIs, and Windows PowerShell runs in constrained language mode. Does this mean the Windows Defender device guard configuration state is going away? Not at all. The term device guard will continue to describe the fully locked down state achieved using Windows Defender application control, HVCI, and hardware and firmware security features. It will also allow Microsoft to work with its original equipment manufacturer partners, frequently referred to as OEM partners, to identify specifications for devices that are device guard capable. Doing this enables joint customers to easily purchase devices that meet all the hardware and firmware requirements of the original lockdown scenario of Windows Defender Device Guard for Windows 10 devices. Now let's look at the supported operating systems for Microsoft Defender for Endpoint. The supported Windows versions include Windows 11, Windows 10, Windows 8.1, Windows 7 SP1, Windows Server, Windows Virtual Desktop, and Windows 365. Other supported operating systems include Mac OS, Linux, Android, and iOS. It's time to recap. In this video, you've learned about Windows Defender Credential Guard and the features and solutions you get by enabling Windows Defender Credential Guard. You have also explored Windows Defender Device Guard and Windows Defender Application Control and their uses. Finally, you also learned about the supported operating systems for Microsoft Defender for Endpoint. Mark is a cloud security engineer for a multinational organization that heavily relies on Microsoft Azure for its cloud infrastructure. Recently, the organization has decided to leverage the security capabilities provided by Microsoft Defender for Cloud to enhance the overall security of its Azure resources. Mark is focusing on the security recommendations offered by Microsoft Defender for Cloud specifically. These recommendations provide valuable insights and actionable guidance to identify and mitigate potential security risks and vulnerabilities in your Azure environment. Hello, and welcome to the video, Explore Microsoft Defender for Cloud Recommendations. In this video, you'll learn how Microsoft Defender for Cloud evaluates the resources for potential security misconfigurations and provide security recommendations to secure the resources. You'll also learn about the Secure Score feature in Microsoft Defender. Microsoft Defender for Cloud periodically analyzes the compliance status of your resources to identify potential security misconfigurations and weaknesses. It then provides recommendations on how to address the issues. These recommendations are based on evaluating your resources against relevant policies and identifying any resources that do not meet your specified requirements. Defender for Cloud makes its security recommendations based on your chosen initiatives. When a policy from your initiative is compared against your resources and finds one or more that aren't compliant, it's presented as a recommendation in Defender for Cloud. Recommendations are actions for you to take to secure and harden your resources. Each recommendation provides you with the following information: a short description of the issue, the remediation steps to carry out to implement the recommendation, and the affected resources. Let's understand the use of initiatives and policies to generate recommendations with the help of an example. First, let's consider that Azure Security Benchmark is an initiative that contains requirements. For example, Azure storage accounts must restrict network access to reduce their attack surface. Second, the initiative includes multiple policies, each requiring a specific resource type. These policies enforce the requirements of the initiative. To continue the example, the storage requirement is enforced with the policy, storage accounts should restrict network access using virtual network rules. Next, Microsoft Defender for Cloud continually assesses your connected subscriptions. If it finds a resource that doesn't satisfy a policy, it displays a recommendation to fix that situation and strengthen the security of resources that aren't meeting your security requirements. You would have now identified that Microsoft Defender works with the goals of understanding your current security situation and efficiently and effectively improving your security. The central feature in Defender for Cloud that enables you to achieve those goals is the Secure Score. Defender for Cloud continuously evaluates your cross-cloud assets to identify any security concerns. It consolidates all the results into a single score, providing you with a quick overview of your current security status. In the Azure portal pages, the secure score is shown as a percentage value and the underlying values are also clearly presented. To increase your security, you need to review Defender for Cloud's recommendations page and remediate the recommendation by implementing the remediation instructions for each issue. Recommendations are grouped into security controls. Each control is a logical group of related security recommendations that correspond to your exposed attack vectors. To improve your secure score, you have to implement the security recommendations. You can view the list of recommendations in Azure Portal through Defender for Cloud Overview. Select Security Posture, and then select View Recommendations for the environment you want to improve. Else, go to Recommendations in the Defender for Cloud menu. Within the list of recommendations, you can apply filters that help you identify the recommendations that have the most impact on your score or the ones that have the most impact on your score. However, your score will only improve if you remediate all the recommendations associated with a particular resource within a control. You have now reached the end of the video. In this video, you learned how Microsoft Defender for Cloud makes security recommendations and how you can leverage these recommendations to secure and harden your resources. You also learned how the Secure Score feature in Microsoft Defender for Cloud provides a quick overview of your current security status. Steve is an IT security consultant working with a financial services organization. The organization has decided to migrate its infrastructure to Microsoft Azure as part of their cloud adoption strategy. They want to ensure a strong security posture in Azure to protect their sensitive financial data. To help the organization achieve its security goals effectively, Steve proposes to implement the Azure Security Benchmark, also called ASB. ASB provides prescriptive best practices and recommendations to help improve the security of workloads, data, and services on Azure. In October 2022, ASB was enhanced to the Microsoft Cloud Security Benchmark, also called MCSB. Hello, and welcome to the video, Secure Azure Workloads with Azure Security Benchmarks. In this video, you'll learn about ASB, which helps to secure Azure workloads and services through cloud-centric control areas. You will also learn about the enhancements introduced in MCSB to help secure your cloud services in a single or multi-cloud environment. ASB is part of a set of holistic security guidance that includes some of the well-known security benchmarks. Let's identify a few of them. Cloud Adoption Framework, which includes guidance on security, including strategy, roles, and responsibilities. Azure Top 10 Security Best Practices and Reference Implementation. Azure Well-Architected Framework, which provides guidance on securing your workloads on Azure. Microsoft Security Best Practices. Microsoft Cybersecurity Reference Architectures, which includes visual diagrams and guidance. Next, let us learn about the successor of ASB, which is the MCSB. ASB was enhanced to MCSB to fulfill the requirement of reconciling security controls across multiple cloud platforms to meet security and compliance requirements on each of them. This helps to reduce redundant overhead, cost, and effort to repeat the same implementation, monitoring, and assessment across the different cloud environments. So what are the salient features of MCSB that help to work with different clouds? Let's identify these features. MCSB provides a single control framework to easily meet the security controls across clouds. MCSB provides a consistent user experience for monitoring and enforcing the multi-cloud security benchmark in Defender for Cloud. MCSB stays aligned with industry standards, including the following: Center for Internet Security, also called CIS, National Institute of Standards and Technology, also called NIST, and Payment Card Industry, also called PCI. Another enhancement from ASB to MCSB is the review of the Azure Security Guidance and Security Principles, so you can remain updated with the latest Azure features and capabilities. MCSB includes a collection of high-impact security recommendations you can use to help secure your cloud services in a single or multi-cloud environment. MCSB recommendations include two key aspects. The first aspect is the security controls, which are generic recommendations applicable across your cloud workloads. Each recommendation identifies stakeholders who are usually engaged in the process of planning, approving, or implementing the benchmark. The second aspect is the service baselines. These apply the controls to individual cloud services to provide recommendations on that specific service's security configuration. You have now reached the end of the video. Let's summarize what is covered in the video. In this video, you learned about ASB and the set of holistic security guidance of which ASB is a part. You learned about MCSB, the successor of ASB. You primarily learned about the enhancements introduced in MCSB from the perspective of reconciling security controls across multiple cloud platforms.
Let's consider a scenario of a large enterprise that heavily relies on Microsoft Azure for its cloud infrastructure and application deployment. The company has a complex and rapidly evolving software ecosystem with multiple services and applications that need to be deployed and managed efficiently. For such a scenario, containers are relevant to improve deployment processes and increase agility. Hello, and welcome to the video, What is a Container? In this video, you will learn how containers work and what their key features are. Containers are a great choice for running applications in Azure. Like virtual machines, also called VMs, containers must be logged to protect your data and business. You can use the built-in Azure container tools to keep your container-based solutions secure. Let's understand what a container is. A container is an isolated, lightweight silo for running an application on the host operating system. Containers are built on top of the host operating system's kernel, which is a core part of the operating system. Containers contain only apps and some lightweight operating system APIs and services that run in user mode. Although a container shares the host operating system's kernel, it doesn't have unrestricted access to it. Instead, the container gets an isolated view of the system, sometimes through virtualization. For instance, a container can interact with the virtualized version of the file system and registry. However, any modifications only impact the container and are discarded when it stops running. To save data, the container can mount persistent storage, such as an Azure disk, or a file share, such as Azure Files. Moving further, let's understand the working of a container. To work with Windows containers, you need Docker. Docker consists of the Docker engine and the Docker client. A container builds on top of the kernel, but the kernel doesn't provide all the APIs and services an app needs to run. Most of these are provided by system files or libraries that operate in user mode above the kernel. A container is isolated from the host's user mode environment. So the container requires its own copy of the user mode system files called a base image. The base image serves as the foundational layer upon which your container is built, providing it with additional operating system services that the kernel alone does not provide. After having discussed the basic working of containers, what benefit do you think they can offer? You know that containers require fewer resources. For example, they don't need a full operating system. This results in effortless deployment and fast startup times. It enables higher density, enabling you to run more services on the same hardware unit, ultimately reducing costs. A limitation to consider about containers is that due to operating on the same kernel, there is a reduced level of isolation compared to virtual machines. To understand the working of containers, it is important to understand the features of containers. So let us learn about the features of containers. The first feature to focus on is isolation. A container typically provides lightweight isolation from the host and other containers. However, it does not provide as strong a security boundary as a VM. You can increase the security by using Hyper-V isolation mode to isolate each container in a lightweight VM. The second aspect to consider is the operating system. A container runs the user mode portion of an operating system. It can be customized to include only the necessary services for your app using fewer system resources. Regarding deployment, you can deploy individual containers by using Docker via the command line. You can deploy multiple containers by using an orchestrator such as Azure Kubernetes Service. For persistent storage, you can use Azure disks or local storage for a single node. For multiple nodes or servers, you can use Azure Files, SMB shares for storage. Next, let's consider fault tolerance. If a cluster node fails, any containers running on it are rapidly recreated by the orchestrator on another cluster node. Last but not least, let us consider the networking feature. A container uses an isolated view of a virtual network adapter, providing a little less virtualization. The host's firewall is shared with containers and less resources are used. In Docker, each layer represents the changes made to the file system after executing a command, such as installing a program. So when you view the file system after the layer has been copied, you can view all the files, including the layer when the program was installed. You can consider an image as an auxiliary read-only hard disk ready to be installed in a computer where the operating system is already installed. Likewise, a container can be seen as a computer with the image hard disk installed. The container, just like a computer, can be powered on or off. You have now reached the end of the video. In this video, you learned about the basics and workings of containers. You also learned about the salient features related to containers.
Imagine you're a DevOps engineer working for a software development firm that has recently adopted containerization for its application deployment. You notice that an unauthorized user has gained access to one of the containers and is attempting to extract some sensitive data. You quickly take action to mitigate this data breach and secure that container, thus preventing any further unauthorized access. However, this incident makes you realize the importance of container security for safeguarding your company's applications and data from any potential threats. Hello, and welcome to the video, Configure Azure Container Instances Security. In this video, you'll explore how to configure and manage container security to ensure the safety and integrity of your organization's applications. So let's understand how you can go about it. There are many security recommendations for Azure container instances. You can use these recommendations to optimize your security for containers. The first recommendation is to use a private registry. Containers are built from images that are stored in one or more repositories. These repositories can belong to a public registry, like Docker Hub, or to a private registry. An example of a private registry is the Docker Trusted Registry, which can be installed on premises or in a virtual private cloud. You can also use cloud-based private container registry services, including Azure Container Registry. A publicly available container image does not guarantee security. Container images consist of multiple software layers, and each software layer might have vulnerabilities. To help reduce the threat of attacks, you should store and retrieve images from a private registry, such as Azure Container Registry or Docker Trusted Registry. In addition to providing a managed private registry, Azure Container Registry supports service principle-based authentication through Azure Active Directory for basic authentication flows. This authentication includes role-based access for read-only, pull, write, push, and other permissions. The next recommendation is to monitor and scan container images continuously. To do this, take advantage of solutions to scan container images in a private registry and identify potential vulnerabilities. Remember that it's important to understand the depth of threat detection that the different solutions provide. For example, Azure Container Registry optionally integrates with Microsoft Defender for Cloud to automatically scan all Linux images pushed to a registry. Microsoft Defender for Cloud integrated Qualys scanner detects image vulnerabilities, classifies them, and provides remediation guidance. Let's proceed ahead and discuss the next recommendation, which is to protect credentials. Containers can spread across several clusters and Azure regions, so you must secure the credentials required for logins or API access, such as passwords or tokens. Ensure that only privileged users can access those containers in transit and at rest. Inventory all credential secrets and then require developers to use emerging secrets management tools that are designed for container platforms. Make sure that your solution includes encrypted databases, TLS encryption for secrets data in transit, and least privilege role-based access control. Azure Key Vault is a cloud service that safeguards encryption keys and secrets such as certificates, connection strings, and passwords for containerized applications. Because this data is sensitive and business critical, secure access to your Key Vault so that only authorized applications and users can access them. Next, you should use vulnerability management as part of your container development lifecycle. By using effective vulnerability management throughout the container development lifecycle, you improve the odds that you identify and resolve security concerns before they become a more serious problem. You should also remember to scan for vulnerabilities. New vulnerabilities are discovered all the time, so scanning for and identifying vulnerabilities is a continuous process. Incorporate vulnerability scanning throughout the container lifecycle. As a final check in your development pipeline, you should perform a vulnerability scan on containers before pushing the images to a public or private registry. Continue to scan container images in the registry both to identify any flaws that were somehow missed during development and to address any newly discovered vulnerabilities that might exist in the code used in the container images. Another recommendation is to ensure that only approved images are used in your environment. There's enough change and volatility in a container ecosystem without allowing unknown containers as well. Allow only approved container images. Have tools and processes in place to monitor for and prevent the use of unapproved container images. An effective way of reducing the attack surface and preventing developers from making critical security mistakes is to control the flow of container images into your development environment. For example, you might sanction a single Linux distribution as a base image, preferably one that is lean, Alpine, or Core OS rather than Ubuntu, to minimize the surface for potential attacks. Image signing or fingerprinting can provide a chain of custody that enables you to verify the integrity of the containers. For example, Azure Container Registry supports Docker's content trust model, which allows image publishers to sign images that are pushed to a registry and image consumers to pull only signed images. Next, remember to enforce the least privileges in runtime. The concept of least privileges is a basic security best practice that also applies to containers. When a vulnerability is exploited, it generally gives the attacker access and privileges equal to those of the compromised application or process. Ensuring that containers operate with the lowest privileges and access required to get the job done reduces your exposure to risk. Another best practice is to reduce the container attack surface by removing unneeded privileges. You can also minimize the potential attack surface by removing any unused or unnecessary processes or privileges from the container runtime. Privileged containers run as root. If a malicious user or workload escapes in a privileged container, the container will then run as root on that system. Finally, it's important to log all container administrative user access for auditing. To do this, you need to maintain an accurate audit trail of administrative access to your container ecosystem, including your Kubernetes cluster, container registry, and container images. These logs might be necessary for auditing purposes and will be useful as forensic evidence after any security incident. Azure solutions include integration of Azure Kubernetes Service with Microsoft Defender for Cloud to monitor the security configuration of the cluster environment and generate security recommendations, Azure Container Monitoring Solution, and resource logs for Azure Container Instances and Azure Container Registry. Now that you've reached the end of this video, let's recap. In this video, you've learned about the security recommendations for Azure Container Instances that can be used to optimize your security for containers. The recommendations include using a private registry, monitoring and scanning container images continuously, protecting credentials, and using vulnerability management as part of your container development lifecycle. You also need to scan for vulnerabilities, ensure that only approved images are used in your environment, enforce least privileges in runtime, reduce the container attack surface by removing unneeded privileges, and lastly, log all container administrative user access for auditing. Imagine your company, an AI-focused tech startup, is facing challenges with the existing infrastructure scalability and speed of application deployments. How can you overcome these issues? Simple. Azure Container Instances, ACI, will allow the company to deploy containerized versions of the AI applications without having to manage the underlying infrastructure, saving valuable time and resources. Teams can store container images in the Azure Container Registry. They can also automate the process of building, pushing, and deploying these images using Azure's integration with CI/CD tools. Hello, and welcome to the video, Manage Security for Azure Container Instances, ACI. What is Azure Container Instances, ACI? Azure Container Instances, often called ACI, is a platform as a service, also called PaaS, for scenarios that can operate in isolated containers, including simple applications, task automation, and building jobs. Some of the key features of ACI are as follows. Azure Container Instances, or ACI, facilitate the rapid startup of containers, negating the need for virtual machines, VMs. Users can launch containers in Azure within seconds. ACI provides direct internet exposure to your container groups with an IP address and a fully qualified domain name, frequently referred to as FQDN, and assures the same isolation level as in a VM. ACI offers customization of CPU cores and memory to cater to individual application needs, optimizing resource utilization. It offers GPU resources for compute-intensive tasks, like machine learning. ACI can schedule both Linux and Windows containers with the same API. ACI allows the scheduling of multi-container groups sharing a host machine, local network, storage, and lifecycle, facilitating the combination of your main application container with other supporting role containers. Let's check out Microsoft's security recommendations and considerations for using ACI to run container applications. Microsoft's security recommendations for managing images and secrets for ACI include: use a private registry to help reduce the threat of attacks, store and retrieve images from a private registry like Azure Container Registry. Monitor and scan container images. Use security monitoring and image scanning solutions to monitor and scan container images in a private registry to identify vulnerabilities. Protect credentials. You must secure the credentials required for logins or API access, such as passwords or tokens. Ensure that only privileged users can access containers. Now, let's look at Microsoft's considerations for the container ecosystem throughout the container lifecycle. Vulnerability considerations for any container platform include: use vulnerability management as part of your container development lifecycle. Effective vulnerability management throughout the container lifecycle helps identify and resolve security concerns before they become a problem. Scan for vulnerabilities. Scanning for and identifying vulnerabilities is a continuous process. Perform a vulnerability scan on containers before pushing the images to a registry. Continue to scan container images to identify overlooked flaws and address newly discovered vulnerabilities. Map image vulnerabilities to running containers. Map vulnerabilities identified in container images to running containers so security issues can be mitigated or resolved. Container platform image considerations include: ensure that only approved images are used in your environment. Allow only approved container images. Monitor for and prevent the use of unapproved container images. Permit only approved registries. An extension of ensuring that your environment uses only approved images is to permit only the use of approved image container registries to reduce risk exposure. Ensure the integrity of images throughout the lifecycle. Don't allow images with vulnerabilities to run in production. Save images in a private registry. Limit access to only a few users. Periodically audit deployed images. Container platform privilege considerations include: enforce least privileges in runtime. The principle of least privileges is an essential security best practice for containers. Give users access to only what they need to perform their job. Reduce the container attack surface by removing unneeded privileges. Minimize the potential attack surface by removing unused or unnecessary processes or privileges. Pre-approve files and executables that the container is allowed to access or run. Limit containers so they can access or run only pre-approved or safe-listed files and executables to reduce exposure risk. Enforce network segmentation on running containers. Protect containers in different subnets from security risks by maintaining network segmentation or nano-segmentation or segregation between running containers. Container platform activity considerations include: monitor container activity and user access. Consistently monitor activity and user access to your container ecosystem to quickly identify suspicious or malicious activity. Monitor container resource activity. Monitor resource activity like files, networks, and other resources your containers access for performance monitoring and as a security measure. Log all container administrative user access for auditing. Maintain an accurate audit trail of administrative access to the container ecosystem. Logs might be necessary for auditing purposes and as forensic evidence after any security incident. Let's recap. In this video, you learned about Azure Container Instances, its key features, and security recommendations and considerations for using ACI to run container applications. A small technology operation, TechStart Incorporated, is developing a web application with multiple microservices. Microservices are packaged as container images and must be stored securely and reliably for deployment. TechStart Inc. chooses the Azure Container Registry, also called ACR, to manage its container images. How will TechStart benefit from using ACR? Let's see. First, there's centralized storage. Centralizing container image storage simplifies microservice management and deployment. Second is security. Enhanced security, including authentication, role-based access control, and vulnerability scanning, strengthens security posture. Then there's integration with Azure services. ACR integrates with Azure services like Azure Kubernetes Services, AKS, and Azure App Service, enabling direct microservice deployments from the registry. Followed by continuous integration and continuous deployment, also known as CI/CD, ACR integration with CI/CD pipelines enables automatic build, test, and deployment of container images when code is pushed to the repository. And geo-replication. Geo-replication enables container image replication across Azure regions, ensuring high availability and reduced latency. Finally, it's cost-effective. With pay-as-you-go pricing, they pay only for consumed storage and data transfer, reducing costs. By leveraging ACR, TechStart Inc. can securely and efficiently manage its container images, streamline development and deployment processes, and ensure web application reliability and high availability. Hello, and welcome to the video, Explore the Azure Container Registry ACR. In this video, you'll learn about the benefits and purpose of container registries as well as access and security, and container artifacts and images. First, let's talk about container registries. A container registry is a service that stores and distributes container images. There are public and private registries. Docker Hub, a public registry available to anyone, is an open-source general image catalog. Azure Container Registry, a private registry available only to the organization, gives users direct image control. ACR's features include integrated authentication, geo-replication supporting global distribution, and reliability for network-closed deployments, virtual network and firewall configuration, and tag locking. ACR supports related content artifacts, including Docker container images and Open Container Initiative (OCI) image formats. Did you know that registries can be accessed using the standard Docker login command or Azure CLI? Yes. ACR supports TLS to secure client connections and transfer images over HTTPS. Be sure to use TLS 1.2 for secure servers and application connections. TLS 1.2 can be enabled using Docker client version 18.03.0 or later in case you don't have it. Access to a registry is controlled using an Azure identity, an Azure Active Directory-backed service principal, or a provided admin account. Role-based access control, RBAC, can assign systems fine-grained permissions and users to a registry. Content trust for image tag signing in firewalls and virtual networks to restrict access to the registry are among the premium SKU security features. Optionally, the Microsoft Defender for Cloud can be integrated with ACR for image scanning when pushing images to registries. Repositories are stored within the registry. They are collections of images or artifacts with the same name but different tags. For example, these images are located in the ACR Hello World repository, ACR Hello World Latest, ACR Hello World v1, ACR Hello World v2. Here, ACR Hello World refers to the name of the container image repository, usually representing the application or service, and Latest, v1 and v2 are the tags of the referenced container image. A container image is a bundle of files organized into a stack of layers that resides on your local machine or in a remote container registry. The container image consists of the user mode operating system files needed to support your app, any runtimes or dependencies, and any other miscellaneous configuration file your app needs to run properly. A container image or other artifact within a registry is associated with one or more tags, has one or more layers, and is identified by a manifest. Understanding how these components relate to each other can help you manage your registry effectively. You should consistently monitor activity and user access to your container ecosystem for suspicious or malicious activity. The container monitoring solution in Log Analytics can help. By using Log Analytics, you can view detailed audit information that shows commands used with containers, troubleshoot containers by viewing and searching centralized logs, find containers that may be consuming excess resources on a host, and view centralized CPU, memory, storage, network usage, and performance information. Containers allow you to run multiple instances of an application on a single operating system instance, thereby using resources more efficiently. They enable continuous deployment because the application can be developed on a desktop, tested in a virtual machine, and then deployed for production in the cloud. Containers provide consistency, flexibility, agility, streamlined operations, scalability, and reduced costs due to resource optimization. Let's review. In this video, you discovered how organizations can benefit by using ACR. You learned about registry hierarchy and purpose, how registries are accessed, and their security posture. You also learned how artifacts and images are named and tagged, and about monitoring container access and user activity. Just as there's more than one way to crack an egg, there's more than one way to access Azure Container Registry. Azure Container Registry, also called ACR, offers multiple authentication methods, each of which applies to one or more registry usage scenarios to ensure secure access to container images. Hello, and welcome to the video, Enable Azure Container Registry Authentication. In this video, you'll learn more about ACR's multiple methods of authentication, along with the need for them. As mentioned earlier, several authentication methods exist, and you may be wondering why. ACR is a managed private Docker registry service that stores and manages container images for Azure deployments. Multiple authentication methods provide flexibility, agility, and convenience to suit different use cases and requirements and accommodate the various needs and scenarios that users and applications may encounter when working with container images in Azure. Why would ACR offer multiple authentication methods, you might ask? First, there's security. Different authentication methods offer varying levels of security. Having multiple options allows users to choose the method that best fits their security needs. Second, we have granular access control. Some authentication methods offer more granular control over access to the container registry. Then there's integration with other Azure services. ACR authentication methods are designed to work seamlessly with other Azure services, such as Azure Active Directory, Azure AD, Azure Kubernetes Service, AKS, and virtual machines. And also ease of use and management. Different authentication methods cater to varying levels of user experience and management complexity. Finally, there's support for various scenarios. Having multiple authentication methods enables ACR to support a wide range of scenarios, such as CI/CD pipelines, application deployments, or third-party integrations. What are some of the authentication methods to access ACR? Let's take a look. Azure AD identities, including user and service principals. Individual AD identity, admin user. Let's talk about service principals. Service principals are non-user accounts in Azure AD that can be granted permission to access resources within your Azure subscription. If you assign a service principal to your registry, your application or service can use it for headless authentication. Service principals allow role-based access to a registry, and you can assign multiple service principals. Multiple service principals will enable you to define different access for different applications. Available container registry roles include the following: ACR pull, ACR push, pull and push, owner, pull, push, and assign roles to other users. You can create a service principal and assign it to a role in ACR, such as ACR pull, ACR push, or owner, to grant it the necessary permissions to push or pull images. Clients can then authenticate using the service principal's credentials, providing a more secure and manageable authentication method than the admin account. Individual login with Azure AD is another method. When working with your registry directly, such as pulling images to and pushing images from a development workstation, authenticate by using the AZ-ACR login command in the Azure CLI. When you log in with AZ-ACR login, the CLI uses the token created when you executed AZ login to authenticate your session with your registry seamlessly. This method provides more granular control over access to the container registry by allowing you to define specific actions, e.g. push, pull, delete, and repositories that the token can access. Access tokens offer a more flexible way to manage authentication for various scenarios, such as CI/CD pipelines or third-party integrations. To complete the authentication flow, Docker must be installed and running in your environment. AZ-ACR login uses the Docker client to set an Azure Active Directory token in the docker.config file. Once logged in this way, your credentials are cached, and subsequent Docker commands in your session do not require a username or password. Finally, there's the admin account. Each container registry has a default admin user account that is initially disabled. You can enable and manage this account through the Azure portal, Azure CLI, or other Azure tools. The admin account provides full access to the registry and has 2 passwords, both of which can be regenerated. This enables you to maintain a connection to the registry while regenerating one password by using the other. When enabled, you can authenticate to ACR using the admin account's username and either password through the Docker login command. While this method is easy to set up, it's not recommended for production environments due to the lack of granular control and security risks associated with sharing credentials. Let's quickly recap. In this video, you learned about the different authentication methods for Azure Container Registry authentication, including Azure AD identities, including user and service principals, individual AD identity, and admin user. Suppose you run a small restaurant and need a robust, scalable, cost-effective online ordering system. The solution? Azure Serverless Computing. Here's how you can leverage the different components. Azure Functions can be used to process online orders. When a customer submits an order, a function is triggered to process the order. This function checks the order details, updates the inventory, calculates the total, and confirms the order. In real time, the function automatically scales up or down based on volume. Azure Logic Apps coordinates complex workflows. When an order is processed, a workflow is triggered to notify the kitchen staff, update the restaurant's inventory, and send a confirmation email or SMS to the customer. Azure Cosmos DB, a globally distributed multi-model database, stores the restaurant's data, including the menu, customer details, order history, and inventory levels. Its global distribution allows customers to place orders from anywhere, interacting with a nearby copy of the data for fast performance. Azure Event Grid manages events that occur due to actions within the system. For example, when a customer places a new order, an event is generated, which triggers the function to process the order. Azure API Management securely exposes APIs used by the restaurant's website and mobile app, including APIs for placing orders, checking order status, and updating details. As you can see, Azure Serverless Computing enables the restaurant to implement an online ordering system quickly and cost-effectively. It scales to meet demand without the need for managing servers or other infrastructure. Serverless computing allows restaurant owners to focus on what they do best, the business of making great food and providing excellent service. Hello, and welcome to the video, Overview of Serverless Compute. In this video, you'll learn about Azure Serverless Computing and its components. Just what is serverless computing? Serverless computing is a cloud-hosted execution environment that runs your code but abstracts the management and existence of servers away from you. Did you notice I said cloud-hosted? So there is a server, or even a group of servers, in the cloud. However, the beauty here is that you're not responsible for setting up or maintaining the server. Your part is serverless and maintenance-free. By eliminating the need to manage the infrastructure, you can build applications quicker than ever. Best of all, you never have to worry about an outage. Your code can scale instantly to meet demand. The cloud vendor handles all maintenance and scaling concerns, leaving you to consume the compute, storage, and network resources necessary to deploy your application and focus on managing your business. How does it work? In serverless computing, you simply create an instance of the service, then add your code. There's no infrastructure configuration or maintenance necessary. You only configure your serverless apps to respond to events. An event could be a REST endpoint, a periodic timer, or even a message received from another Azure service. The serverless app runs only when it's triggered by an event. Performance and scaling are automatic, and you pay for only the resources you use. Let's talk a little more about scaling. What happens if you have a spike in business, say more orders than expected come in? Because Azure Serverless operates and manages the server and executes your organization's code logic on an as-needed basis, Microsoft's serverless components handle everything, meaning you worry about nothing. They automatically and dynamically scale up resources to match the demands of the workload, utilizing and charging for only the resources you use. It'll scale to zero if no function runs, making it cost-efficient when you're not using any resources. Now, here's what you know about serverless computing so far. The cloud service provider, often called CSP, automatically provides, scales, and manages the infrastructure required to run the code. And even though servers do run the code, there are no infrastructure provisioning and management tasks visible to you. Keeping the restaurant in mind, let's dive into an overview of the process and check out the platform components. With Azure Functions, you can create a new function app in the Azure portal. Inside this app, you might write functions in your preferred programming language, such as C#, JavaScript, Python, or others supported by Azure. Each function would correspond to a specific task, like processing an order or updating inventory. Azure Functions are event-driven and run in response to various triggers. In this case, HTTP triggers would likely be used, responding to web-based events like a new online order from the restaurant website. Using Azure Logic Apps, you could leverage this low-code or no-code platform to build and automate workflows instead of writing code. You might build a workflow that runs when an order is processed and automate it to send an email to the customer, notify the kitchen, and update the inventory system. Then you'd want to establish a new Azure Cosmos DB account in the portal. Within your Azure Functions code, you would use the Azure Cosmos DB software development kit, called SDK, to interact with the database. This might involve creating a new document when an order is placed, querying for documents when checking inventory, and so forth. Next, you would utilize the Azure Event Grid to define event sources, such as a new order in Cosmos DB, and event handlers, like an Azure Function or a Logic App workflow. When an event occurs, the Event Grid ensures that it's sent to all interested subscribers. Finally, you would set up Azure API Management by creating a new instance in the Azure portal, after which you would define your API's operations, like placing an order or checking order status, and map each operation to a specific Azure function. API management provides a facade for your serverless backend and can handle tasks like request routing, rate limiting, and access control. So what challenges does serverless computing address? Serverless computing mitigates cost and time-consuming challenges, including procuring machines and software licenses, managing the physical infrastructure such as housing, securing, configuring, and maintaining the machines, as well as meeting their networking, power, and air conditioning requirements, updating and upgrading operating systems and software, configuring web servers or machine services to host application software, setting up and configuring application software within its platform. Organizations allocate significant budgets to handle hardware infrastructure issues. By transitioning to serverless computing, expenses can be eliminated, thereby reducing costs. In this video, you learned about Azure Serverless Computing, including the meaning of serverless, Azure Serverless Components, implementing Azure Serverless, challenges addressed by Azure Serverless.
Imagine the global e-commerce company you work for needs a new website and mobile app to improve its online presence and boost sales. However, the teams work with multiple programming languages and frameworks, and they are spread across different regions worldwide. What's your recommendation? If you said Azure App Service, you are right on target. With Azure App Service, your company can streamline web and mobile app deployment and management, improve scalability, enhance security, and reduce costs. This service helps them stay agile, responsive to customer needs, and competitive in the global e-commerce market. Hello, and welcome to the video overview of Azure App Service. In this video, you will learn about Azure App Service and its key features and benefits. Let's get started. First, what is Azure App Service? It's a fully managed platform as a service, also called PaaS, model for developers. Azure handles all the infrastructure maintenance, such as operating system updates, patching, server hardware, and network resources. Developers can use their favorite languages and frameworks, including .NET, .NET Core, Java, Ruby, Node.js, PHP, and Python. The service is HTTP-based for hosting web applications, REST APIs, and mobile backends. Let's look at some of the key features. Azure App Service has built-in support for developing, hosting, and managing APIs and mobile features, which includes turnkey CORS, support for RESTful API scenarios, making for easy development of mobile app backends, including features like push notifications, user authentication, offline data sync, and more. Azure App Service includes up or out autoscaling to meet your application's demand based on predefined rules and schedules or in response to actual traffic patterns. Scaling helps handle traffic spikes and can help to optimize costs. Azure App Service offers hybrid connections to SaaS platforms and on-premises data for secure integration with popular SaaS platforms and access resources in other networks such as on-premises data centers via Azure Virtual Network or VPN. Azure App Service supports containerization and Docker containers to deploy and run containerized applications, making it easier to move apps between environments and ensuring consistency across development, testing, and production. Azure App Service allows you to add custom domains to your apps and secure them with free SSL or TLS certificates. With DevOps integration, Azure App Service integrates with various DevOps tools like Azure DevOps, GitHub, Bitbucket, and Docker Hub for continuous integration and deployment, allowing developers to automate their deployment pipeline and speed up their development processes. Do you need environment isolation? The App Service environment allows you to run your apps in a fully isolated, dedicated, and integrated environment. We'll talk more about it later. With Azure App Services global deployment, applications can be deployed to data centers around the world, providing the best performance for your users regardless of location. Azure App Service provides built-in integration with other Azure services like Azure SQL Database, Azure Cosmos DB, and Azure Logic Apps, making it easier to build and manage complex, robust applications. Azure App Service supports multiple programming languages, including C#, Java, PHP, PowerShell, Python, and Ruby, frameworks such as ASP.NET, .NET, .NET Core, and Ruby on Rails, and scripts and executables such as Express.js and Node.js, allowing developers to work with the technologies they are most comfortable with. Concerned about security and compliance? Don't be. Azure App Service is secure by default and includes features like authentication and authorization, SSL TLS encryption, and compliance with global standards including ISO, SOC, and PCI DSS. Then there is the advantage of serverless code execution, allowing you to run Azure functions in Azure App Service. Offering the pay-as-you-go compute option, it is great for running background tasks and workloads that don't need a full-time server. Azure App Service provides a wide range of helpful application templates to kickstart your app development, such as web apps, mobile backends, RESTful APIs, or real-time web functionalities. If you need help with your development environment and code editor integration, Azure App Service integrates with Visual Studio and Visual Studio Code, allowing you to develop your apps and directly publish and debug them in Azure App Service. How does Azure App Service work? Well, an app service always runs in an app service plan. An app service plan represents the set of resources and features that Azure provides for hosting your web apps, REST APIs, mobile backends, and automated tasks created in Azure App Service. Choosing a plan that provides the resources and features your apps need to run effectively depends on application needs, including expected load, required features, and budget. Consider these points when selecting your app service plan. You get to select the geographic location from which to run your apps. Various budget-friendly pricing tiers are available. The number of instances you can add depends on the pricing tier, and you can scale manually or automatically. An app service plan can host multiple apps which share resources defined by the app service plan. Windows or Linux operating system, app service plans run on both. Finally, let's talk about the app service environment, often called ACE. This premium feature of Azure App Service provides a fully isolated and dedicated environment for securely running your applications at high scale. ACEs are suited for applications requiring higher scale levels, security, network isolation, or network functions unavailable in the multi-tenant offering. Key points to understand about ACE include, unlike the multi-tenant model of the regular Azure App Service, each ACE is a dedicated environment dedicated to a single customer, which allows for increased performance and security. The network isolation of an ACE allows you to control inbound and outbound network traffic. As high-scale environments, ACEs can run many app instances, handling high loads, which is useful for large-scale enterprise-grade applications. With virtual network integration, you have secure access to resources on your private network from your ACE apps. Like the Azure App Service, you can map custom domain names to your apps in an ACE and secure them with SSL TLS certificates. ACEs have separate pricing models from the standard app service plan. With scaling, the cost is based on the number of isolated worker tiers rather than individual app service instances. In this video, you learn how the Azure App Service works and its key features and benefits. You discover that the app service helps streamline web and mobile app deployment and management, improve scalability, enhance security, and reduce costs. Imagine you are a DevOps engineer and manage microservices architecture-based applications. As you know, microservices applications are divided into small independent parts and can be deployed in containers for auto-scaling. In the case of simple applications, we can easily manage containers. However, in complex applications like drone tracking apps, managing these containers involves a lot of management overhead. To mitigate such overhead, we need a container orchestration tool like Kubernetes. Hello, and welcome to the video, What is Kubernetes? In this video, you will learn key concepts related to containerized workload, the definition of Kubernetes, and its benefits. You will also explore the considerations when you work with Kubernetes. In this video, we will refer to a drone tracking application, for example. Before looking at Kubernetes, let's understand a few concepts of containerized workloads. First, we will look at container management. It is the process of organizing, adding, removing, or updating a significant number of containers. The drone tracking app consists of multiple microservices for tasks like caching, queuing, or data processing. Each of these services is hosted in a container and can be deployed, updated, and scaled independently. Wondering how this works? Take a look at this image of a server or application that is replicated as containers for cloud deployment. For example, with the drone tracking app's website, you find that at specific times during the day, you need more instances of the site's caching service to keep up the performance, so you add more caching service container instances. Now assume that you have increased the number of caching instances and need to roll out a new version of the microservice. You'll have to make sure that to update all the active containers. Container orchestration helps you with these otherwise manual tasks. Let's understand what container orchestration is. It's a system that automatically deploys and manages containerized apps. For example, the orchestrator can dynamically respond to changes in the environment to increase or decrease the deployed instances of the managed app. Or it can ensure all deployed container instances get updated if a new version of a service is released. Now that you know about the key concepts, let's define Kubernetes. Kubernetes is a portable, extensible, open source platform for managing and orchestrating containerized workloads. Kubernetes simplifies complex container management tasks and provides you with declarative configuration to orchestrate containers in different computing environments. In the diagram, you can see replicated servers as multiple containers in a Kubernetes cluster. In simple words, Kubernetes forms a cluster of servers. Do you know Kubernetes is sometimes abbreviated to K8s, but it is pronounced as Kubernetes only. The 8 represents Uber-Net-E, the 8 characters between the K and the S of the word Kubernetes. There are benefits to using Kubernetes that include self-healing of containers. Kubernetes can self-heal failed containers by restarting or replacing them. The next benefit is dynamic scaling. You can dynamically scale the deployed container up or down based on the demand. Kubernetes also automates the rolling of updates and rollbacks of containers. Kubernetes also allows you to manage storage and network traffic. It can also be used for storing and managing sensitive information such as usernames and passwords. While working with Kubernetes, you must keep in mind that all of the preceding aspects of Kubernetes require configuration and a good understanding of the underlying technologies. For example, you must understand concepts such as virtual networks, load balancers, and reverse proxies to configure Kubernetes networking. With Kubernetes, you can view your data center as one large computing resource. You don't worry about how and where you deploy your containers, but only about deploying and scaling your apps as needed. There are some other considerations or challenges that you should keep in mind when working with Kubernetes. Let's look at them one by one. Aspects such as deployment, scaling, load balancing, logging, and monitoring are all optional. You are responsible for finding the best solution that fits your needs to address these aspects. Second, Kubernetes doesn't limit the types of apps that can run on the platform. If your app can run in a container, it can run on Kubernetes. To make optimal use of containerized solutions, your developers need to understand concepts such as microservices architecture. The third thing to consider is that Kubernetes doesn't provide middleware, data processing frameworks, databases, caches, or cluster storage systems. All these items are run as containers or as part of another service offering. Then, for Kubernetes to run containers, it needs a container runtime like Docker or Containerd. The container runtime is the object that's responsible for managing containers. For example, the container runtime starts, stops, and reports on the container status. With all the benefits you receive with Kubernetes, keep in mind that you're responsible for maintaining your Kubernetes environment. For example, you need to manage the operating system, commonly known as OS, upgrades, and the Kubernetes installation and upgrades. You also manage the hardware configuration of the host machines, such as networking, memory, and storage. There are so many challenges while working with Kubernetes. So how are you going to overcome them? You do not have to worry too much as cloud services such as Azure Kubernetes Service, commonly known as AKS, reduce these challenges by providing a hosted Kubernetes environment. These services also simplify the deployment and management of containerized apps in Azure. With AKS, you get the benefits of open source Kubernetes without the complexity or operational overhead of running your own custom Kubernetes cluster. Let's summarize. You have learned about key concepts related to containerized workloads, definition of Kubernetes, benefits of Kubernetes, and considerations or challenges when working with Kubernetes.
Assume you've been hired by an online retailer that has grown quickly in recent years. The business has been deploying an increasing number of apps in the cloud to support this expansion and is currently searching for a means to simplify the deployment and maintenance of its containerized applications. The business is interested in determining whether Azure Kubernetes Service, frequently referred to as AKS, is a good fit for its requirements after learning about it. Hello, and welcome to the video, Review Azure Kubernetes Service. In this video, you'll learn about the uses of the Kubernetes platform and what Kubernetes does during application development. You will also learn about components of Kubernetes cluster architecture and features of Azure Kubernetes Service. Let's first understand what you should do after your application development moves toward a container-based approach. At this point, the need to orchestrate and manage resources is important. Kubernetes is the leading platform that gives the ability to provide reliable scheduling of fault-tolerant application workloads. AKS is a managed Kubernetes offering that further simplifies container-based application deployment and management. With AKS, you get the benefits of open-source Kubernetes without the complexity or operational overhead compared to running our own custom Kubernetes cluster. Let's look at how Kubernetes helps to manage deployed applications. Kubernetes is a rapidly evolving platform that manages container-based applications and their associated networking and storage components. The focus is on the application workloads, not the underlying infrastructure components. Kubernetes provides a declarative approach to deployments, backed by a robust set of APIs for management operations. You can build and run modern, portable, microservices-based applications that benefit from Kubernetes orchestrating and managing the availability of those application components. Kubernetes supports both stateless and stateful applications as teams progress through the adoption of microservices-based applications. As an open platform, Kubernetes allows you to build your applications with your preferred programming language, operating system commonly referred to as OS, libraries, or messaging bus. Existing continuous integration and continuous delivery, commonly known as CI and CD tools, can integrate with Kubernetes to schedule and deploy releases. Azure Kubernetes Service provides a managed Kubernetes service that reduces the complexity of deployment and core management tasks, including coordinating upgrades. AKS is built on top of the open-source Azure Kubernetes Service engine, commonly known as the AKS engine. Now we'll look at the components of Kubernetes cluster architecture. A Kubernetes cluster is divided into two components, the control plane and nodes. The control plane provides the core Kubernetes service and orchestration of application workloads. Nodes run your application workloads. The image shows the Kubernetes cluster architecture and its components. The control plane is Azure managed and has Kube API Server, etcd, Kube Scheduler, and Kube Controller Manager as components. The Kubernetes node is customer managed. It has kubelet, kube proxy, and container runtime as its components. The control plane and node are connected by a bidirectional arrow. One interesting thing to note is that in the case of AKS nodes, you only pay for the nodes that run your applications. Next, we're going to take a look at the features of Azure Kubernetes Service. AKS is a fully managed service. The AKS control plane is managed by the Azure platform along with other Kubernetes components. You can use it with public IP and FQDN. The FQDNs also provide a private IP option. In simpler words, it means you can use AKS for public-facing websites and intranet applications. AKS can be accessed with RBAC or Azure AD. That is, it can be integrated with Azure AD or with the default Kubernetes RBAC role. AKS allows you to deploy container-based applications. With dynamic scale containers, it supports the auto-scaling of container infrastructure. With AKS, you can automate rolling updates and rollbacks of containers. It helps to promote an application from one environment to another. In case of any failure, you can roll back to the previous version. AKS also manages storage, network traffic, and sensitive information. To support application workloads, you can mount static or dynamic storage volumes for persistent data, network isolation, and secrets can be stored in encrypted form. There's no management overhead. Let's recap. In this video, you have learned about uses of the Kubernetes platform, what Kubernetes does during application development, components of Kubernetes cluster architecture, and features of Azure Kubernetes Service.
Consider that you're employed by a sizable e-commerce business that has switched its application stack to Azure Kubernetes Service, also known as AKS, in order to improve scalability and availability. The business runs several microservices on AKS, including checkout, payment, and product catalog services, among others. These microservices must be able to communicate with one another over a network and be reachable by outside clients like web browsers and mobile apps. Hello, and welcome to the video Configure Azure Kubernetes Service Networking. In this video, you will learn about virtual networking support in Kubernetes and how the Azure platform helps simplify virtual networking for AKS clusters. You will also learn about the network configuration services in Kubernetes and some details related to them. Let's first review how virtual networking is supported in Kubernetes. To allow access to your application or for application components to communicate with each other, Kubernetes provides an abstraction layer to virtual networking. Kubernetes nodes are connected to a virtual network and can provide inbound and outbound connectivity for pods. Kubernetes uses pods to run an instance of your application, where a pod represents a single instance of your application. The kubeproxy component runs on each node to provide these network features. In Kubernetes, services logically group pods to allow for direct access via an IP address or domain name system, also known as DNS, and on a specific port. You can also distribute traffic using a load balancer. More complex routing of application traffic can also be achieved with ingress controllers. Security and filtering of the network traffic for pods are possible with the Kubernetes network policies. The Azure platform helps you to simplify virtual networking for Azure Kubernetes Service clusters. When you create a Kubernetes load balancer, the underlying Azure load balancer resource is created and configured. As you open network ports to pods, the corresponding Azure Network Security Group rules are configured. For HTTP application routing, Azure can also configure external DNS as new ingress routes are configured. Now a question arises. How does Kubernetes simplify the network configuration for application workloads? Kubernetes uses services to logically group a set of pods together and provide network connectivity. There are 4 service types available for creating network configurations: cluster IP, node port, load balancer, and external name. Now let's describe each of these services and a related scenario. Cluster IP creates an internal IP address for use within an Azure Kubernetes service cluster. This service is good for internal-only applications that support other workloads within the cluster. Node port service creates a port mapping on the underlying node. This allows the application to be accessed directly with the node IP address and port. Load balancer creates an Azure load balancer resource, configures an external IP address, and connects the requested pods to the load balancer backend pool. This service is used to allow customers' traffic to reach the application. Load balancing rules are created on the desired ports. External name creates a specific DNS entry for easier application access. Let's look at a diagram to see how these services are used. To access the pod, internal traffic uses cluster IP, incoming direct traffic uses node port, and incoming non-direct traffic uses the load balancer. Now we'll take a look at some details about these network configuration services. You can create internal and external load balancers. The IP address for load balancers and services can be dynamically assigned, or you can specify an existing static IP address. Internal load balancers are only assigned a private IP address, so they can't be accessed from the internet. You can assign both internal and external static IP addresses. The existing static IP address is often tied to a DNS entry. Let's recap. You have learned about virtual networking support in Kubernetes, how Azure platform helps simplify virtual networking for AKS clusters, network configuration services in Kubernetes, and some details related to them.
Suppose you work for a healthcare organization where Azure Kubernetes Service, frequently referred to as AKS, is being used to host a number of vital apps. These apps, which handle patients' private data, require high availability and reliability. The business must make sure that data storage and application configuration are handled safely and effectively to satisfy these criteria. For this, the healthcare organization wants to deploy AKS storage. Hello, and welcome to the video, Deploy Azure Kubernetes Service Storage. In this video, you'll learn about storage options for applications in AKS. In particular, you'll be introduced to the core concepts that provide storage to your applications in AKS. This includes volumes, persistent volumes, storage classes, and persistent volume claims. Let's first understand the need for data storage and management in AKS. Your applications running in AKS may need to store and retrieve data. For some application workloads, this data storage can use local, fast storage on the node that is no longer needed when the pods are deleted. Other application workloads may require storage that persists on more regular data volumes within the Azure platform. Multiple pods may need to share the same data volumes or reattach data volumes if the pod is rescheduled on a different node. Finally, you may need to inject sensitive data or application configuration information into pods. For all of these requirements, you can use Azure Storage Services with AKS. Let's look at a diagram of an AKS cluster and the storage options. AKS cluster includes a persistent volume. The volume uses Azure Managed Disks as premium storage and Azure Files as standard. So what exactly are volumes? As Kubernetes typically treats individual pods as ephemeral, disposable resources, different approaches are available for applications to use and persist data as necessary. A volume represents a way to store, retrieve, and persist data across pods and through the application lifecycle. Traditional volumes to store and retrieve data are created as Kubernetes resources backed by Azure Storage. You can manually create these data volumes to be assigned to pods directly or have Kubernetes automatically create them. Now these data volumes can use Azure Disks or Azure Files. Let's understand them one by one. Azure Disks can be used to create a Kubernetes data disk resource. Disks can use Azure Premium Storage backed by high-performance solid-state drives, also known as SSDs, or Azure Standard Storage, backed by regular hard disk drives, also known as HDDs. For most of your production and development workloads, you should use premium storage. Azure disks are mounted as read-write once, so they're only available to a single pod. But what happens if there are multiple pods? For storage volumes that can be accessed by multiple pods simultaneously, you must opt for Azure Files. You can use Azure Files to mount a server message block or SMB 3.0 share backed by an Azure storage account to pods. Azure Files lets you share data across multiple nodes and pods. It can use Azure Standard Storage backed by regular HDDs or Azure Premium Storage backed by high-performance SSDs. Now the volumes you've defined and created as part of the pod lifecycle only exist until the pod is deleted. Pods often expect their storage to remain if a pod is rescheduled on a different host during a maintenance event, especially in stateful sets. Stateful sets maintain the state of applications beyond an individual pod lifecycle. A persistent volume, frequently referred to as PV, is a storage resource created and managed by the Kubernetes API that can exist beyond the lifetime of an individual pod. So, how are PVs provided to pods? As you already know, the choice of disks or files is often determined by the need for concurrent access to the data or the performance tier. If you are a cluster administrator, you can statistically create a PV. It can also be created dynamically by the Kubernetes API server. If a pod is scheduled and requests storage that is not currently available, Kubernetes can create the underlying Azure disk or file storage and attach it to the pod. Dynamic provisioning uses a storage class to identify what type of Azure storage needs to be created. Let's understand what storage classes are. To define different tiers of storage, such as premium and standard, you can create a storage class. The storage class also defines the reclaim policy. This reclaim policy controls the behavior of the underlying Azure storage resource when the pod is deleted and the persistent volume may no longer be required. The underlying storage resource can be deleted or retained for use with a future pod. In AKS, two initial storage classes are created, default and managed premium. The default storage class uses Azure Standard Storage to create a managed disk. The managed premium storage class uses Azure Premium Storage to create managed disk. For both storage classes, the reclaim policy indicates that the underlying Azure disk is deleted when the persistent volume that used it is deleted. If no storage class is specified for a persistent volume, the default storage class is used. Do you know that pods also make requests? Yes, there are instances when pods request a specific type of storage, such as a disk or file. These requests are called persistent volume claims. The pod specifies what kind of storage it needs, how it should be accessed, and how much space it requires. The Kubernetes API server can dynamically provision the underlying storage resource in Azure if there is no existing resource to fulfill the claim based on the defined storage class. The pod definition includes the volume amount once the volume has been connected to the pod. Let's look at a diagram where an AKS cluster with a persistent volume claim is accessing the storage class. A persistent volume is bound to a persistent volume claim once an available storage resource has been assigned to the pod requesting it. There's a one-to-one mapping of persistent volumes to claims. Let's recap. You've learned about the core concepts that provide storage to your applications in AKS, such as volumes, persistent volumes, storage classes, and persistent volume claims. Imagine your organization, TechCo, separately uses Azure Kubernetes Service, also called AKS, to manage its containerized applications and Azure Active Directory, often called Azure AD, for identity and access management. TechCo wants to ensure that only authorized developers can access and make changes to their Kubernetes clusters, and they want to leverage existing Azure AD identities to achieve this. They also want to define different access levels for different teams, perhaps the DevOps QA teams, to manage their AKS clusters effectively. How can they accomplish these goals? By integrating Azure AD with AKS, they can map Azure AD identities to Kubernetes roles and permissions, thus defining granular access control policies based on Azure AD groups and user identities. Hello, and welcome to the video, Secure Authentication to Azure Kubernetes Service with Active Directory. In this video, you'll learn the ins and outs of authenticating to AKS with Azure AD. So what does Microsoft say about secure authentication to AKS with Azure AD? Well, there are different ways to authenticate with and secure Kubernetes clusters. With role-based access controls called RBAC, administrators can grant users or groups access to only the necessary resources. With AKS, they can also enhance the security and permission structure using Azure AD. Let's look at TechCo's options and review the benefits. They could create an Azure AD group for their DevOps team and assign it a Kubernetes role with permissions to deploy and manage applications in the AKS cluster. Similarly, they could create another Azure AD group for their QA team and assign it a Kubernetes role with read-only permissions to the AKS cluster. By integrating Azure AD with AKS, TechCo can leverage Azure AD's robust security features, including RBAC, multi-factor authentication, conditional access policies, and identity protection, significantly enhancing its AKS cluster security posture. Through Kubernetes RBAC, TechCo can define granular access control policies, ensuring that users have only the necessary permissions to perform their tasks, following the principle of least privilege. With RBAC, the permissions of the Kubernetes service account are controlled policies within Kubernetes itself. There's more about service accounts in a bit. TechCo can manage all their user identities and access control policies in one place, Azure AD, simplifying the identity and access management of their AKS clusters and reducing the potential for configuration errors. All authentication requests are logged in Azure AD, providing a clear audit trail of who accessed what and when, a crucial component for meeting compliance requirements. Now let's talk about Kubernetes service accounts. These service accounts are used for processes running within the Kubernetes cluster. They are designed to provide an identity for processes running in pods, allowing these processes to interact with the Kubernetes API. Service accounts are non-human and associated with a token for API authentication requests. When users attempt to access the AKS cluster, they are prompted to sign in with their Azure AD credentials. Once authenticated, Azure AD returns a token to the user, which is used to authenticate requests to the AKS Kubernetes API. When Azure AD is integrated with AKS clusters, Kubernetes resources can be assigned to specific users or groups. This access can be within a particular namespace or across the entire cluster. To get a kube control configuration context, the user needs to execute the AZ-AKS get credentials command. As they interact with the AKS cluster using kube control, they will be asked to log in using their Azure AD credentials. This method centralizes user account management and password credentials in a single location. User access to resources is strictly controlled by the permissions set by the cluster administrator. By using secure authentication to AKS with Azure AD, you can leverage security features to boost and protect your AKS cluster security, enhance cluster manageability, and improve compliance while also increasing productivity by leveraging its existing Azure AD identities. This authentication augments the security of your AKS clusters and simplifies the management of user identities and access control policies. Let's summarize. In this video, you learned about using Azure AD for secure authentication with AKS to leverage security features to protect your AKS clusters. You also learned how this authentication enhances the security of your AKS clusters and simplifies the management of user identities and access control policies.
Imagine you're on the IT team at GlobeCo, a growing international organization specializing in cutting-edge software solutions. With their expanded offerings, GlobeCo has leveraged Azure Kubernetes Service, AKS, to handle increasingly complex applications. With GlobeCo's growing team of developers and stakeholders, proper access control has become crucial. Individuals need access to various resources, so ensuring everyone can access what they need without compromising security is paramount. To address this challenge, GlobeCo selected Kubernetes Role-Based Access Controls, or RBAC, within Azure. Their goal is to create a system where permissions are defined and granted based on roles, enabling a structured and secure approach to resource access within their AKS environment. They want to segregate access across namespaces, apply cluster-wide permissions, and manage sensitive data effectively using Kubernetes secrets. Let's explore how Globeco can make this a reality with Azure RBAC. Welcome to the video, Manage Access to Azure Kubernetes Service using Azure Role-Based Access Controls. In this video, you will learn about assigning and defining roles, binding roles, and effectively handling sensitive data using Kubernetes secrets. In the Azure ecosystem, there are two key RBAC mechanisms: Kubernetes RBAC for managing AKS clusters and Azure RBAC for managing resources within Azure subscriptions. Azure RBAC is unique in its ability to define roles that outline specific permissions, which can be applied to individual resources and entire resource groups, and even spans the subscription. It's that flexible. Let's start with the basics: roles and cluster roles. Think of these as your permission paths. In Kubernetes, you first define permissions as roles before assigning permissions. A role gives you access to specific namespaces within your Kubernetes environment. However, if you need an all-access pass to every namespace, cluster roles comes in handy. Cluster roles are similar to roles, but apply to the entire cluster rather than a specific namespace. Once you have defined the permissions with a role or a cluster role, you will bind the permissions. This is where role bindings and cluster role binding comes into play. Think of them as bridges, connecting your users with their permissions within the cluster. Role bindings assign roles within a specific namespace, allowing you to logically segment a single AKS cluster so users have access only to their assigned namespace. For cluster-wide role assignments, you would opt for cluster role bindings, particularly useful for granting administrators or support engineers access to all resources within the AKS cluster. Now let's talk about Kubernetes secrets. Secrets inject sensitive data like keys and access credentials into pod definitions or deployment. Instead of placing this sensitive data directly in a defined pod or container image, you create a secret using Kubernetes API, then request it when ready for pod definition or deployment. Secrets are only provided to nodes for a specifically scheduled pod. So once the last pod requiring the secret is deleted, the secret is removed from the node's temporary file system or TMPFS. Remember, secrets are namespace specific and can only be accessed by pods within the same namespace. By using secrets, you significantly reduce the amount of sensitive information defined in the pod or service YAML manifest or schema definition when you request the secret stored in the Kubernetes API server. It's important to note that raw or unprocessed secret manifest files contain secret data in base64 format, used to encode binary data as printable text, and should be treated as sensitive information and never committed to source control. For those using Windows containers, remember the secrets are written in clear text on the node's volume, unlike Linux, where they are stored in TMPFS or in memory. So make sure to secure the secret file location using file access control lists or ACLs and use volume level encryption with BitLocker. Let's recap. In this video, you gained insights into Azure's RBAC, learning to utilize these powerful tools to manage resources within your AKS environment. You discovered the nuances of defining and assigning roles and cluster roles, and binding these roles using role bindings and cluster role bindings. You learned how to manage access across namespaces strategically, grant cluster-wide permissions, and handle sensitive data effectively through Kubernetes secrets, even learning about secrets for Windows containers.
Well done! You've made your way through Week 3, Host and Container Security. During this time, you were introduced to the concepts of configuring and managing host security, container security, and Azure Kubernetes Service, also called AKS. We covered quite a lot in this short time, so let's recap what you've learned. In Week 3, you began learning about host security as part of your defense strategy. You explored securing Azure Virtual Machines, or VMs, private network security, security management, threat defense, and layered infrastructure protection. You saw how Azure uses a combination of logical isolation, access control, firewalls, authentication, and encryption mechanisms to guarantee customers' data in shared environments. Then, you learned about enabling endpoint protection. You learned to use Microsoft Defender for enterprise network endpoint security to prevent, detect, and respond to threats. You discovered that Microsoft Defender for Endpoint uses a specific combination of technologies built into Windows 10 and Microsoft's robust cloud service. Next, you learned about privileged access, including defining a privileged access strategy with root of trust and deploying privileged access workstations called PAWS. You discovered you could use root of trust to ensure the most secure conditions. You also found that PAWS are hardened, locked-down workstations providing high security assurances. Then you explored creating virtual machine templates using the Azure Resource Manager. A virtual machine template is a master copy of a VM used to deploy multiple VMs. Ensuring consistency and standardization, you discovered that Azure Resource Manager is your Azure Subscriptions deployment and management service. It provides a consistent management layer that allows you to create, update, and delete resources in your Azure subscription. That's not all. You can use its access control, auditing, and tagging features to help secure and organize your resources after deployment. You also learned about enabling and securing remote access management with Azure Bastion. You found that Azure Bastion is a service you deploy that enables you to connect to a VM using your browser and the Azure portal or via the native SSH, that is Secure Shell or RDP client already installed on your local computer. You learned how to connect to and sign into a Windows and Linux-based VM and to use Azure Bastion for remote access management. After that, you explored update management and scheduled updates. You learned to configure and use Azure Update Management Service, compliance scans, and scheduled and recurring update deployment. Next, you learned to deploy disk encryption using Azure Disk Encryption for Windows VMs, which uses BitLocker to provide volume encryption and is integrated with Azure Key Vault to control and manage disk encryption keys and secrets. Then you explored Windows Defender and Microsoft Defender for Cloud. You learned to deploy and configure Windows Defender and how Microsoft Defender for Cloud evaluates potential security misconfigurations and provides security recommendations. Following Microsoft Defender, you learned about securing Azure workloads with Azure Security Benchmarks, which helps secure workloads and services through cloud-centric control areas. Next was configuring and managing container security. Containers are isolated silos for running applications on the host operating system, or OS. They contain only apps and lightweight operating system APIs and services. You learned to configure and manage container security to ensure application safety and integrity, and about Azure Container Instances, or ACI, security recommendations and considerations. Then you explored the Azure Container Registry called ACR for managing container images. You learned about registry hierarchy and purpose, how registries are accessed, security posture, how artifacts and images are named and tagged, monitoring container access and user activity, and different authentication methods for ACR. ACR was followed by serverless compute. You learned how to implement Azure Serverless and address challenges. You discover that serverless computing is a cloud-hosted execution environment that abstracts the management and existence of servers away from you, meaning you're not responsible for setup or maintenance. Next, we introduced you to the Azure App Service. You learned how the Azure App Service works and discovered that it streamlines app deployment and management, improves scalability, enhances security, and reduces costs. Then came an overview of Azure Kubernetes Service, or AKS, a portable, extensible open-source platform for managing and orchestrating containerized workloads. With AKS, you can streamline development and deployment processes and improve efficiency and productivity, from setting up an AKS cluster and integrating Docker images to utilizing Azure's Deployment Center and service integration. After the overview, you discovered how to configure and deploy AKS. You learned about support for virtual networking, how the platform simplifies virtual networking for AKS clusters and network configuration services. You learned about application storage options and core concepts. Finally, you learned to manage access to Azure Kubernetes Service using Azure Role-Based Access Controls, or RBAC. You learned about assigning and defining roles, binding roles, managing access across namespaces, granting cluster-wide permissions, and effectively handling sensitive data using Kubernetes secrets. Congratulations, you're ready for the next steps. It's time to complete the course project, where you'll put your learning into practice. After finishing the project, you'll be able to provide valuable feedback to your peers and receive equally valuable feedback from them. Finally, you'll participate in the graded assessment. Good luck.
Way to go! You have reached the end of the course 3, Implement Platform Protection. You've covered a variety of security components, tools, solutions, deployment methods, strategies, and services for protecting your Azure environment. In this video, we will review some of these resources to help refresh your recall and reinforce your understanding. Let's get started. Week 1 began with the Cybersecurity Defense in Depth strategy, which uses multiple layers of security controls to protect against risks. You discovered that it introduces modern approaches for granular, identity-based security. Next, you explored the client-server model in network technology, the roles of thick clients, thin clients, and hybrid clients, servers as providers of services to network clients, and server models, including request response, peer-to-peer, and perimeter security. Following that, you learned about network security, firewalls, tools to strengthen network protection in Azure, and virtual network security and monitoring for perimeter security. You then learned about distributed denial of service protection, often called DDoS, a collection of attack types to disrupt target availability as a method for securing solutions. We introduced you to Azure Firewall and Azure Firewall Manager. You learned about Azure Firewall implementation, resource protection, built-in high availability, scalability, and how to configure and deploy Azure Firewall Manager. Then you learned about securing solutions using VPNs. You learned about network isolation and security, and creating virtual networks and VPN gateways. Next, you explored the hub and spoke topology. You discovered that the hub is a centralized data security and network management point, and that this configuration simplifies operations. Network virtual appliances, or NVAs, came next. NVAs control traffic flow between segments with different security levels. NVAs include firewalls, routers, load balancers, and proxies. Following NVAs, you discovered how to configure VPN-forced tunneling to redirect internet-bound traffic to on-premises locations via a site-to-site VPN. Then you learned about peering. You discovered you could directly connect Azure virtual networks using virtual network peering, and how you could choose between virtual network peering and VPN gateways. You wrapped up week 1 with an exploration of Azure Functions, networking options, and Azure Network Virtual Appliances firewall architecture. Week 2 opened with Network Security Groups, or NSGs. You learned about the roles of NSGs, providing advanced security for virtual machine or VMs, and how to deploy and configure NSGs. Then you learned about creating application security groups, also called ASGs. With ASGs, you can configure network security as a natural extension of an application's structure and apply security policy at scale. Following ASGs, you learned how to configure service endpoints. Service endpoints enable virtual network private IP addresses to reach the endpoint of an Azure service without a public IP address. Next, you explored Azure Private Link, which enables access to Azure PaaS services and Azure-hosted customer-owned services over a private endpoint. Then, you learned how to implement and configure Azure Application Gateway, which encrypts data traversing the network from users to application servers, protecting your perimeter. You learned about front-end port, listener, and back-end configuration. Next, you learned about the Azure Web Application Firewall, or WAF, a centralized cloud-native security platform to protect web applications and prevent attacks. After WAF, you learned about Azure Front Door, which routes and manages web traffic, ensuring peak performance, instant global failover, and high availability. As week 2 concluded, you explored Azure ExpressRoute, which establishes a private direct link from your WAN to Azure, ensuring secure, fast, and consistent communications. You began week 3 learning about host security as part of your defense strategy. You explored securing Azure virtual machines, or VMs, private network security, security management, threat defense, and layered infrastructure protection. Then you learned about enabling endpoint protection. You learned to use Microsoft Defender for enterprise network endpoint security to prevent, detect, and respond to threats. Next, you learned about privileged access, including defining a privileged access strategy with root of trust and deploying privileged access workstations, or PAWs. You discovered you could use root of trust to ensure the most secure conditions, and that PAWs are hardened, locked down workstations providing high security assurances. Then you explored creating virtual machine templates using the Azure Resource Manager. A virtual machine template is a master copy of a VM used to deploy multiple VMs, ensuring consistency and standardization. You also learned about enabling and securing remote access management with Azure Bastion. You learned how to connect to and sign into a Windows and Linux-based VM, and to use Azure Bastion for remote access management. After that, you explored update management and scheduled updates. You learned how to configure and use Azure Update Management Service. You also learned about compliance scans and scheduled and recurring update deployment. Next, you learned to deploy disk encryption using Azure Disk Encryption for Windows VMs, which uses BitLocker to provide volume encryption and is integrated with Azure Key Vault to to control and manage disk encryption keys and secrets. Then you explored Windows Defender and Microsoft Defender for cloud. You learned to deploy and configure Windows Defender and how Microsoft Defender for cloud evaluates potential security misconfigurations and provides security recommendations. Following Defender, you learned about securing Azure workloads with Azure Security Benchmarks, which helps secure workloads and services through cloud-centric control areas. Next was configuring and managing container security. Containers are isolated silos for running applications on the host operating system or OS. They contain only apps and lightweight operating system APIs and services. You learn to configure and manage container security to ensure application safety and integrity, and about Azure Container Instances or ACI, security recommendations and considerations. Then you explored the Azure Container Registry or ACR for managing container images. You learned about registry hierarchy and purpose, how registries are accessed, security posture, how artifacts and images are named and tagged, monitoring container access and user activity, and different authentication methods for ACR. ACR was followed by serverless compute. You learned how to implement Azure serverless and address challenges. You discovered that serverless computing is a cloud-hosted execution environment that abstracts the management and existence of servers away from you, meaning you are not responsible for setup or maintenance. Next, you are introduced to the Azure App Service. You learn how the Azure App Service works and discover that it streamlines app deployment and management, improves scalability, enhances security, and reduces costs. Then came an overview of Azure Kubernetes Service or AKS, a portable, extensible open source platform for managing and orchestrating containerized workloads. With AKS, you can streamline development and deployment processes and improve efficiency and productivity from setting up an AKS cluster and integrating Docker images to utilizing Azure's deployment center and service integration. After the overview, you discovered how to configure and deploy AKS. You learned about support for virtual networking, how the platform simplifies virtual networking for AKS clusters, and network configuration services. You learned about application storage options and core concepts. Finally, you learned to manage access to Azure Kubernetes Service using Azure Role-Based Access Controls or RBAC. You learned about assigning and defining roles, binding roles, managing access across namespaces, granting cluster-wide permissions, and effectively handling sensitive data using Kubernetes secrets. Wow, you have covered a lot. You have made it to week 4. Well done. You are ready to complete the course project where you'll put your learning into practice. You'll have a chance to provide feedback to your peers and receive feedback from them, an invaluable experience. Finally, you'll participate in the graded assessment. You've got this. Good luck. Imagine the excitement of emerging victorious in a game or competition. Isn't that an indescribable feeling? Winning provides a sense of achievement that fills us with pride. Similarly, the graded assessments in a course provides an opportunity to evaluate your mastery of the concepts or skills you learned. It also allows you to experience this sense of accomplishment and how your dedication and efforts bear fruit through a favorable score. Hello, and welcome to the video about the graded assessment. In this video, you will learn important details related to the graded assessment at the end of the course. You have learned all the concepts covered in the course, implement platform protection. You might have completed the hands-on exercises to strengthen your learning. It is time for the final graded assessment, which will test your understanding of implementing platform protection, which includes deploying and configuring various security strategies. The graded assessment evaluates your knowledge and understanding of the course content. It provides valuable feedback on your exam-taking skills, such as time management and test anxiety, that you can apply to your exam preparation strategy for the AZ-500 certification exam. The graded assessment also provides valuable insight into areas you need to improve. There may be several aspects of the assessment that you're curious about, including the number of questions, how the scoring will be done, and the assessment duration. To better understand these details, let us dive deeper into the specifics. What types of questions can you expect in the final graded assessment? The graded assessment consists of multiple choice questions. You will often be presented with a scenario that you must carefully analyze to answer the question correctly. You will notice that the question formats are similar to the knowledge checks you have completed throughout the course and the module level graded assessments. We have designed this question format to help you feel more at ease with the type of questions commonly found on the AZ-500 exam. Each question in the graded assessment carries a value of 1 point, with a total of 20 points available for you to earn. It is important to note that there is no negative markings for incorrect answers. Even if you are unsure about a particular question, it is still worth attempting to answer it to the best of your ability. Do not hesitate to make an educated guess if needed. In addition, the graded assessment allows you to navigate back and forth between questions and modify your answers before submitting your final responses. This feature allows you to review your work and make any necessary adjustments to ensure you are fully satisfied with your answers before submitting the assessment. It is important to note that you must achieve a score of at least 80% to pass the assessment. This means that out of the 20 questions, you will need to answer at least 16 correctly. It is important to take your time and read each question carefully before selecting your response. What is the assessment duration? To ensure you have ample time to carefully consider each question and provide thoughtful responses, we have designed the final graded assessment to last 1 hour, giving you approximately 3 minutes to answer each of the 20 questions. Unlike the AZ-500 exam, there is no time pressure to complete the assessment within the stipulated time, as no timer will stop you from continuing after the allotted time has passed. Nevertheless, we strongly advise you to complete the assessment within 1 hour to practice for the speed expected in the AZ-500 exam. As you prepare for the graded assessment, remember that you can still brush up on any key concepts you may need to review. Take advantage of this time to refresh your knowledge and ensure you feel confident in understanding concepts such as defense in depth strategy, distributed denial of service protection, Azure Firewall implementation, and using VPNs as part of your perimeter security strategy. You can also review differences between virtual network peering and VPN gateways, creating user-defined routes and network virtual appliances, network security groups, and Azure application gateways. It's also a good idea to revisit topics on deploying a web application firewall and managing Azure Front Door. To prepare effectively for the AZ-500 certification exam, we recommend that you recreate a similar environment for this graded exam. This includes finding a quiet space to take the exam and closing all other applications and browser pages to simulate the exam conditions. You may remember that for the AZ-500 certification exam, you have the option to take the exam at a test center or from the comfort of your own home. Here's wishing you all the best for the final graded assessment of the course Implement Platform Protection. Congratulations! You have completed the course Implement Platform Protection. This is the third course in a series of 7 courses in the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. This course is part of the preparation for the AZ-500 Microsoft Azure Security Technologies exam. The content you learned in this course maps to the secure networking and the secure compute, storage, and the database areas of the exam. Recall that you can expect 20 to 25% of the exam questions from secure networking, which will test your knowledge of network security principles and best practices, such as configuring network security groups and deploying Azure firewalls, and another 20 to 25% from secure compute, storage, and databases, which will test your knowledge about securing Azure virtual machines, managing Azure Key Vault, and disk encryption. By learning the content in this course, you have prepared well to answer questions on perimeter security, network security, and host and container security, serverless compute, and storage. In this course, you learned about the concepts and features related to perimeter security. The course covers core security concepts and approaches that form part of a defense in depth strategy. You explored how to configure a distributed denial of service, frequently referred to as DDoS, and deploy an Azure firewall. You also learned to configure VPN-forced tunneling and create user-defined routes and network virtual appliances. Next, you learned about the features related to network security, including network security groups, also called NSGs, and application security groups, including ASGs. You learned about different features for securing web applications, including Azure Application Gateway, Web Application Firewall, also called WAF, and Azure Front Door. Finally, in this course, you learned about host and container security. You learned about deploying privileged access workstations and creating virtual machine templates. You also learned about enabling remote access management, configuring update management, and deploying disk encryption. Last but not the least, you learned about Windows Defender and Azure Security Benchmarks. You have now moved one step closer in your preparation for the AZ-500 exam. Remember to refer to the Microsoft website to view the latest updates on the AZ-500 exam. Before you sign off from this course, you will watch a video on the next steps that you will take to proceed further in this training program. See you in the following video. You have made it to the final video of Implement Platform Protection. Take a moment to acknowledge and celebrate this accomplishment. Your next step is to move to the next course, Secure Your Applications. This is the fourth course in the series of 7 courses that prepare you for the AZ-500 certification exam. The Secure Your Applications course relates to the skill area, compute, storage, and database. The course covers securing applications using Microsoft solutions such as Azure Key Vault, Microsoft Identity Platform, and Azure Active Directory, frequently referred to as Azure AD. Let's explore what concepts and aspects will be covered in the course. In the fourth course, you will learn about the purpose of Azure Key Vault and the guidelines for using Azure Key Vault. You will also learn about configuring Key Vault access and certificates to secure access to your applications, identities, and data. Next, you will learn about securing applications with the Microsoft Identity Platform. The Identity Platform helps you build applications your users and customers can sign in to using their Microsoft identities or social accounts. You will learn about configuring and monitoring secure access to an application with the Microsoft Identity Platform. You will also learn how to use Azure AD with single-page applications. You will also gain an understanding of key considerations for web apps that sign in users and call APIs, and with daemon and non-interactive apps. Another key concept covered in this course is application security with Azure AD and other Microsoft tools. You will learn about app registration and the different types of permissions supported by the Microsoft Identity Platform. You will explore Microsoft Graph services and learn how to configure Microsoft Graph permissions. You will gain an understanding of managed identities and how to configure and enable managed identities. You will also learn how to configure and deploy web app certificates. Who doesn't like to try out things themselves? The Implement Platform Protection course provides you with practical skills through hands-on exercises. For example, the course provides step-by-step instructions on creating a key vault, creating and configuring single-page applications, creating server-side web apps that sign in users and call APIs, and creating an Azure Active Directory tenant and registering an application. In this video, you learned that your next step is taking the fourth course in this training program, Securing Your Applications. Are you ready to take your Azure security skills to the next level? See you in the next course.